All right. Hello, everyone, and welcome to this conference, which I think is a decisive and essential one. It was originally intended for the people working in the digital sector like I do, but in the end, I made it a rather accessible one, except for the very last part before conclusions and kisses goodbye. We're gonna talk about a few things that are critical right now. First, we're going to take some distance to what Earth is, what the universe is, what matter and energy are. Then we're going to see how a species has evolved in the direction that we're taking at the moment. Then we'll see the consequences of our actions and how we are shaping the biosphere. Then we'll talk about solutions against the harm we're doing to it. And then we'll try to focus on a detailed part of this problem, namely the digital world. We'll finally try to discuss what we can do as individuals, companies, structures, then as digital workers. This conference is about 6 hours long. I'm deeply sorry, not sorry, but as you'll see, there's no way I can explain all that within less time. What you're gonna see is the result of approximately 6 months of work from a non-specialized individual, which I am. So if you don't have time, considering how important the topic is, I suggest you come back later to finish it. It will be live on probably Twitch and on replay on YouTube, so yeah. Considering the low and simple graphics of most of this video, I will leave it to 180p quality so that you can read most graphics, but the final weight should be pretty reasonable. Needless to say, we're going for quite a little journey. So let's go. All right, so first I have to warn you, before we go any further, and this is important, if you haven't investigated by yourselves about climate change, materials shortage, and the future of mankind, you'll be shocked and desperate through this talk. Even though I'll try to conclude with optimistic perspective, this conference is highly disturbing and I don't recommend watching this with children under 7-8 years old until you decide what to do with them and how you tell them everything. Some footage and images are definitely not suited for younger and sensitive audiences, especially after the first part. So now you've warned, it's time to move to the people around you away, and you think they're concerned, just to tell them to go to another room or something. First of all things, a few words about me so you can reach out to me after this conference. So should you have questions, note corrections, or simply the will to discuss, the manager is always in. My name is William Pinault. I'm what I would call a ninja. I'm a web architect, lead developer, public speaker, got 15 years in experience in the sector of computing science, essentially in the web. I work right now in a NISN, that's called Neosoft in France, in Limoges, in the middle of France, and I'm a contributor of some open source projects. I'm working as a project manager, technical responsible now, architect and developer, so you can find me on GitHub, GitLab, Twitter, anything. I'm a photographer and musician, so you can find me on Instagram, YouTube, Flickr, 500px, SoundCloud, whatever. And if you're interested, I play also a lot, which is not the topic here, but I play Magic the Gathering on Arena, Apex Legends, and many other games. You can also find me on Twitch when I do some gaming, and Facebook and Snapchat, whatever, if that's your thing. So first, why are we here? What's the purpose of this talk? Well, it's been a few months that I've been, studying heavily this topic, as it's out of my spectrum of skills. I'm doing this because I realized at some point it's how important this topic was, and I can tell you, what I can tell you is that we progressively learned over the decades that something is going wrong. We all know that something is wrong right now, but we cannot tell exactly why and how it's going wrong. So I realized that we don't really know how bad it's going wrong. We keep saying this over and over. We keep repeating facts, numbers. Sometimes we repeat them the wrong way. And, anguish can be powered by ignorance. Until we get interested in, which is what I did a few months ago. So let's go through a funnel from our universe to the components of an atom of Earth. And also one last preliminary warning before the 6 hours of talk. Considering how critical the topic is and how decisive it is that the population gets informed and can access information, I thought it'd be a pretty good idea to do my part, which is the purpose of this talk. But I'm just a digital worker doing that part of a job. Not more, not less. So I hope you'll forgive me if I just provide with any information that is approximative or poorly explained, for which I do apologize in advance. But keep in mind that I'm not an engineer from the world of energy, climate, materials, or physics. I'm not a scientist either. You might know about those concepts, what we called ultra-crepidarianism, means that you publicly speak without any prior specialization, training, education for a specific domain, so that you speak without mastering this domain. This comes from Latin, from an old sentence that says the shoemaker should only speak about making the shoes. This cognitive bias, which is relatively hard to fight, hello COVID-19 crisis, improvised specialists, for instance, this bias is also named after the works and studies of two American psychologists at the end of the 20th century, named David Dunning and Justin Kruger, known as the Dunning-Kruger effect. So I have tried a lot to provide with all the sources used at the very end of this conference. We got 6 pages with all the sources. You can just pause and you will get all of them. I can provide them with links if you want to not copy them visually, which is not pretty convenient. And I've used as many official and various sources as I could, but I might have missed some of them. For that also, you will forgive me. So let's dive. Let's dive in the infinite perspectives of the ethers that gave birth to us, to life, to everything. You might know this video as Cosmic Eye from 2018, which has millions of views on YouTube, and I thought it was the best way to start this whole conference. And I just cut the sound, I think. Yeah, I did cut the sound. So this is a pretty convenient way to take a perspective on what you are, what we are, and how large is what we're supposed to know about our universe. And this is something most of the people know about, the planet, the planetary system. Everything seems pretty known to us at this point. We've got a pretty good picture of this. We got a very good picture of that too. Then it starts being a little blurry. And as you know, you just see now the scale of things that we are considering in our universe and how far this goes, and how little we are and how big we are at the same time. We still got no dimensional vision of whether we are infinitely small or rather close than small or large. We don't know. Everything seems to be infinite. So this is right now what you see, the extent of what we consider we know about the universe. And then the video goes back and you go to the atom size and the subatomic size. This video can give you a perspective on space, and this here, I have my laser pointer, this is a perspective on time. As Wikipedia quotes from Joseph Silk, I'm going to quote it, about this person: the Big Bang Theory is the prevailing cosmological model explaining the existence of the observable universe from these earlier known periods through the subsequent large-scale evolution. The model describes how the universe expanded from an initial state of high density and temperature and offers a comprehensive explanation for a broad range of observed phenomena, including the abundance of light elements, the cosmic microwave background, the CMB, radiation, and large-scale structure. You see, when counting the time our planet takes to go back to a given position at the closest star, measured at the tropics, we get a time. We call that time a year. And though we have tens of different definitions of a year, we conventionally use the tropical year, which makes 365 days, 5 hours, 48 minutes, and 35 seconds. Or multiples of the second. And the second is our base time unit, formerly defined from Earth's movement, and now defined as being equal to the time duration of 9,192,631,770 periods of delayed radiation, corresponding to the transition between two hyperfan levels of the fundamental unperturbed ground state of the cesium-133 atom, which is a hell of a good definition for a second. Basically, it's what you called a second. Within a fraction of that second that we can even perceive, because it was infinitely small, the universe totally changed and started cooling down and expanding. From radiations to particles to recombination to microwave lights to extinct matter to shapes, stars to asteroids to Earth or planet to molecules to self-organizing molecules to biological activity, self-sustaining super complex molecule which we essentially call life. Life, yes. That very absolute, improbable thing which includes us. Against all the odds, one chance in billions of billions and billions for no reason, and after all this chaos, there we are. And you ended up using your time listening to me. You must be really someone special, right? So, on May 25, 2011, astronomers unveiled the most complete 3D map of the local universe, which means it reaches out to a distance of 380 million light years ever created. Taking over 10 years to complete, the 2MASS redshift survey, the 2MRS, is also notable for extending closer to the galactic plane than previous surveys, a region that's generally obscured by dust because of the shape our Milky Way is. This is so far, what you're seeing right now, the best map of the galaxy we could find. And that's, so far as we can reach. Beyond those points, beyond this outer disk here, there's no chance we get to see it at the moment. It's simply too far. Think about it. You take a super fast car and you reach the blazing speed of 299.9 kilometers per hour. Wow. Then you go 10 times faster. That's more than twice the world record speed for a car established at 1,227 kilometers per hour. Then you go 10 times faster than this again. That's 3 times faster than the fastest plane ever, topping Mach 9.8, which is around 11,000 kilometers per hour. And it's about the record for the inhabited rocket speed through space. Around 40,000 kilometers per hour, and it's exactly the round trip around Earth in 1 hour. If it still goes 10 times faster than this, at 300,000 kilometers per hour. On November 2018, the NASA Parker Solar Globe probe, peaked at 530,000 kilometers around the sun. That's the fastest object ever made by humanity ever. This is beyond anything you could conceive or imagine. 530,000 kilometers per hour. Just imagine the blazing speed of this probe. Let's push things even faster. You take the same time that this thing goes, but instead of hours, you take seconds. That's 3,600 times faster, and that is the speed of light. And at that incredible, theoretically maximum physical speed, what we think right now as physicists, even light took 46 billion years to arrive to us. 46. What light we barely detect from these areas happened up to 46 billion years ago. That is our reach right now. That's the maximum we could go to so far. Inside that whole continuous explosion that we are in, that we call the universe, not everything is homogeneously scattered within matter. Huge piles of matter are stacked into noticeable areas. At the extreme edges of what we can perceive, we count the largest ones of these heaps of matter, superclusters. Of course, if we see in all directions, ours is right here in the middle. This is our supercluster. And our supercluster is what we perceive as the center of our known universe. And that is a supercluster. Just take a look at this animation for a minute. By the way, I just recovered from a cold, so my nose is still a little filled. It's not really completely empty. My sinuses are not ready for that yet, but I'm still trying to do this conference. So what you're seeing here is a three-dimensional model of, as you saw on the right, what is called the Laniakea watershed. This is a supercluster movement of galaxies within it, because galaxies are moving at a speed you don't even have any idea of. And as you can see here, we're trying to get a multidimensional model of this one in particular. And this one in particular is our supercluster, is what I showed you on the last part of the map, right in the middle of what we perceive. This is what we see. This is not actually any supercluster, this is our supercluster. We barely took a few points on the last map, a few points, and this is Laniakea. Is how it chose to name it. The name Laniakea means immense heaven in Hawaiian, from Lani, heaven, and Akea, spacious, immeasurable. We gave its name in 2014, which is yesterday, basically. After months of research and modelization, as you saw in the previous video, it's our super neighborhood. If the observable universe that we saw last slide was Earth, this could be a little country. It's somehow expanding, dispersing, and likely to change and exchange galaxies it contains with other neighbors superclusters, as you see on the edges here. By the way, if you think about that point here, right in the middle, that seems to attract the lines you're right. We call that anomaly the great attractor. The lines on this schema, which is absolutely not a photo but a modelization, represent the redshift or blue shift, which is basically measuring waves of elements, so we can think of them moving away from us or getting closer to us. Therefore, we get their displacements. This seems to have an influence on millions of times the volume of the galaxy. So if you've been worried about black holes, this right here could be the high-level boss for black holes in your head. And it's generally thought that there are black holes right in the middle of the galaxy if you want a point of reference. And all these points here are not stars. I mean, there's stars into them, but each of these points here is what we identified as a galaxy. And inside all those superclusters, there are groups, local groups of galaxies. Yes, that is our local group. Which one is a photography here? Made of several galaxies, mostly the Milky Way and the Andromeda galaxy, which is our neighbor galaxy. We don't know exactly all that's inside of it, and some part of it is already impossible for us to observe, as I told you. I won't dive into telling you how we can see which we cannot see, but that's absolutely incredible. And this galaxy, this local group here, has a total diameter of roughly 10 million light years, which is 9 times 10 power 22 meters. And it has a total mass of the order of twice 10 power 12 solar masses, which is 4 times 10 power 42 kilograms, which is hell of heavy. And inside this local group you find galaxies. But what's a galaxy? What inside of it? Well, a galaxy is a gravitationally bound system of stars, stellar remnants, interstellar gas, dust, and dark matter. Galaxies range in size from dwarfs with just a few hundred millions of stars to giants with 100 trillion stars, which is 10 power 14 stars. Each orbiting its galaxy center of mass. We give a name to ours, the Milky Way, which is what you see right now on the slide. And inside this galaxy there are between 100 and 400 billion stars, and at least that number of planets too. The solar system, our system, is located here, in a radius of about 27,000 light years away from the galactic center, on the inner edge here of what we call the Orion Arm, one of a spiral-shaped concentration of gas and dust. Inside that system, 8 planets that orbit around one star, 5 dwarf planets, 181 moons, and so far 552,894 asteroids around us. And 40 billion years later, here we are. This is us, all of us. I strongly recommend that you read Carl Sagan's speech, The Pale Blue Dot, in 1994. He gave his speech in 1994. It's brilliant and simple to take 5 minutes to think about Earth. To us, this is everything. Every resource we have is here. Apart from a little dust, some super rare asteroids, apart from cosmic radiation and light, which mostly comes from the sun, it's all here. Nothing else. And those resources on Earth didn't cost anything to us. Stars are made of what is enough to create all the chemicals elements on Earth. And a fantastic, improbable chance made of correlation of event and facts, the distance between our planets and the different stars and the types, the presence of water, the fact that Earth is a telluric planet, it's solid, the presence of greenhouse effects thanks to vapor in the air, etc. In 1961, astronomer and astrophysicist Frank Drake wrote this equation to summarize an approximation of all the concepts and criteria we would expect to find life outside Earth in our universe. It's purely speculative and it can be criticized, and it is criticized. And this supposes that we can find another place where life evolved up to a point they could communicate with radio emissions. The question is, can we? The Drake equation here you see is N equal R times Fp, Ne, Fl, Fi, Fcl, where N is the number of civilizations in our galaxy with which communication might be possible, given in another way similar to what we can communicate with. So another civilization, another planet, okay? Which should be in what we call our current past light cone, which is a fundamental notion in the theory of relativity. And here, R, here, is the average rate of star formation in our galaxy. Fp is the fraction of the stars that have planets. Ne is the average number of planets that can potentially support life per star that has planets. Fl, the fraction of planets that could support life that actually develop life at some point. Fi, the fraction of planets with life that actually go on to develop intelligent life, which is what we call civilization. Fc, the fraction of civilizations that develop a technology that releases detectable signs of their existence into space, which we are trying to do ourselves right now. And L, the length of time for which such civilizations release detectable signals into space. Because yeah, if we just missed them, or if they missed us, it's too late. The last three parameters are very difficult to estimate. In fine, the more n is below 1, the less likely we can find another world like ours. The more n is greater than 1, the more likely we are. Drake proposed values, ended up with n equals 10. 10 possible civilizations in the whole Milky Way. And the numbers are very discussed. That makes a very, very unlikely good results. In 2013, Sarah Seeger, Canadian astronomer, proposed a modified version to estimate inhabitable planets in our galaxy only. The commonly discussed results end up with 0.45 planets here as n in our whole galaxy. And we just saw how large this galaxy is, right? Of course, you can criticize and debate over each number, but you get the idea. In other ways, there is very, very, very unlikely any other life like ours on a planet like ours within our technological reach that we can communicate with that could potentially help us. Which means there is not anything else for us. Everything we have is here. Our planet is all we have. We might achieve more secure, reliable, powerful, stronger, faster space travel in the years to come, but very unlikely will we do a sufficient leap before 2050. And yet, nothing proves us that this is the correct way to go. The vast cosmos might be at our disposal, but burning our resources faster to try to get more about of Earth doesn't really seem clever. Actually, we did so. For instance, we spent $100 million with a Japanese project called Hayabusa 2, and Hayabusa 2 in 2020 landed a probe on an asteroid, which helped us a lot study about it, and brought back to Earth 5.4 grams of asteroid matter, which makes the ton of asteroid material cost $777 billion, which is quite a lot. By the way, that's a picture of the rover landing on the asteroid. And that is a mission Apollo 12 propeller rocket ignition. In 1969, Apollo mission 12 brought back 34 kilograms of rock from the moon. The cost, calculated with inflation, was around $3.2 billion, which makes it cost around $94 billion per ton of moon material. And those missions consumed way more material than what they brought from other solar items. The purpose was also scientific. It was not mining, of course. But as you see, let's just say that everything we have at disposal so far is already around us. We cannot bring anything back from space at decent costs. And if you were to qualify our resources, well, I'd say it's easy. From a strictly historically human point of view, you can think of them as what we find. From a scientific point of view, resources are, well, different. This is a story that's being written right now. We don't know. We haven't reached the end way from that. What we think as something that exists, matter, is usually what we call matter. Artists, physicians, philosophers all try to think since the dawn of man about what matter is. But matter itself is not enough. It's changing, it's moving, it's reshaping, it's disappearing. It's not inert. There's something inside of our universe that's not visible, but that makes us alter the reality state of matter. We call that energy, which comes from Latin and therefore from the Greek energia, which means strength in action. But as you see on this graph, there's only 5% of matter and therefore energy in our universe that we can perceive and interact with. And you see where it comes from. It's really disseminated all around the universe. So what is energy? Well, most of us use this word very often, but never truly try to get its meaning. As long as there was a universe, there was energy. Energy is the ability to do work in a physics way of working. Anything that happens, anything that changes is energy. Work is the ability of changing a state. Energy is the thing we measure from the physics system, which is a predefined ensemble you are observing, to another system or within the system. In that moment, when forces apply, energy is transferred. Yes, transferred. Energy is, so far from what we know, never lost. It just goes from one place to another. And when you quantize the amount of change, you quantize energy. It's everything. It's what animates any of your cells, what we call being alive. It's what makes your cell phone and computer work at that exact moment. It's what makes this signal go from this live or video replay source to you right now. Is what we call communication. It's in wood that looks like it's not moving or anything, but when you initiate a chemical reaction by adding a little more energy, like burning gas, you make all that dead wood cells, which we call lignin, break their bonds between carbon, oxygen, and hydrogen, mostly, and release energy. It's what we call fire. Yeah, you got that. That's a pretty decent but small amount of energy, but between each atom, but it's still energy. That's only for what we would call conventional energy, the one I showed you on the last slide. That's around ordinary baryonic matter. Dark energy is another story, for which we don't have enough time today. It's basically what is responsible for the expansion of the universe. It's an unknown form of energy we are very actively doing research on. We could talk about it for one day, but it's absolutely fascinating, but it reaches the limits of human knowledge, so I guess you guess how far this goes beyond my personal skills and knowledge too, and how far it goes from this talk. So let's go back to energy. There are two ways we find energy on Earth: by manipulating subatomic elements or by manipulating atoms themselves through the use of what we call molecules. Now, about atoms. If you look inside each atom, there's what we call a nucleus and electrons spinning around that nucleus, which is poorly represented by that picture on the right, which is nothing looks like an atom, but it's perceptual, okay? If you are to make electrons move within sufficient quantity from one point with a higher electric potential from another, you create a current of electrons. And this is what we call electricity, which we measure in volts. If you are to break or assemble the bonds between different protons and neutrons inside the nucleus, you will release a tremendous amount of energy. It's what we call nuclear energy. It comes from the nucleus. If you look at your smartphone right now and you were to break all of its atoms at the same time, and all of the atoms that make you right now listening to me, you would probably end up with a gigantic crater of melting matter hundreds of kilometers around you and at several tenths of thousands of Celsius degrees. Yes, there is all that power inside you. Now you can say you're pretty hot. And mass and energy are linked to each other very deeply. In short, things exist because there's energy inside of it, because atoms interact with each other. We have mechanical, electromagnetic, radiant, elastic, ionization, and gravitational energy mostly. To simply explain that in a very bad and critical way, atoms interact with each other, depending on the distance and many factors in 4 ways that you can see on the screen. The one you know the most is the electromagnetic interaction. It's basically what you see with light, the photons, electricity, radio waves like your cell phone uses them, X-rays or magnetism, magnets. Is the only interaction that you can somehow see at your level along with gravitation. Gravitation, on the other hand, is a very, very weak force. As you can see, the strength of gravitation is magnitudes lower. It's just insignificant. It's heavily studied too. You have heard about the experiment that led to revealing the theoretical only until then existence of gravitational waves in 2018-16 with LIGO and Virgo. Gravitation is a natural phenomenon by which all things with mass or energy, including you, planets, stars, galaxies, and even light, are attracted to each other. In 1915, the face of our worldwide knowledge changed in a very extraordinary way. One of the most advancing theories formulated by one of the most brilliant men of all time, and probably inspired by his wife's work too, by the way, Albert Einstein, with the general theory of relativity. In that theory, he describes gravity not as a force, but as a consequence of masses moving along geodesic lines in a curved space-time caused by the uneven distribution of mass. The most extreme example of this curvature of space-time is a black hole, from which nothing, not even light, can escape once past what we call the black hole's event horizon. And the strong interaction is basically what we use with nuclear energy. So far, with nuclear fission in power plants, nuclear fusion in atomic bombs, and hopefully soon in nuclear power plants too, with fusion. We'll come back to that. And then atoms band together to form what we call molecules, more than one atom. They can be simple, homonuclear, like dioxygen, O2, which you're breathing. It's only made of oxygen. Or heteronuclear, like CO2, which is made of carbon and oxygen. And the bonds that links atoms together are made of energy in a way. The more an atom is stable, the stronger the energy bond between nucleons. If you like physics and chemistry, you can still check the works of Lavoisier, Proust, Dalton, and Bohr or Pauli. You'll find out that we discovered all that long time ago. When atoms get excited, the electrons can move from different orbits around them, jumping by quanta. And when you make them react, some interact with each other, and atoms can exchange electrons. Then atoms can be exchanged between molecules, which we call a chemical reaction. Remember school lessons? Yeah, I know you remember this one. And atoms can, in some rare cases, receive additional nucleus elements or lose them, which is fission and fusion. Combustion, fire, for example, is what we called oxidoreduction. Yep, that thing you studied when you were a teenager in school too, and this is what we called exothermic. It generates heat, and it's what we use to mostly get energy from the environment. As simple as this. Alright? So when you put all those things together, this is what mankind uses right now. It doesn't come all from atomic energy. As you see, most of it comes from molecular energy reactions, which is less interesting but works more easily. You know, biomass, coal, oil, gas, hydropower, wind, biofuels, renewable. Everything here is molecular reaction. It's not energy we take from atoms, from nucleus. And by the way, if you just wonder where it comes from, on the previous slide, the strong interaction is what we use with nuclear power plants. Excuse me. This is where we draw the energy in the world, which is basically what we use to stay alive. Without that, we all die, or at the very least, we fall back to living like a few millennia ago, which, trust me, you don't want to experience. As you can see, we've been changing a lot. We come from a world of complete renewable energy sources here until the 19th century. By then, and since the dawn of Homo sapiens, us, we mainly used the only renewable energy we had on Earth, the sun. Sun historically makes everything possible. See, the sun is a star, which means it's a massive permanent thermonuclear bomb that fuses protons and atoms together all the time, up to helium, beryllium, and that generates a fabulous amount of energy. The sun is 1,400,000 kilometers large, which is about 109 times larger than Earth. And it accounts for 98% of the total solar system mass. You can put 1,300,000 Earth inside the sun. A small fraction of its energy crosses space and hits Earth. Remember, the very exact position of Earth around the sun makes life possible, among other things, like the presence of water. A few thousand kilometers away, in any direction closer or further away, and there's no life. Because there are gas around the solid ground of Earth, we have what we call an atmosphere. Inside this, gas can move, which creates winds, mostly due to temperature differential. All that because the sun doesn't hit Earth the same in every place. Our planet rotates, has oceans, mountains, etc. And all that, those factors create winds, our second historical source of energy. So we created windmills. The fun one we use, mostly for very little purposes at first, is gravity, in addition to the sun. Sun enables the cycle of water, from oceans to peaks to rivers to oceans again. So we create water mills. The most historical source of domestic energy we use is woods. We now have little biomass knowledge and we use more than just wood, but decay of matter too. Then, in addition to that, we discovered coal, burning ground coal in ovens. Then we did the same with oil and natural gas and it's just about burning oil in ovens and very soon mobile vehicles, thanks to its inside energy weight ratio. Then we created hydroelectricity with dams. Then nuclear energy plants, atomic fission, at the most fissile and findable atom on Earth's surface, the uranium-225. and also plutonium 240, 244, and californium 254, which only exists on Earth when human people fabricate it again. Then we discovered new ways to create energy sources, the new so-called renewables. New renewables, which they are not really renewable, which say about that, but yeah. And then the new biofuels that come from bacteria, algae, plants, and biochemical conversion processes. And as you know, we kept adding more and more energy sources over and over. And we never stopped using the previous ones. You see, we just added on top more sources of energy. We use that energy for three main purposes: transforming matter, moving matter, and providing electricity for just anything. Electricity is a convenient thing, for it allows transferring energy very far without moving anything. We're moving electrons, but that's the only thing we're moving, not huge piles of matter. Oil is convenient for transportation. It's the kind of energy that contains the most energy mass per unit, and therefore per weight. Nuclear energy is convenient for it emits close to zero pollution, as we saw, and atomic energy is by a factor of million times more efficient than molecular energy like oil or coal, which means you will need a million times more combustible and matter to get the same amount of energy than the one you would just get by manipulating atoms. By the way, the four major accidents with nuclear energy were the Mayak nuclear complex explosion in 1957 in USSR, the core reactor fusion in 3 Mile Island incident in 1979 in Pennsylvania, USA, the Chernobyl core reactor fusion in 1986 in USSR, now Ukraine now, and the tsunami that cut the cooling systems in the Fukushima Daiichi power plant in Japan in 2011. We're not trying to find new ways of getting energy. We're trying solar optimization for houses, for buildings, solar arrays, tidal force, higher wind currents, and living organisms' chemical reactions mostly. There's also a lack of correlation between our daily topics regarding energy we discuss and what we use. You probably didn't know that our world uses that much fossil energy sources. All the things here in the bottom. This graph represents the world consumption, but the data for USA, China, France, Germany, Japan, UK, or any top GDP countries, most consuming ones, would be something that resembles that series with a little variation. So we're trying to replace everything with electricity, because electricity itself doesn't generate that much pollution. It's silent. Its transfer doesn't lose that much efficiency due to modern materials, and it doesn't disturb the environment that much. At worst, we put cables in the air and we use high and super high voltage lines. By the way, a long time ago, the first car which passed 100 kilometers per hour was not thermic. It was not using oil. It was Belgian. It was called La Jamais Contente, the never happy one. And this car was electric. Electricity was way ahead of everything. And also because electric engines are like 3 times faster, more efficient than oil-based motor engines. So yeah, electricity is way better for everything. But we decided to go another way, and mankind took a turn towards something very powerful: fossil energy sources. You see, before the 19th century, the most powerful country, the one with the higher GDP here, was China. Here's a time lapse of that. Let's look at the segment around the 19th century. You see what's happening here? In August 1859, Edwin Drake an engineer, was given the task to drill oil, which was already known from its properties, as deep as his team could beneath the surface. And guess what? He did succeed. He opened the way for what was the greatest energy outburst in the human history: the mass use of fossil fuels, which is petroleum and, in a way, natural gas. Coal was easier to get because it doesn't move. You basically have to dig the ground, and that's all. You lose many in the process because it's dangerous as hell. You can use coal as is, but you can also paralyze it further to obtain what we call coke. Not cocaine, coke. That has nothing to do with cocaine. And then we burn it, which is very efficient and produces a lot of energy. Now, we still use 25 million tons of coal per day. 25 million tons. At that moment, USA economy here, as you see on the graph, made a tremendous bounce. And as you can see, it's only thanks to oil. This is why this country, and then all the others, were historically attached to that energy. A standard barrel of oil contains 159 liters of oil for historical reasons. And now, we use 100 million barrels of oil per day. Per day, you heard me well. 100 million barrels of 159 liters of oil per day. But what about natural gas? Well, it's the same. We use 4 million cubic meters per day. I'm gonna let this animation run to the end. So, as you see here, you understand the power of fossil energy, and in particular, the power of oil. And then you get to realize all the other countries, slowly, one by one, decided to use oil the same way that the United States do. And at this point, you see here, we reached the 1960s. USSR just caught up, and then all the other countries did the same. And if you keep looking at that running graph, this schema here on your screen, you realize soon that the countries that use oil the most are the ones topping GDP. Not for any other reason than that. They are not necessarily the ones producing the oil, but they're the ones using the oil the most. And this is now close to our times, 1970. And as you see, it's going pretty far in the sense of usage of oil. You see? And you realize the power it has now with all the countries we are in. I could just go faster than this and show you that in the end, when you reach our current modern times, you basically catch up on the situation we have right now, the economic situation we have right now. To sum up what it does in global worldwide energy and put that in perspective that we use from a generic breakdown in fossil, nuclear, and renewable energy sources, this, on this scheme here, is what you get. This is our state of the world right now. So you think we are in a world of renewable energies, nuclear energies? I don't think so. This is pretty clear, right? You see that? That is the breakdown of fossil fuels energy we get for everything, including transport. Remember, this is not electricity, this is energy. This is nuclear, and this is the renewables. You see how dependent we are from the fossil energy? And as I showed you a few slides ago, energy is everything. No energy, no civilization, no mankind, no life for most, for anyone. So we chose a few centuries ago to base everything on a common ground that we name economy. The main index to measure economy is GDP. GDP is just everything. It's not the best economy indicator of change, but it's a good overall index of summed value. It's just an index which says whatever you produced or accumulated over a given period. So this graph here, that represents all the countries in the world as acknowledged by the United Nations, and their 2016 link between GDP in abscissa and the energy use in ordinates. Please note, the scales here are not on a regular scale, they are logarithmic scales. On a linear graph, this would even be more compact and linear. So what you see here is a clear link and a correlation between GDP and energy use. The more the countries use energy, the higher the GDP. This has nothing or close to nothing to do with internal politics, history, religion, whatever you want it to be. Your human civilization, your country, is just linked directly to the energy it uses. If you were to sum up all of this and put in a global perspective, you know there's a very clear link. This is also what you could pose with GDP and energy use, not this time through countries and a given specific point, but through several years of time from 1965 here to 2020 for all the countries, for all the world. Okay, this is for the total world. So as you see, there's a regression equation here. This clearly shows that the more we use energy, the more the world develops. But yet, you cannot tell which one is a consequence of the other one, right? And as we saw before, since almost all the energy we used is fossil energy, the emission of carbon dioxide are strictly linked to economy. The exact same way. Why? Because all fossil energy creates chemical products, among which carbon dioxide or CO2, which goes up in the atmosphere as a consequence of such exploiting. So again, progress, civilization is completely linked to energy, which is completely linked to GDP, which is completely linked to CO2 emissions. And if you were to wonder what we do with that energy, here's what we do. If you were to break down consumption between more sectors like this, you can tell energy is used to create materials, which is the industry here, how big and read, transportation, okay, human life, which is residential, and although what's not materials, but what we need as humans, like health systems, insurances, schools, or simply building websites, whatever you want it, you know. And this is where our energy sources go and how they are dispatched, okay? As you can see, industry uses anything. Transportation uses mostly oil. Houses and buildings use mostly gas and electricity. You might be aware of that during winters, Jon Snow. And services mostly rely on offices, which essentially use electricity. That's just a bad way of summarizing things, but we'll see why it's actually bad. Also, one word about electricity. To produce electricity, we only use the principles of Carnot. We create heat. That heat boils water, which creates steam, and then we use the power induced to steam and the volume expands, then we cool it down. By the way, this is why you often have cooling towers next to power plants. This has nothing to do with nuclear energy, or some nuclear power plants don't have this, some non-nuclear plants have that. It just means that you're close to a source of water, most often a river. Which means that depending on what source creates the electricity, coal, oil, uranium, solar panels, the electricity is what people call clean electricity or not. But, as I already started to tell you, spoiler, we have a huge problem. A huge catastrophic problem. You see, hydrocarbons, such as oil, gas, and coal, are formed from the decay of ancient plants and animals. They are used for everything from electricity production, jet fuel, to heating, to medical materials, plastic productions, and chemical feedstocks. Hydrocarbons are organic molecules that consist of hydrogen and carbon atoms. Crude oil and natural gas are hydrocarbon deposits formed largely around the burial of marine plankton, whereas coal is formed from plant matter, as you see here, that accumulates in a gently subsiding basin. This being mostly the consequence of tectonic plates, collisions, and subduction mostly, leading the ground to be buried way deeper over millions of years, up to a point the ground gets really warmer and burns everything slow. That's how those fossil fuels are formed. This is where the word fossil comes from, because it's made from fossils. And this process here takes several hundreds of millions of years to happen, between 2 to 350 million years for oils. And it's continuous, but we dig those way faster than the biosphere recreates it anew, which is why, in the end, the time it takes makes us call it not renewable, which is actually a salvation from us. It looks like a problem. We're gonna have, but as we see, we're gonna face a much bigger problem thanks to that, because of that. You see, now you know that we almost use exclusively fossil fuel as energy sources. You might also wonder why and where we get them and where we get to use them. The problem is that thanks to the high concentration of energy in fossil fuels and due to how easy it is to gather resources, which we never paid anything for, nature just created it the way before Homo sapiens existed, we don't consider energy to be a problem at this time. And nowadays, energy barely accounts from from 5 to 10% of our daily costs, even less if you're really rich, or if you run a company of services that don't really rely on buildings or on transportation. Just like we do in the digital sector, we don't consume that much energy ourselves. Actually, if we don't work in a data center, we don't really know what energy means to us. An average company will not even look at their energy bills. They're not even a topic. So as you can see, energy is everything to us. Everything. It's not a choice. It's physics. It's how the universe works, how we work, and how the millions of machines we created for us work every day. It's what makes us here, sitting comfortably at home in a nice place instead of being destroyed by working in the fields all day. It's what makes us able to travel further than a few tens of kilometers away. It's everything around you. It's everything to us. And yet, we thought we solved that constraint and pay nothing for it in any day. But, you see, for example, the wheels of a car account for barely 1% of a car's weight. But what happens if you remove the wheels? Isn't that 1% critical, more than AC, for example? Your blood represents about 8% of your total weight. My excessive fat, personally, I'm a little fat, represents about the same, according to my body mass index. Which one can I safely remove, blood or excessive fat? You see, the price and the share of things are not related to how important they are. So as you can see here, we emit greenhouse gas with almost everything we do. Mostly CO2, but not only. Methane also in a few other cases. And also by warming the atmosphere, we make water evaporate more, and that creates even more greenhouse effect, because water, vapor, steam in the air is just the number one gas on the planet that is greenhouse effect gas. Actually, everything we do, from using trucks, trains, planes, from making cement, building houses, having industrial complexes, cows, fields, fishing, producing TVs, faucets, tires, fruits, microphones, cutting trees, making steel, pianos, hospital beds, Instagram posts, everything generates directly or not, greenhouse gas in the end. And that is a problem. Why is it a problem? Let me explain. Take a look at this. This is the composition of our atmosphere, which is a 1,000 kilometer thick envelope around a planet. We are usually here at the very beginning, between minus 417 meters, which is the middle of the Dead Sea, the lowest point on Earth, and plus 8,849 meters high, which, as you know, is Mount Everest in the Himalaya mountains in Nepal. So let's say we are on the very left part of this graph. You see, this is the height in kilometers of the atmosphere and the concentrations of gases. Okay, so we are here on the very left area, on the very first kilometers here. We are between here and this first iteration here. You see? If you don't remember your chemistry lessons, that's nitrogen, N2 here. Then that's dioxygen, and then that's argon. And then there's the rest. That's it. Among the rest, there are a few things we are very concerned about, notably water vapor, H2O, carbon dioxide, CO2, and methane, CH4. You may know water because everything that breathes rejects water. Oceans vaporize, creates a lot of water. And we need it to survive. 3 to 4 liters per day, including food water, water you get from the food. Or else you would die. You may know dioxygen, because that's what things that we breathe, that breathe use. Not only us, but everything that breathes on the planet uses oxygen. We adapted to our world, which is why under 18% oxygen, you would start suffocating. You may know CO2, because it's what you emit when you breathe, what everything that breathes emits. What makes photosynthesis, absorbs, and work. Without CO2, there's no photosynthesis. At our altitude here, you see, at the very end left of this graph, atmosphere contains 0.04% of CO2. That's very little, 0.04%. But above 1.5%, you would start suffocating, and above 3% CO2, we cannot guarantee that you will survive beyond 15 minutes. You know that because if you stay confined in a room with no ventilation, you can start having migraines. You know that already. This is CO2, a great origin of migraines along with dehydration. You may know CH4 because it's what causes burp all day while eating grass, but also oil production, wastewater, and many other things. Above 5%, we are in immediate danger of death. 5%. So first of all things, all those gases are directly deadly, directly. But just inhaling too much of them and all the proportions are not that crazy. But as we're going to see, everything we do modifies Earth's surface, climate, and resources. And everything has many direct or indirect consequences. Before going on, there's something I told you a few slides ago. One preliminary question. Where does Earth's surface get its energy from? Here's a revised table from 2017 with the calculated estimates and their respective ranges of errors for the identified sources of energy the biosphere basically gets. The study was focused on United States, so the fourth line here, let's say, varies from country to country, but that doesn't really make a difference. So as you can see here, the energy brought by the sun accounts from 99% of what we get here. Excuse me. So most of the energy we get comes from the sun. You see the percentage. It does the difference we have there's nothing else than the sun that is bringing us energy. All right? So the sun sends energy through space that's been heating our planet continuously since it existed. The sun is a little older than Earth, a few million years older, between 4.55 and 4.6 billion years ago. And here's the major one we all get concerned about, but it's just a major one. We'll see how much more than this problem is, but let's just stop for a few minutes on this illustration here. Comes from NASA. The sun's surface is about 5,500 degrees Celsius, and it spreads its atomic energy mostly through the visible and near-infrared light radiation, 150 million kilometers away, up to us. The Earth has a fragile ecosystem which distributes the heat, mostly received on the equator, because our planet is almost perfectly spherical, towards the poles. The total solar radiance on the ground is about 1,360 watts per square meter. It means, within the reach of your arms, if you have 2 arms, you were to capture all the energy on that surface for 1 hour, you could run a fridge for all day, just within your arms. And the Earth is 510 million square meters. So you see, that is a lot of energy, way much more than we are using right now. But if we kept this energy infinitely, we would all just end up burning and the surface would be hundreds of degrees high. But it's not. Why? Because part of this energy gets reflected back into space, and part of it is radiated back to space from the ground too. Except for a very small fraction, which over the ages, for many reasons, has changed. This small fraction here, as you can see, is due to the presence of some gas in the atmosphere here, which are opaque to radiation and retain it, while being transparent to sunbeams. You see, the sunbeams coming from the top go through the atmosphere to the ground. Part of it is thermal evacuated back to the atmosphere, then beyond the atmosphere, and these gas are very disseminated through the atmosphere. So we usually speak in parts per million, ppm. You already have seen this unit. Only a very small amount of this gas and only a very small fraction of this gas changes, and everything else changes. And that is the danger we are facing right now. The difference between the radiation we receive here and the radiation we emit here as a planet is called radiative forcing. Cool. What is our radiating forcing at the moment? This is a graph of average ground temperature variation on Earth, so directly linked to radiative forcing. From the end of a historical era we call the pleistocene, which leads to the current era we are in, which we name the Holocene, up to this day on the right, where we try to call the Anthropocene, because we are mostly responsible for what's happening now on the Earth. Unfortunately, the surface climate on Earth is going through cyclic and recurring warming and cooling eras. This is totally variable, and we haven't modelized the reasons for that completely so far, even through Fourier systems. It mostly comes from astronomic considerations, where the other celestial objects have an influence on Earth position, orbit, inclination, nutation, etc. We're not playing in a game with 2 people, the sun and us. We're playing in a game with at least 9 people and maybe more. But when you see on this picture, I think it's both pretty clear and unprecedented. We are going here on the right side way higher than the expected and faster than any previous event during anything we studied or found so far, and not in the expected direction. You see, we should be in a cooling era here, but we're not. In the end, we just bumped so high into warming. That's a huge difference. And this comes, in other way, this goes towards a huge climate change that takes the form of a global warming. This comes from what we call Earth's energy budget, which is the difference between the energy Earth receives from outer space and the energy it radiates, that I showed on the last slide. And what happens if we keep going the same way as we currently do? Well, see for yourselves. These are different scenarios by the IPCC, the Intergovernmental Panel on Climate Change, published. This is an international body created by the United Nations to watch over climate, the IPCC. As you can see, within 70 years, we'd already be facing around 5 degrees Celsius raise on the average, directly linked to the main culprit from that race, greenhouse effect gas, which is almost exclusively CO2. Remember, there are other concerns, but this one is the one we try to stay focused on. You see, this is what would happen if we kept doing the same thing. Concentration of CO2, the global mean surface air temperature, the global mean surface air temperature here with, what we expect it to be between different scenarios, from the most pessimistic to the most optimistic one. Whatever we do, we are on the average about 5.9, let's say just 5 degrees Celsius change. And if you think we are on our way to slowing those emissions, well, think again. These are models taken into account from IPCC report, Long-Term Climate Change Projections, Commitment and Irreversibility, chapter 12. As you can see, whatever model you take, if you think that those curves are going down, you need to see an ophthalmologist. This is what we are doing right now. We are just consuming more and more energy and releasing more and more CO2 in the atmosphere. So we are going right now towards the most catastrophic scenarios. And that's not everything about it. We should be decreasing the amount of CO2 emissions, but we are increasing them instead of decreasing them, knowing that this is going to a huge problem on Earth. But that's not about it. If I just was to say decreasing, which I just used, you might think if we stop, then those curves here will go down to 0, right? Well, think again. Carbon dioxide is a very stable molecule, as we saw earlier what that means. It means the bonds between the atoms are very strong, and there's nothing that is going to break them. And we spend our time oxidizing carbon forming carbonaceous fuel. In other words, we keep creating more and more CO2. That's how we divide energy sources, those based on carbon use and those based on nuclear knowledge or renewables like sun, wind, tides, gravity, etc. We saw that. So, about the carbonaceous energy, whatever you do, it's about burning that energy, conduct and channel heat to mostly boil water due to water properly activating turbines, etc., which contain an alternator, which we call a turbo generator, etc. In the case of dams, water comes from natural gravity, it falls down, and in other cases that use water, it navigates through pipes to reach the generators, usually gets sent back to the natural source of water after being cooled down. Okay? But every time we burn something to generate energy on Earth right now, we release carbon in the atmosphere. CO2 is the main gas we focus on. There are actually, like I said, many more chemicals produced from the equations and conditions of combustion, but that's not our topic here. And this gas remains in the atmosphere for a very long time. We have no way to make it come back to ground, to the surface, and trap it down to the ground or the oceans again. The only thing we can do is wait and have trees. So far, the best way we know for Earth to recapture CO2 is found in the living base chemical reaction from vegetation, which, as you remember, is called photosynthesis, which is about using photons and matter to synthesize different matter, photosynthesis, mostly CO2 plus H2O, water, to generate O2, which is why we live in symbiosis with vegetation, because they produce the O2 we need to breathe. 2/3 of the photosynthesis and carbon capturing capacity comes from trees. There are an estimate 60,000 to 100,000 different tree species on Earth. Actually, as you can see, if we wanted to have simple atmospheric concentration fall by 50%, okay, 50%, if we just stopped now, let's say we all stop now emitting carbons right now, we need to wait around 70 years here to have this concentration fall back to 50%. And then we would need 1,000 years to eliminate almost 80% of it. And if we were to wait for 10,000 years, which is a heck of a long time, we wouldn't be almost able to eliminate 100% of it. In other words, you'll never be able to live in the year 2021 or 2022, the climate that you will have lived in 2021 or 2022. And so is it for the next 10 years at least if we stop right now, and more than 10 years if we stopped right now and we wanted it to go back to normal. This illustrates the absolute emergency we are in. We are not acting for future generations. We are acting for ourselves already again, but for every generation after the generations and generations and generations after our children. It just goes, as you see, it's going so far in time. This is a heck of a challenge we're facing. If you were to imagine what we're changing, picture this. These, left and right, are two simulations based on many calculations of the consequences of such climate change. On the left, you have the current minimal scenario, in which everyone in the world would make their best to limit global warming under +2 Celsius degrees over the Earth's supposed temperature. On the right, you have the worst scenario ever calculated. This is the equivalent of what we call business as usual, and it will represent the 19th percentile of no changes in any scenario, which means we keep up the current pace. Remember, these estimates are dated 2014, and the next IPCC report is expected for 2022, which is next year. By the time I'm making this, by the time I'm talking, it's the end of 2021. On top, here, you have ground temperature measure increase in Celsius degrees. As you can see, +4.9, +5 degrees on the average would mean up to 12 degrees average temperature on the ground on an average, which would lead to way more than this on peak temperatures. Now picture this, where you live. Imagine the current top ever recorded temperature, the top high temperature, and you add, like, let's say the double, 15 more Celsius degrees. Then add the average on this map every day on the hotter season, which means you would go from 35, 40 to 50 to 60 Celsius degrees. Below is the precipitations, what we call hydrometeors, annually on the average. When the temperature rises, the water on the ground vaporizes much faster. As a consequence, the atmosphere gets much more humid. This means that rainfalls, snow, mist, etc. would be redistributed first, and they would go on specific places, as you can see, for real complex reasons I won't detail here. You see, but they would just go to very, very different reasons, very different places on Earth, you see? The darker places here are negative, and the lighter places are positive. Now, right in the middle here, as you see, there's a band here. It looks like a band. It's what we call the equator, an imaginary line halfway between South and North Pole. Close to this latitude, the position from north to south on Earth, both temperatures and humidity would rise in extreme ways. And as you can see, this spreads quite a lot. Be reminded that we are homeotherms beings, which means any deviation from a single degree in our internal body temperature is a danger. 3 of them, in any way, is lethal. 3 degrees away from the 37 degrees you're supposed to be alive with is lethal. 34 to 40. When our homeotherm bodies face excessive heat, they evacuate as much as they could through breathing and sweating, and also heat radiation and conduction, but last resource, but they don't really account for a lot. But this is why we saw people standing almost naked against concrete grounds during the 50 degrees heat waves, which was their last chance to survive before death. But when the air also gets wetter, the critical temperature threshold becomes lower and lower. It's usually around what we call 35 degrees Celsius TW, which is what we call the wet bulb temperature. It's a composite index that uses both moisture and temperature, but can become way less. Under this region, it's going to skyrocket way further than this. In other words, with these predictions, with these calculations, without permanent cooling in these regions, any of us, me, you, whoever you want it to be, would be dead. Whatever you do, how much water, how much sun protection you are wearing, within a few hours, if not a few minutes, these places on Earth are going to become purely and strictly uninhabitable. No one is going to be able to survive there. Now, these regions are currently hosting hundreds of millions of people, so what would happen? That I can't tell. But I can tell you this has something to do with the news. I can tell you this has something to do with people losing their minds, with the rise of racists, xenophobic movements, aggressions, economical contractions, difficulties for governments to balance budgets, for companies to stabilize their activities. The World Bank estimates that climate change could cause more than 140 million people to move within their country's borders, so not outside their borders, by 2050 only in sub-Saharan Africa, South Asia, and Latin America, with severe consequences on economic development. History repeating. When we face threats, we've become very creative to give them faces they have nothing to do with. With energy contracts, when it falls down, when economy contracts, daily lives become affected. The stupid in us awakes, and that's just before the animal in us awakes, and that leads to something you don't want to know about. And if you don't want to be only on that aspect only, there are more dramatic consequences. So guess what? They're all linked and cascading, which means since everything was on an equilibrium on Earth, we are breaking that equilibrium too. So dramatic consequences imply even more of the dramatic consequences. The permanent ice is melting. Migratory animals won't be able to migrate anywhere anymore. Biodiversity will drop. Plants won't adapt fast enough. Animals won't either. We already lost 68% of living vertebrate species between 1970 and 2060s. Trees will die even if we stop deforestation. Wildfires are going to spread. Canada, Russia, and the North Pole are going to burn like Australia today. The North Europe will be as dry as North Africa right now, and the forests will burn faster than the South Mediterranean ones will do. You think this is over, right? It's not. There hasn't been any single week since year 2010 since we didn't find a new terrible consequence of our action in the future. Every week we project new really bad consequences. Like 2 weeks ago, I learned about clay soils and underground, for instance, which might become unstable deeper because of increased droughts. This, on the left here, is the expectation of seafood production changes. Dramatic, you see? Dramatic. This on the right is the expectations on agricultural productions. Again, the darker, the worse, dramatic. And for the very first time in history, a country, Madagascar, encounters a famine solely caused by global warming. 400,000 people are headed for famine, 1.5 million people for food insecurity. These, what you see on my screen right now, are real pictures from a few months ago. People, as you can see, started eating cacti flowers and dead locusts to survive. We are now in a state of mind when we refuse to consider a danger, mostly because people don't realize how advanced the catastrophe is. It has already started, not yesterday, decades ago. We get the news every day, but we're still not acting, because we don't see things happen, because it's not under it's not under our noses. It makes us blind, you know. And I hope if you were, after this conference, blind, then you won't be totally blind anymore. Social changes are going to follow climate changes, which are going to follow energy crisis. Now, there's only one question for you, for us. How long? How long until it reaches us? Well, I got some news. It's already here too. We'll see about that. For the first time in British Columbia in Canada this year, an absolute record of 49.6 Celsius degrees was recorded on the ground on June 29, 2021 in Lytton. This is the picture that was taken this summer. This picture was taken in Ontario, USA, in Canada, in 2020, 1 year before on the other side of Canada. I said USA because the North USA was also burning at the spot. This is Krasnoyarsk in northern Russia, close to North Pole in 2019. This is the North Pole. This is not the tropical forest. Right now, in Siberia, to contain all the 3,000 fires this summer, firefighters declare that we need to align 2,000 kilometers of line on containment, non-stop people and fire workers, firefighters. This is Australia 2020. The colors here are the original colors. As of 9th March 2020, the fires burnt an estimated 18.6 million hectares, which is 186 square kilometers, hundreds of thousands square kilometers of ground that was completely burnt, completely annihilated. The fires destroyed over 5,900 buildings, including 2,779 homes, and killed at least 34 people. Those on the screens are the exact colors of what the people saw this day. This is not a photo edited. This is not an old sepia photo. This is exactly the color of something that was taken with a smartphone. Nearly 3 billion terrestrial vertebrates alone died, the vast majority being reptiles, were affected, and some endangered species were believed to be driven to extinction. This is Lion's Head Mountain, near Cape Town, South Africa, 2019. Yes, this is the capital. This is near Braga in Portugal, 2017. The outbreaks that followed Portugal's deadliest forest fire in June 2017 that killed 64 people and injured more than 250. Portugal's National Forest Service has said that wildfire has scorched almost 200,000 hectares of land in 2017 alone. This is a major inhabited city on your screen right now. And this is Turkey, a few months ago in August 2021. This really summer, right now. This is Turkey. I assume most people don't speak Greek. So here's a summary transcript. This happened in Euboea, in Greece, a few days ago, summer 2021. The reporter on the left is making a report, and on the last place is not yet under the wildfires, while the island is burning a few kilometers away. And they stumble upon this old man. She asks, what is still doing here? He says he has a respiratory problem and cannot leave, as you can hear in his voice. She reaches out a mask to help him. She doesn't find a mask, and she asks the team, do you have a mask for him? And then she says, he has to leave. I don't know, we can take you with us, she says. And he answers, and where would I go? Where would I go? She later tweeted that they talked a little more about that he got abandoned by his family.
Μην ευχαριστώ, μην κλαίτε, σας παρακαλώ. Είναι, κυρίες και κύριοι, πολύ δύσκολες και οι στιγμές. Είναι απολύτως ανθρώπινο αυτό που βλέπουμε. Είναι ένας μεγάλος άνθρωπος. Προσέξατε τι είπε πριν. Δεν φοβάμαι για τον εαυτό μου, φοβάμαι για το σπίτι μου. Νομίζω ότι πρέπει να αφήσουμε χρόνο και...
You see, we're not talking about a third world country, we're talking about Greece. What does that mean? It means not everyone moves for simple personal pleasure. It means not everyone who's forced to move will do so. It means some people will even choose to die. This is a screenshot I've taken from Google Maps of the valley of Vesubie in Roquebillière in France. That's my country. This area is famous for violent weather conditions named Mediterranean episodes. Basically, when very specific weather conditions like the Mediterranean Sea temperature rising in conjunction with coastal winds coming from the sea towards the continent happen, this can create up to 1 year of rainfall within 1 day. This is the Mediterranean equivalent of a monsoon. This happens once every few years, more and more often. But on October 2nd, 2020, despite being warned and invited to leave their home by neighbors, this happened to the retired couple who used to live inside it. This is a footage taken by a journalist very close to the overflowing river. The couple would only send distress flashes, as you may see, with their flashlights. A few minutes later, the house was gone under the eyes of a handful of people, including rescuers. I'm including these slides for my French fellow people who still think all this will happen outside their frontiers. I could do the same for any given country. Remember we broke the heat record in 2019 with 45.9 degrees in Gare in France, which is totally beyond any normal seasonal temperature in France. I have a friend who I like a lot. Her family lives a couple meters east from what you have on your screen right now, in the next valley, where the same events happened. I stayed with her on Instagram and Facebook messengers for 2 days during that week. It was during the pandemic, lockdown too, trying to find news on media on my site. Everything is already at your door, already. And we've been consensually warned for over 50 years at least. Every year we beat heat records on the majority of Earth's surface and oceans. Remember, when it comes to temperature only, we are currently simply 1.09 degrees Celsius above the average temperature at the end of the 19th century. But we reached the hottest periods of the 5 years worldwide since 1850. It's pretty clear that we are not going the good way. And when I say all countries, I could say everywhere, because oceans are not left apart. As you can see, wherever you mixed things you might go on the planet, you will suffer a slight temperature increase, and that's because the nature of heat flow, the temperature will rise more on the land. When you think the current space has a statu quo and you add 4% growth increase, which we saw, we should lead to radiative forcing of 8.5 watts per square meters around the globe, leading to plus 5 degrees on the average. But you can expect double this on land and half this on the oceans. You see, between 1 and 3 degrees, maybe 4 for certain places on oceans. And since it's an average, you can expect in both ways double and halves again as peaks, maybe worse. Another great thing that's known to us for sure is that the consequence can be reversible or not. The Atlantic Ocean Meridian Overturning Current is one of the main oceanic circulation systems. It distributes heat on the planet with a major impact on climate due to temperature differentials, hence salt concentration differentials, tides, etc. And it seems that the global warming is affecting it and slowing it down. You might already know about the ice sheet collapse on both poles. Earth's cryosphere has melted for over 87,000 square kilometers per year since 1976 on the average. I won't go through the whole list. Methane clathrate, which is trapped in permanent ice, forests dying all over the globe, droughts, etc. And one last thing about those consequences. They do escalate, they do impact each other, and they generate more dramatic consequences. In other words, you cannot track them one by one separately from each other because they all affect each other. Like I say, we were in an equilibrium. For instance, warming the weather would make trees less resistant and unable to adapt that fast, so they would stop growing, reproducing, and they will start burning. But when they do, they reduce the number of one way to capturing carbon in the atmosphere along with ocean life. And they do raise the albedo on the ground. The ground is going to be reflecting more light, so leading up to more warmth. So guess what? Less trees, more carbon release, less carbon capture. Less carbon capture means more in the atmosphere, so more warming. So even less trees, and etc. and so on and so on. Okay, so this doesn't sound good, right? So all we got to do is take the solutions, and we're good, right? See, usually in our world, there's always a super easy solution when we debate about things between, let's say, the patronage and the politics on one side, who only see the world, the illusion of competition, and the enlightened and wise citizen on the other side, right? Well, here's the thing, not this time. First, it's already too late to discuss about what we face, it's already too late to find absolute working solutions, and actually we don't have solutions. The very few ones we have are scarcely set up. You're gonna ask me, why did we do that? Why don't we just go back before that? This is a painting from a Spanish painter, Alonso Sanchez Coelho, by the end of the 16th century in Sevilla, Spain. This is what our world would look like if it was made only with renewable sources of materials of energy and digging very reasonably into non-renewable sources. At this time, life expectancy is a few decades only. On the average is about 27 years for men, 28 years for women. Needless to say, I expect more than you to be dead already about this life expectancy. Which would be the same age for me being 37 today as if I were 180 years old already. At this time, I would already be dead long time ago. At this time, there's no real knowledge about medicine. At this time, there's no way to prevent suffering, no anesthesia, no laws against raping, justice. Was really far away from what you think right now. At this time, we just relieve ourselves in buckets. We just poo, we defecate in the streets. We let our teeth rot until we pull them or they break naturally with pain. Needless to say, at this time, there was nothing. And no, people were not living a happy life. Not at all. At least that's what they all wrote in the history books and the witness from this epoch that we have in abundance. So why did we do this? Why did we stop using our genetical capabilities to instead use, assemble, exploit, animate all that energy, all those materials? Simply because it's more convenient, and actually we created a much and more enjoyable life for this. See, this is Robert Fürstemann, a multiple national, European and world champion of track cycling. His legs are 74 centimeters circumference. Yeah, it's pretty badass. On this video that you can find on YouTube, he produced 700 watts in 1 minute 48 seconds, which enabled the toaster attached to the battery storage to burn one slice of bread. Just burn one slice of bread, something you don't even think about it right now. This is the equivalent of 0.021 kilowatts hours. A human body is homeotherm, as we saw, which means we need to keep and to maintain at the permanent current same temperature, not like reptiles, for example, which are heterothermals. Meaning we need to remain at constant internal temperature, a couple degrees away and we're dead. For that, a human body can generate up to 100 watts. If that cyclist was doing a 2,223 meters uneven uphill ride on foot, let's say he takes a total of 90 kilograms of matter, his own weight and a backpack with water, whatever you want it to be, he would generate 0.4 kilowatts of energy. kilowatt hours, okay? kWh. If he was to be doing, let's say, just 1 kilometer only every day, just try to do once in your life. This is fine. 1 kilometers uphill ride, okay? 1 kilometers per day, every day. He would generate around 100 kilometers, kilowatt hours per year. On the other side, 1 liter of gasoline contains the energy equivalent to 8.9 kilowatt hours of electricity, which means you would do the same with that tremendous amount of energy, which would just literally kill you, within 11 liters of gasoline. 11. I live in France. We use on the average 1,000 liters of gasoline every year. Last year in France, we used 42.5 millions of liters of fuel when all summed up. And that energy comes for free. We never paid to have oil. We simply pay for the salaries, the taxes, the arbitrary cost by human sitting on the oil. We do not create oil, which is why it's entering a crisis. We'll say about that in a minute. And the cost of conventional oil is around 3 to 10 cents per liter. And it's super concentrated and light, easy to transport, included into the engine, the vehicle that carries it, which is why we have reservoirs. It's quite dangerous depending on its refined form, but we learned how to deal with that. And just to compare, if you were to break all the uranium-230 atoms contained in 1 gram of uranium-213, you would generate 158.5 kilowatt hours of energy, which is tremendously much more. It's actually close to 1 million times more. You see the difference? But here's the thing. In 2019, an average human consumed over 9,700 kilowatt hours per year on the average. This goes up to 2,100 in Qatar, 180 kilowatts in Iceland, 80,000 in the USA, among the top consuming countries. In other words, on the average, on Earth, a human being like you and I produces 0.2% of the energy they use every year. That's it. That's what we went from the 16th century world I showed you before to our world today, which means on the average, there are around 500 human people working for you, only you, constantly. If you wanted to have the same way of life that you are living right now, on the average of Earth, you would have 500 human people just like you, working like slaves all the time, all day and sleeping at night, right now, to make everything work smooth, to take an average. Every time you are in a building that was built on a road, on a vehicle, using a smartphone, eating food, going to the toilet, sleeping in a bed, every single time every single thing that was made used this energy. Without it, you would be naked in the wild, dying at the age of 20 maximum, and you would spend 100% of your time sleeping, surviving until you would die. Which means we would need, on our planet right now, 3,950 billion human people on Earth just to provide the same energy with human people only. Not even considering them doing anything else like sleeping and eating, because we would need to feed them too. And this is why we are burning the planet so fast without realizing how fast it is and without questioning it. And if you live in rich, developed countries, I got bad news. You're pulling this 500 average way above. You are actually way, way above, up to 1,000, 2,000 times more, depending on your individual life. Now you understand why we use petrol instead of human force. It's super easy to find on the planet, it's disposable, you can storage it, you can transport it around 0.88 kilograms per liter of petrol, and it makes machines work. And machines don't riot like human slaves, they don't create labor unions, they don't fight for their rights, they don't get ill, they can be repaired, upgraded, and changed without ethical problems. So did we think. This is why right now all machines on Earth which work with coal, oil, natural gas, gravity, solar radiation, etc. are so enjoyable. Thanks to that, we're all permanently using an average of 500 human beings working virtually for full strength for us all the time. And this is why thinking about going backwards in time regarding our use of energy is going to be considerably lowering your life quality. This is why people, governments, industries, companies, individuals like you and I don't really enjoy that discovery. This is why it's not pleasant. Because if you consider the knowledge and research advances in gravitational waves, deep learning, or the scalar boson of Higgs, they don't really affect your life in a visible way. But this does. This totally changes your life and how you consider the world and your future. So did you think? But it's not true. It's not about your future. It's about your past 17 years and your present, as we're going to see. For these conferences, I won't dig too much into the consequences of that energy revolution, but when I'm telling you it's about everything, it's literally about everything. Without getting away from our mortality, from our basic animal needs, we went to working in services. In other words, we became more and more useless as a workforce in a world that still works as a foundation reference. On Earth, all life gets its resource from inert materials first, then from death. That's what we are made of. We are all made from the death of other entities, living organisms that we just killed or found dead when we used to be alive ourselves. When life needs resources, it waits for dead organisms or it kills them. We are animals. We are living too. We are no exceptions. Just open any history book, blog, vlog, publication, etc. You'll see the hundreds of millions of deaths due to our animal side. And you got no idea how many more you'll need to add when people got desperate. Surprise robbery, famine, resources wars, food, oil, water, etc. Thefts, accidents. So many lives were lost. When machines work for you, that you don't have to work, you lower your mortality rate. In conjunction with medical research advances, you get a population explosion. You know what the graph looks like. When you satisfy any of your human needs, heat, energy, matter, in and out, people have no reason to fight, or very few desire mostly, but neocortex is well aggressive once fed. When you divide the number of people working primary exploitations resource to get resource from Earth, less people in mind, in fields, less people for logging, no more hunting, fishing, water supplies, etc. In EU, for example, in Europe, in European Union, this is about 4.57 of employment. The primary sector is 4.57% of employment, against 75% 3 to 4 generations ago, accounting for only 2% of GDP. But just try to remove this sector. Just see how long we can hold without agriculture, without the mines, without the fuels, without everything. You see, just because breathing is super easy for most of us doesn't mean we can stop breathing right now, right? Then comes the secondary sector of the economy. The one is basically transferred from rich country to poorer countries because of suffering, need for care, pollution, and deaths. This is why most developed countries are right now. In EU, for example, is counting for 80%, 18% of both employment and GDP. 18% is nothing. But this is replaced by machinery too. Workers have been on the decline for a number of decades. So the people moved away from those. They gather in cities, larger and larger. They go from cities to work in services. We know all work in services, like between 70 and 80% in the tertiary sector when it comes to developed transition countries. We now have currently 50% of the world who live in 2% of the total territory, and it's going to be expected to be 70% in 2050. And also this has a lot of more social possibilities and transitions. With all this resource, we can start parasiting which once was a substitute for our needs, on top of which we build what we call the economy. And in that economy, we slowly started to detach the needs from the structures. Because we need less and less humans. We set back to doing nothing in many ways. The poorer the country, the more people work, the younger they die from it. And finally, we can pile on the upper apex top of this many extremely useful stuff like shareholding, business angelism, merchandising, globalization, stock exchanges, speculations, business banks, fundraising, high frequency trading, and then dark pools, whatever you want on top of it. YouTube channels of speculating, investing in cryptocurrencies, shares, and people with bows and ties, super large caps connecting, connected wine bottles, freelance human resources, happiness managers, quality managers, and much more bullshit. Which, as you can guess, is something we desperately need to build our world. Just because no one ever told us not to do that. No one has ever told us that we wouldn't need that shit. So we just did that. When everyone is given extra free capital or resources or machines in sublayers of society working for them unconsciously, what do you think they will do? It's kind of crazy what a human brain can do to keep themselves occupied. So, we just created so many things with that. We created weekends, vacations, the framed working hours, the pensions, the divorce. We have a raised number of divorce. Why? It's not because we don't want to be together anymore. It's just because we can. For years and decades, people could not divorce. And divorcing means you have to have twice the number of furniture, of houses, of flats, of cars, of heating, of everything, of food, and everything is just multiplied when you do that. So we also took more and more living space per inhabitant. It just doubled around among the last 15 years, So this goes well further away than we just thought. What we know is that regardless of estimates, projections, and conjectures, the world, starting with 1970, more and more to now, and continuing starting now, will be more and more unstable. I'm not going to list all the consequences. You just have to open historical content like any school book will do and read history reversed, but with added technology and knowledge. So yes, you will see everything we try to fly away from. Just look around you. Who's in charge of Turkey, of Russia? Who's the former president of the United States who got elected between 2016 and 2021? Who's at the door of governing countries like Italy, France, Austria? Who's in charge in England? What's the current state of social tensions? Don't you feel like there's a growing need for diversion away from structural crises? No one elected can change without risking their whole careers and lives. Are you sure you haven't heard about population moving recently? About inner conflicts? About obscurantism? How's the situation in Middle East, in Pakistan, in Myanmar, in Brazil, in China, in India? When energy supplies contract, economy contracts. When economy contracts, no one can see where the trouble comes from because it's really subtle. So people start acting really weird. It's like being slapped from nowhere all the time while there's no one around you. At some point, you just start blaming anyone or anything you'd see, imaginating culprits. When we hurt, we have an animal reaction of folding, When you hurt, you just go to lateral safety position. You put your hands on the location where pains come from. You fold and repulse people around you. That's exactly what happens at large scales. Borders get reinforced, tensions rise, and people seek from scapegoats and responsible targets. Anything that doesn't look like you becomes an enemy. Black and Jews, AIDS and gay people, unemployment, misery, and whoever is your neighbor, your imaginary fear, black people, Mexican people, North African people, Russian people, Armenian people, Chinese people, English people, the Tutsi, Portuguese people, etc. Basically any frontier religion, physical appearance, sexual orientation, ethnic group in the world help fabricating enemies when there is no enemy. Then you start building walls, removing rights, denying access to services, building campaigns. You know where this goes. You've seen that in essentially any given election. You know who these people are. You know whatever their names. And you know that against all common senses, it works, and it worked in time. No Godwin point here. We don't have to end up with Adolf Hitler, Benito Mussolini, Kim Jong-un, Bashar al-Assad, or any of these aberrant creation of economic collapse. We can do better than this time, but we're not certain that this will be an easy task. Polls often quote voters' concern when approaching elections: unemployment, human migrations, education, terrorism, poverty, health economy, coronavirus outbreak, violent crimes, and much more. Guess what? All of these concerns are directly affected by all that I showed you today. Didn't I spend 6 minutes making a quick list of the most devastating catastrophes that simply happened over the last 2 years? Are you sure there's no link between recent election results around the world and that economic collapse, that structural physical collapse? And tell me, what do you think this is if it's not a start? You remember that dog, right? Just a question, how long can you hold until you don't even know what percent of the crisis you are in? Except this time there might not be even wars, because wars need resources, tremendous amount of resources, and therefore they need energy, material, people. Without that, you go into no war. Wars ruin countries, including the ones who win them. But what if those countries are already ruined before they start? And we know that the situation we face is unprecedented, and that apart from building models, we have no idea what's going to happen. Nothing will happen as planned. Nothing. Facing such a global systemic crisis is absolutely new for mankind. Handling a world in contraction has all the drawbacks you can imagine, or maybe you still don't want to imagine. When I was talking about the dogs, I was talking about this one, you see, this dog which is denying what's happening to him. So, let's go back to the way you need to see our use of resource. See, if you were to talk about our resources, you could say that we mostly use two types of resources. Here are only resources that you can exploit. For instance, the sun gives us each year over 12,000 times more energy than the absolute total we produce. All energies summed up, totalized every year. Those can renew over a short time span. Okay, what we call the renewable energy is what can regenerate over a very short time span that is visible to us, like sunlight, wind, tidal energy, gravity, or briefly, like drinking water, edible water, cereal cultivation, just need 1 year basically at worst, biomass, etc. Or within a few years, like trees, animal development, the humus in the woods. This is a couple years, this is okay. Those that we do not exploit or consume faster than they regenerate, okay? This is the left bars, the renewable energy, the renewable resources, okay? Then there's the other type, the non-renewable sources of materials and energy mixed together. Now, those that are on this bar here on the right in blue are in a known, close to definitive quantity. This includes material like chemicals, elements, any of them, the combination, and some high-level molecules like oil, natural gas. Yes, oil and natural gas are theoretically and physically, we know about them, renewables, but not fast enough for us, so they are considered non-renewables. The problem is that the closer we get to zero here, the harder they are to find. So we can push back the zero, the value close to zero, at a greater and greater and greater and greater cost. And this is what we're doing right now. Being aware of that, you might think that things are easy. Let's just go with full renewables and keep running the old world over and over again. Done. Actually, no, it's not far. It's just far more complicated than it looks. First, because whatever you do, you'll need to build power plants. And this is both expensive in money and energy and materials. You can only estimate what power source is okay or not depending on its full life cycle, because you have to take a whole life cycle into account. Because building a power plant pollutes a lot. Making it work does so, not only from this potentially polluting energy source, and at the end of life, when it stopped working, it still pollutes as well, even once it's gone. A wind turbine, for example, depends on many factors: size, place, average wind speed, humidity, heat size, the aerodynamics of rotors, height, and what we call the weight of the air, etc. And it only works when there's wind, which is not all the time. Which is why we install them offshore, which looks like a good idea, but has a lot of costs in cables, concrete infrastructures, etc. An average of them produces between 100 kilowatt hours and 4 megawatt hours, which is around, let's say, 4,500 megawatts per year. About the needs for 1,000 to 3,000 people, depending on many factors. Around the same as barely 400 tons of oil. Yeah, not much. Same goes for photovoltaic energy. Panels require a lot of materials, ground space. We're starting to invent new ones for the land, to use the land under the solar panels, but it's not really fully thought yet. Hydropower is never really saturated, but let's say that we already built the most interesting dams so far. For instance, India has 4,000 dams. China has 24,000 dams. There's still some place, but these are actually the most dangerous energy source on Earth. The dams have killed an estimated 200,000 people since 1850 around the world. It's very hard to determine. This number might be less or more accurate. So in the end, all you see on this graph on the left here can be safely used, with very particular limitations for any of them. And these all the right here, the three on the right, are the bad evil 3 source list, coal being way ahead of it, as you can see. Needless to say, our top priority is to stop using coal. Needless to say, it's possible but extremely hard. Remember how much coal we used in the first graphs on this presentation. And as you can see on this graph, no energy is carbon neutral. So we usually call them low carbon energies, which is actually enough to save the planet from these problems under current conditions. By the way, if you see CCS, it's about carbon capture storage, which we'll come back to that in a moment. It means retaking the carbon that is emitted to not let it go into the atmosphere. And I won't mention a major problem here: the capacity of handling and dispatching the generation of the electricity, the current, on demand. That's a real serious problem we face. Our energy consumption does not depend on what we generate, but what we need. When you are home and it's cold outside, you don't want to wait for more winds or more sunlight. You need to warm it now. When everyone comes from work days and wants to charge their car from tomorrow, you need to have power plants ready. When everyone is at dinner time and they want to use ovens and they just consume suddenly a lot of energy, you need to have the power plants ready too. When it's night and people want to do the washing and the things that consume a lot, charging their water balloons for hot water storage, you need to have all the power plants ready at the same time for everyone. And this is not something you can pilot. It's not something you can handle and dispatch. This is what we called dispatchable generation. We need to pilot the energy produced, and we need to adapt the production live on the demand, according to the demand. Otherwise, this ends in a failure and power shorts. Again, here I'm not talking about how to solve this. Better heating, heat pumps, adapted sources, renewables, neutral insulation, better building norms and requirements, adapting the existing real estates, etc. And if you're wondering why photovoltaic energy is not yet that cool, it's probably coming, but yet not totally efficient enough. It works, but the challenges are the panels need to last. They need to be changeable, atomically maintainable, that the energy must be stocked, and that the efficiency of cells has become way and way better. we've been doing tremendous improvements, don't get me wrong. Just like you see on this graph, this is all the solar cells projects around the world. You see the efficiency has grown considerably, especially over the last year. Look at the last years. We're doing good progress, but we are far from what we could call satisfying. Once again, for the same price as nuclear and the same cost for environment, let's just build nuclear power plants for a moment and see what the solar panels can do in most cases. So you might think now we know everything, right? We should be lowering our energy consumption very fast, right? Well, guess what? We're not really going that way. This is the annual change, a growth. This is called a growth, right? In worldwide energy consumption. This is the growth, okay? This is not the amount of energy we use. This is the growth of energy we use, which means anything above zero means we use more and more, and anything below zero means we use less and less. Except for a few recent years, in 2009, there was a crisis that was thought to be economic, but it's actually due mostly to energy supply and not directly linked with the subprime crisis in the US, which is not really something that happens. I mean, that was a bad management in finance, but it just comes from a collapse in energy sources from the United States. And also, it's going to be the same in 2020. It's not yet fully calculated, but we can tell we approximately fail 4% worldwide and 5 to 10% in electricity. In 2020, it was partly due to the COVID-19 crisis. The energy supply went down all over the world, except in some countries like China, but it just went down from minus 7.6% in the USA, minus 7 in European Union. Sometimes people use the term the world after. The world after. What's going to be the world after that? Thinking that conscience would reach us collectively. Yet, without going too far in human psychology, it's kind of obvious that we're waiting for public decisions to be made by people in power, like governments, presidents, prime ministers, kings and queens, industrial owners. And we never really look at us and what we do. I refuse to go on individual evaluation of people's behavior, including the people I love. But I could make a collage of Instagram posts from this summer 2021, and I counted. At least 5 people took a plane travel: Corsica, Italy, Japan, Northern Europe, Central Africa, North Africa, Zanzibar, Portugal, United Kingdom, French Antilles. More than 2/3 of them posted photos over 500 kilometers away from their current city, and at least 1/3 of them made a promotion of new digital services they bought. I had 3 of them posting their new cars, a handful buying old second-hand ones. I saw a handful of them selling and buying new houses during the pandemic movement restrictions. I had friends who starting the road trip with their old-school bus that they repaired around the EUs for no reason, just because they wanted to. Several thousands of kilometers with oil. Some people posted over 50 photo stories of themselves and nothing else during the same week. 50 pictures of yourself, a selfie, over and over, being stored on servers who just consume energy. Most of them don't realize they broke their yearly carbon footprint within a month, within a week sometimes. But this is not about my friends or the people I follow. I try to look back on what I did too personally, how many social posts I did, how much I drive with my car, how many kilometers, and I find myself guilty too, This is about our conceptions and mental constructions. That we need to change our mentalities. Remember, a world with neutral energy without new technology so far means no traveling apart from what you can do with your legs, no digital activity, no multiple flower houses constructions, no gasoline, no gas, no coal, no barbecues, no supermarket, no supply to hospitals, no warehouses, more time spent being with farmers, if not full time, no time to do anything else, no social networks, no unemployment, no employment in services or little, no heavy industries, no moving to another country, no divorce, multiple people per habitation, living with 5-10 people in the same house. If your family is more than 100 kilometers away, you would need 2 days or more to reach them at least, if it's not separated with water, etc. So before that happens, and we're going to change everything we can before that happens, I hope so, We need to stop a few things. We need to stop sharing that buying new stuff is cool. It's exactly the opposite. Every time you buy, you are the utmost apex polluting things you can do in your life. We need to stop sharing our travels. It's not cool anymore. If you travel, do it quietly. You need to stop thinking about individual property, houses, cars, motorcycles, second houses. It's not cool to be rich and to own more and to use more for no reason. We need to stop manufacturing useless objects. It's absolutely not cool. We need to stop thinking that wearing old clothes is bad. We need to stop thinking that old is bad. It's exactly the opposite. Old means survived, which means still in use despite not costing anything. We need to stop having 1,000 companies building the same thing under competition and spending their time killing the competition. It's not success. It's a collective failure. We need to keep our artistic free time activities. We need culture, leisure, we need peace, but we also need to understand they come and they become a problem for the connectivity if we just expand them too much. I could go over and over, but this conference is only going to focus on the digital consideration, and it's not up to me to tell anyone what's good or not for the planet. It's something that needs to be measured, and we need to take decisions together. Anytime you do anything in your life, you can be participating in killing someone somewhere in the world, animal, plants, life, without anyone even making the link, the connection between you and it. Doesn't mean you should become paranoid. It means the exact opposite. You should be conscious and enlightened. You need to take some time to look around you, allow everyday life, and what you do that the others don't. You need to take some time to think about everything, but you're going to need metrics, you need data to take good decisions. Because when it comes to understanding your impact on climate, materials, and the biosphere, I can tell you nothing is intuitive, nothing. And this is where the tricky thing starts. When it comes to energy, only about energy. And that with one objective in head, all that with one objective in head, remained under the plus 1.5 degrees additional variation, which is unfortunately impossible, even though we haven't reached it yet. Remember, we're still around between 103 to 105 in 150 years so far, but we're still going to try whatever it takes. You remember the Avengers, right? Whatever it takes. Plus 2 Celsius degrees is something we can almost think about, and plus 2.5 is our new target. With every 100th of a degree that counts. We could still try to achieve neutrality in 2050 and then try, what is the plan, to remove CO2 during the second half of the 21st century. But right now, as we saw, we're not going that way, not really. This is, for example, the share of cumulative CO2 emissions around the world. As you can see, it's not distributed equally, and the great countries don't even have data to provide. And this, by the way, if you want to know a difference, is what the world looked like 12,000 years ago with minus 4 degrees difference. Minus 4 compared to today. Let's because we have plus 1 is minus 5 actually. Minus 5 degrees on the average compared to nowadays. I'll let you imagine what is plus 5 degrees above that. All right? And if you want to see the climate very precisely, this is what is expected. But there's another thing. Energy is not the only problem we've had. And solving the energy problem is going to create more problems in cascade. We're trying to solve those new problems as well. Let me tell you why. This is something you usually remember from school. If you remember this from work, then I'm having a little pressure right now. Most people actually forget that we called metals is larger than we think. It's actually quite hard to classify atomic elements because the separations lines are not strict. But generally we have this. We think that metals have specific properties like electrical properties with electrons, Wikipedia says they are materials that, when freshly prepared, polished or fractured, show a lustrous appearance and conduct electricity and heat relatively well. It would be quite complex to explain how we classify them, but it has mostly to do with electrons, and many physicians are going to kill me for that simplification. Most of them come what we think is the Big Bang nucleosynthesis for the lightest, and later by stellar nucleosynthesis and spallation the process in which stars create all those starting elements, all those elements starting with the basic hydrogen elements here, then deuterium, which is just, let's say, hydrogen steroids, where tritium, which is radioactive, helium, etc. And at the end, with most of what we have in this chart, this is a real quick summary. Astrophysicists are going to send the police right now to my home, but this is a simplification, but it's the only thing I could tell you right now. Most of these were found in our current universe, but not all of them are. Actually, the larger the nucleus is, when you go down to the bottom of the chart, the faster they will degrade into other simpler elements higher in the chart. So for the first time, in 1937, we synthesized number 43 here, the technetium, which comes from Greek artificial. Then came 25 more so far. There might be a limit to the number of protons and neutrons we can squeeze in the nucleus, but we don't know it yet. Then we have the non-metals elements called the metalloids, because they are just somehow like metals, but not completely metals, but not completely different either. And then we have the non-metals on the right here, which means they are not really metals. Just a little note to avoid confusion. The rare earth elements are the lanthanides, the top line of the two of the bottom, this line here, from 57 to 71, plus yttrium here and scandium, which is here. Those are called the rare earth elements. Okay, they're a set of 17 nearly indistinguishable lustrous silver, white, and softy metals. And these have nothing to do with their rarity. They are considered quite common in Earth's crust. Okay, I know life sucks, but they are not rare that much. Okay, but despite this little atomic joke, we have a problem. As you can imagine, we don't fabricate those every day. And when we fabricate them, we need other elements. Or we could, but that would require a tremendous amount of energy. Remember, we need stars to do that, and our sun is only making a few of them. It's not a very powerful star, actually. The sun is a little star, and it's 109 times larger than Earth. And the larger star we know so far is Yoichi, which is 1,700 times larger than the sun. Yeah, that's pretty large. So what we have on Earth, with the exception of needing very small quantities, is what is left for us until the end of times. And this, on your screen right now, is a table of what we would now call rarity. Remember, just forget about the rare earth, it's just a group of elements. Rarity means that we can find them easily or not. Again, most of them are findable on Earth. But the question is, how deep, how large have the mines to be so that we can find them in sufficient quantities? And just if you wonder what rarity is about, just think. That's the definition of a rare, valuable metal, right? What could be a rare metal that you all know about? Gold, right? Gold. All right, just think. Oxygen takes 46% of Earth's crust, which is the surface, the last hundreds of kilometers on Earth, okay? What we can reach. We cannot reach further than this, okay? Remember, the deepest hole, the human-made hole on Earth is 12 kilometers deep. 12, not 6,000, 12, okay? Oxygen takes 46% of Earth's crust. Silicon takes 28%. Aluminum takes 8%, carbon takes 0.02%, nitrogen 0.0019%, gold 0.000004%. Plutonium, I won't tell the zeros, it's 0.3 plus 14 zeros%. I think now you understand what rarity means. And also, they're not distributed equally among Earth's surface and ocean grounds, and some of them are also into the atmosphere. And then comes another problem. With that complete list, we use all the elements, almost all the elements. 60 years ago, we used about 40 different metals here. Now we use over 80 of them out of the 82 metals on Earth. As a result, guess what is happening? Yep, we are going to lack some of them within the years to come. Not in 1,000 years. For some of them, extraction is already on the decline, and we expect them to be missing between 10 to 20 years from now on. And yet, not only are they missing, but also we keep mining them more and more, and the demand increases. Most countries have now what they call strategic element councils. Why? Because they're expecting to use 2.5 more of those materials by 2060. So you're going to ask me, how fast are we using those resources? You see, this one, the color here, there's so many of them, that limited availability, risk, or serious threat within the next 100 years. So how fast are we using these resources? And here's your answer. On the average, we traced all the things we used and we could find in the history. And it comes out that we used the same quantity of materials over the last 70,000 years than what we expect to use within the next 30 years. And this, guys, is what structural long-term growth is about. A gigantic lie and failure. There is no structural long-term growth. There's a dead end for us. But you know what? It's not only about the atoms themselves we consider individually. It's the same problem we have with molecules, the more complex assembly of them. And guess what? Coal itself, despite being number one for responsible for greenhouse effect emissions, is not infinite. We only have about 400 years of coal left. This is a coal mine. This is what it looked like in Fushun, Liaoning in China. This is a coal mine. Look at how the earth is fucking dead around it. This comes from Datong in Shanxi in China as well. The second pictures here are from Hefei, Anhui, still in China. And these women are scavenging coal in a dump site in Jaria, coal field in India. I could show you any mine, and they would be more or less looking like that. Graphite, gold, silver, uranium, etc. They all have catastrophic consequences to their environment. Water, air, people suffer and die by the thousands. People leave their houses, plants stop growing, etc. I could tell you the same about natural gas. We're going towards the end. And that's an average. Some studies say we only have 100 years left of natural gas on Earth. You remember oil, that thing that contributes to moving things, the number one culprit from the inbound catastrophe we're going to have, because we can just cut the coal, we can cut the gas, but cutting the oil means the end of everything as we know today. Every trace of civilization we are right now would just stop instantly if we don't have oil. And guess what? Your round trip to countries, the other side of your countries, or even simply to the other side of your town will soon be over. The peak oil for all types of oil is expected in 2027 with current calculations. You have to remember it's not normal to leave your family to move 500 kilometers away. It's not natural. Absolutely no one did that 3 centuries ago. We did not travel for a weekend or a week or a month. It could take months to travel by using all your money. So you're going to tell me, well, if we're missing the main 3 energy sources, coal, oil, and natural gas, then let's go and build nuclear power plants and use electric cars with nuclear energy. You see, the problem is, as of April 2020, there are 440 operable power reactors in the world, with a combined electrical capacity of 319 gigawatts. Additionally, there are 55 reactors under construction and 109 reactors planned, with a combined capacity of 63 and 180 gigawatts, while 329 more reactors are just proposed, like studied, not in construction, studied and being thought and engineered, okay? An average nuclear reactor produces around 1 gigawatt of energy on the average. The world uses 23.4 terawatts each year, which means we need to build a little more than 20,000, okay, 20,000 new nuclear reactors to sustain 100% of the energy. Remember, energy, not electricity, energy, everything including transportations, car, planes. I don't know how planes would work with nuclear energy, but they would, okay? Submarines, trains, cars, bikes, whatever is working with electricity or not, would just work with nuclear energy, okay? Also, there are other factors to consider. One nuclear plant requires 20.5 square kilometers of land to accommodate the nuclear power station itself. Its exclusion zone, its enrichment plant, ore processing, the ore processing is something, and supporting infrastructure. Secondly, nuclear reactors need to be located near a massive body of coolant water, but away from dense population zones and natural disaster zones. Simply finding 15,000 locations on Earth, just 15,000, not 20,000, that fulfills requirements is already extremely challenging. So we cannot even have the locations where we can set up nuclear reactors right now, nuclear power plants. Every current operated nuclear power station needs to be decommissioned after 40 to 60 years, 80 for the best of them, or operation, due to what we call neutron embrittlement, cracks that develop on the metal surface due to radiation. If nuclear stations need to be replaced every 15 years on the average, then with 20,000 nuclear power stations, one station will need to be built and another decommissioned somewhere in the world every day. Currently, it takes 6 to 12 years to build a nuclear station and up to 20 years to decommission one, making this rate of replacement unrealistic. I won't even talk about the handling of nuclear power plant wastes, from depleting uranium to gloves, wheels, and all materials that is safely removed even when it's not really radioactive. Nuclear waste is very minimal. Since the very beginning, we barely generated a grand total of less than 1 cubic hectometer of waste, which means a cube of 100 meters side. And less than 3% of it holds 96% of the radioactivity. And there are more problems, like all the rare materials we use, for instance, to absorb, bounce, or manipulate neutrons. All these materials we need to fabricate the centrals, the power plants, are rare and going on the decline. I'm not even talking about the steel, the energy you need to build the bars, the metal, the sand and the concrete that are becoming rarer and rarer every day on Earth. But that's not the main problems. To break atoms in order to generate energy, you need easily feasible atom. You need to create chains of reactions with little energy input so that you get lots of energy on the output. For that, there are almost no atoms that correspond to those criteria. Actually, the only one we find on Earth that is really usable for that is uranium-225, like I told you, 92 protons, 143 neutrons. This isotope, this variant of an atom, accounts for only 0.72% of total uranium on Earth, vastly found under uranium-238, which doesn't work for our power plants. Currently, we have about 80 years of uranium-225 left, following the current use of what type of energy through power plants. If we were to, let's say, magically have 100% power, remember, including vehicle, planes, everything, we could just empty those uranium resources within less than 5 years. As you can get, uranium comes from the beginning of Earth and is not generated anymore. So, despite the fact that it's a low carbon source of energy and handling the waste and everything, it's strictly non-renewable and it will be lost forever. Actually, I could spend hours telling you how many years we have left of materials, but you need to remember one thing. Estimating is really hard and depends on methodology. Not everyone publishes the same results, but what matters is the global trend and magnitude. Okay? So you can take it or leave it, we're running out super fast. And quantity is not only the problem we've left with. We also have risks and tensions, political, economical, social tensions, with some regions that this material can be found easily in. Look here, if I look at what we consider strategically relevant materials, you can use most of them are within 2-digit numbers. Look at this schema. If you cannot read it, I can read it. The inner part is how many years are left on the average. The outer part on the average, and the inner part is if the whole world consumes the materials at the same rate as the United States do. Remember, the United States are polluting a lot. That is a maximum of 30 years for antimony, which is used for medicine, silver, which is used for catalytic converters, 40 for tins. Tin is used for electronic soldering. You know, it's used in everything, the smartphones, everything. 13 barely for indium. Indium is used for screens, smartphone, TVs, computer screens. 40 for lead batteries. This was a slight older document than the previous slide, which estimated 60 years for uranium. We have accelerated the nuclear development also above. We only have 45 years of gold left. We use gold not only to make jewels, but for dental, for healing. We use gold for many things. Look at this graph. Look at everything. We only have a couple of decades. This is not for our children. This is for yourself. And I could show you different studies too. Like I said, it's super hard to estimate it properly. So the more studies you find, the better you get a big picture of it. Don't take those graphs for granted as a rule as they look. We found many ways to extend all reserves for ages, like 50 years at least, as we saw. We might find the same extensions for those materials and resources. But as you can guess, we are entering an era of mineral diplomacy because we all want to be independent as we can. Some countries closed all their mines, like France. Some countries have extremely valuable potential resources locations for the local people, or whole countries are once again opening and reopening them. Which, in the end, will lead to tensions and misunderstandings among people. In other words, you can take a car and film with your smartphone and share it on a social network at a demonstration against the reopening of the locations where they come from. You cannot be against opening new mines around you or reopening mines and taking your car to use that and using a smartphone to communicate on that. There's some paradoxical behavior. That's the definition of mineral diplomacy, an emerging term. And that's what we need to think in terms of circular economy as much as we can. And that will probably need to be written in laws again to give value to secondary products, the products we can reuse and recycle, instead of primary products, the ones extracted from the ground. Among the EU, there are commissions, like I said, almost every country now has one. You got the same in the United States, China, Russia. One of them is responsible for surveillance of rare material and critical elements. The fourth list of critical raw materials from the EU in 2020 showed this. On the 83 individual 66 candidates, raw material assessed, the following 30 on the right here, where you see in red, were identified as critical in these assessments on the top right corner. This shows the economic, if you prefer, the development importance compared to supply risk for each material. So, since the last report in 2017, one element, helium, was removed and 3 were added as so. As you can see, this is not good at all. And by the way, if you wonder, this is light rare earth elements and heavy rare earth elements. We talked about that a couple of slides ago, okay? But what do we use them for? What's a glimpse of the new technologies that we commonly believe at the moment? As you can see, they're all tied to digital activity, more or less, by the way. So, for example, here 3DP means 3D printing, ICT means information and communication technology, which is computers, smartphones, networks, etc. PV is photovoltaic here. And you see, we need all those materials with supply risk for each of those things. We need a lot of materials that are at risk to use for photovoltaic, for winds, for batteries, for fuel cells. We're not going to store energy just like that. We're going to have problems when we're going to face the energy problem and the global warming problem. So what is usually called is that if our 19th century was about coal, then we could say 20th century was about oil and 21st will be about metals. But there's going to be another problem again. You might think you could recycle them. Well, think again. Recycling is not going to be the game changer. It's not going to, you're going to increase the quantity. It means that you recover part of what was initially used, which means, first of all, you would be maxed out as 100%. You cannot generate things just like that in theory. So you would not increase the total amount. So if the demand increases, recycling is not the solution. But unfortunately, chemistry is not that simple. We cannot simply recycle everything. Remember, some metals are naturally used as alloys, which means that they are easier to assemble than they are to disassemble. And also, recycling is not neutral. You need energy to recycle. It's not just something you look at, you throw them in the dustbin and you look at them. And it also generates wastes a lot. You got a lot of pollution from recycling, less than you do from extracting, which is a good balance, but it's not the only thing you need to be caring about. And sometimes it's just extremely expensive. And guess what? The problem is, for some reasons, and for some physical reasons, there are some materials we don't even know how to recycle. We don't have any clue how to get them, to separate them, and to get them back. So this chart, for example, gives you what we currently use and recycle in European Union right now. And we are one of the most advanced places on Earth in which recycling takes place. So you would see less of these digits in other parts of the world. So we need to develop a sector that we need to innovate. But why? We don't know everything with recycling. And within what we know, we need to do more effort, okay? But it's not the only thing again. Have you ever seen this picture? How do you think they are? Take a moment if you don't know. I'm gonna fill up my my water bottle because I need to drink. Did you guess? Well, the one on the left is the total amount of all water on Earth compared to solid ground. And I'm saying all water, which means oceans, polluted water, everything that's contained water. Everything that's water is this little bubble, this little marble here. And if you were to pick up only the edible water, the one you can drink, it would be about the same ratio on this ball, which means let's say the reflection here would be the amount of edible water. The rest is not. You cannot drink it. The one on the right is the total amount of air around Earth. That's not a lot either, right? Same thing as we saw on the slides, a couple tens of slides before. You remember the atmosphere composition? A fraction of this air is breathable for us. The rest is not in good proportions or simply toxic. So same again, breathable air would be a super small sphere next to it. Like the reflection would be breathable air. A few digits, a few numbers. 1 in 9 people worldwide use drinking water from unimproved or unsafe sources. 2.4 billion people, that's a lot, that's actually more than a quarter of the people on Earth, live without any form of sanitation, which is one of the most significant forms of water pollution. 300,000 children die each year because of that. 1.8 billion people are still drinking feces contaminated water. That means you guess what it is, causing 502,000 diarrheal deaths every year. 90% of sewage in developing countries is discharged untreated directly into water bodies, which it's around 80% worldwide. Every day, 2 million tons of sewage and other effluent drains into the world's water. Every day, 2 million tons. Industry discharges an estimated 300 to 400 megatons, millions of tons of waste into water bodies every year. 9-point source pollution from agriculture and urban areas often greatly increases the total pollutants load together with industrial point source pollutions, which means agriculture is a diffuse pollution. A reduction about 1/3 of the global diversity is estimated to be a consequence of degradation of freshwater ecosystems, mainly due to pollution on water resources and aquatic ecosystems. The reuse of wastewater in agriculture is important for livelihoods, but it's associated with serious health risks. There are now close to 700 dead zones in the world where sea animals can survive, which is the equivalent of size of the United Kingdom. In other words, serious studies from the United Nations show that within a few years, less than half of the world we know have little to no usable water. Over a third do already. Around 52% of the world's population will live in regions with less water than by 2050, causing between 24 to 700 million people to displace. Guess what happens when people move in masses over hundreds of kilometers, right? The sphere on the left here, which used to be linked to almost exclusively to water draining salts from high grounds to oceans, now depends in majority of human-generated factors. And guess what? Wastewater treatment contributes to an estimate 3 to 7% of global greenhouse gas emissions every year. And I won't tell you about the 5 to 7 gyres of plastic that float on top of 30 meters top of oceans, mostly trapped into 5 vortex, just a little more, like depending how you count. They are water of very low, those are water of very low density of plastic, usually invisible, but still way too dense to be ignored. About 18,000 pieces of plastic per square kilometer, and 90% of it is non-biodegradable. And I won't tell you about the tens of different chemical components that they generated that are really dangerous for life. We use about 90 million tons of plastic each year, and 10% end up in oceans. 30% of that remain in the surface, the rest usually sinks. I mean, what do you think everything you throw in the streets are your pockets, the dustbins for your car windows, all the little plastic pieces of your cigarettes pack when you fall down, open it? Where do you think those things go? Your shoes, your tires, including the tires of your bike, your cars and trucks, they get to use, they get to wear over time. The rubber goes into the water of the oceans. You don't even see it. Do you really think you put everything in your garbage collector bins when you throw away your garbage? Do you really think that employees who clean the streets, when they are, really let no debris despite all their efforts? 34% of the 120 marine mammal species in the threatened list have been observed entangled or ingesting plastics. Chemicals used in plastics have been found in fish, mollusks, sea mammals, and other sea life, which in turn is consumed by us. In short, we're killing them, and just before all that eats them, including ourselves. And the density has been multiplied by 100 over the last 4 years. Well, while you try to figure out the answer, I can tell you where it all ends up. Look on the map here and you will know where everything ends up. Why? Because it's not the only thing about water, it's about the gigantic melon we live on. This is Earth, again. But this time, we're talking about what's inside, or rather on its surface, below the feet. Earth consists of 3 main layers: the crust, the mantle, and the core. Half its radius is made from the core, half the mantle, and the crust. The crust represents barely 1.4% of all Earth's thickness. I told you about just 35 kilometers. It's made of 2 kinds of crusts, continental and ocean. The continental crust is what we call felsic. In geology, felsic is an adjective describing igneous rock that are relatively rich in elements that form feldspar and quartz. It is contrasting with mafic rocks, which are relatively richer in magnesium and iron. Felsic refers to silicate minerals, magma, and rocks which are enriched in the lighter elements such as silicon, oxygen, aluminium, sodium, and potassium. And those silicate minerals are the base of life, when it first formed, as well as nowadays to keep it. And then comes hydrometeors, especially rain. Rain is hydrogen and oxygen. Yeah, nice, water, really well done. It's very hard to break those bonds between hydrogen and oxygen. You need to bring water to approximately 2,500 degrees Celsius to break water. Water comes from what comes in the infractuosities of rock, and its hydrogen is drawn by the oxygen rock of polyhedrons, the ground. Then it breaks those rocks into extremely small ones we call clays. This creates a thin skin that contains nutrients that are the essential base of life. 400 millions of years ago, plants, thanks to that, started to invade continents, and they made carbon presence in the atmosphere to be divided by 20 to 25. Yes, the plants divided the carbon presence. This is what allowed us to exist in turn, thanks to the oxygen produced and sent to atmosphere, from soil to photosynthesis to respiration. Then plants die and give back their atoms to the ground, to bacteria, which in turn destroy the humus and make it usable again by new plants. For many years of studying oils, we can tell that forests were gaining over 100 meters per year on savanna and deserts worldwide, until man arrived. Man started doing agriculture, so only 22% of the ground surface is arable, which means you can use it for agriculture, which is why we are now invasive on non-arable soils. For that, we use 70% of pure water on a worldwide average. And this creates a memory of what we use, including pesticides that gets captured by clays. And plowing ground also releases part of the carbon that was trapped into it. When doing so, and removing the precious forest, men also made salts ascend up to the surface, creating salty grounds on which nothing can grow now, like we did in Australia. Not only do we do that, but we also go through lumbering, removing 0.6 to 1% of all forests each year, which is about 10 to 14 million hectares. As we saw earlier, this is the only way for Earth to recapture carbon from the atmosphere. We also increase the albedo, the reverberation of light from the ground. Around 20% of global warming is estimated to be due to raising tropical forests. We also make permafrost melt and dry, which also releases gigantic amount of carbon into the atmosphere. And finally, we need more and more arable land, yet we use it more and more to extend cities. Around 200 hectares each day lost in favor of cities. So to recap, we're using energy to move things. We're using the matter to form atoms, assemble matter our way, and then we use matter compounds to exploit them. That's a very super kinetic way, but you get the point. Thanks to that, we can move, assemble, and exploit things. And we use it way too fast. Remember, those coarse graphs I made with renewable and non-renewable sources, we use them so fast that even renewables don't renew fast enough. Only the sun and the winds are still on our sides. Farming, fishing, lumbering, everything is falling down and cannot step up to our current pace, which is why we just picture that into the fact that we use 1.6 Earth every year. And a quick word about 2020. I won't say that SRS-CoV-2 directly appeared because of global warming, but the mechanics of warming the biosphere greatly help and favor microbiological activity, which includes bacterial activity and viral activity, including recombination, mutation, etc. And for the first time, recently we had some shortages in common production in materials. We thought it was coming from speculation, cryptocurrency mining, but some computer hardware became harder and harder to find. Copper, semiconductors are putting the car manufacturing in stop right now. Plastic, wood, rubber, metal, grooming products, electronic chips, notebooks, construction materials, etc. They are literal waiting lists for specific niche products for the first time. We all had a shortcut thinking reflex of linking that to the COVID situation, but the production and supply chains never really stopped, and the demand increased, especially now the pandemic is stabilized. We had to perceive, but we already stepped into that part of the crisis, even though so far we might quickly recover from that. But you know what? This is nothing brand new. We've been aware of that for quite a long time. Actually, the first time we publicly expressed thoughts and studies about the importance of climate was 120 years ago. The first person to be ever credited about that is the brilliant mind of Joseph Fourier around 1824 and 1827. I'm gonna make a small pause here. All right, I'm back. I needed to refill some water to be able to drink something because my throat is getting dry. All right. So, as I was telling you, the first time we spoke about using our resources and wasting them to a limited supply, the first person to be credited about that was Joseph Fourier at the beginning of the 19th century, in 1824. But since then, we did some progress in warning people and studying climate. In 1972, scientists from the MIT in Boston published a widely acclaimed report that was called the Limits to Growth, which we also called the Meadows report. It was provided to a group of hundreds of elites, specialists, politicians, economists, diplomats, scientists, businessmen, etc. Its purpose was to study the dynamics of human population in its environment and see it through modelization. Since its publication, some 30 million copies in the book in 30 languages have been purchased. It had 3 objectives. 1. Gain insight to the limits of a world system and the constraints it puts on humans' number and activity. 2. Identify and study the dominant elements and their interactions that influence the long-term behavior of world systems. And 3. To warn of a likely outcome of contemporary economic and industrial policy with a view to influencing changes to a sustainable lifestyle. This report has been widely misinterpreted and often leads to hard conclusions. There were no hard conclusions in this report, mostly because it's prospective and speculative science calculations, not crystal ball reading. But despite that, I actually concluded to something that you might find interesting. Just let me quote its introduction abstract summary in 3 points. It says as follows: if the present growth trends in world population, industrialization, pollution, food production, and resource depletion continue unchanged, the limit to growth on this planet will be reached sometime within the next 100 years. Remember, this report is 1972. The most probable result will be a rather sudden and uncontrollable decline in both population and industrial capacity. 2. It is possible to alter these growth trends and to establish a condition of ecological and economic sustainability that is sustainable far into the future. The state of global equilibrium could be designed so that the basic material needs of each person on Earth are satisfied and each person has an equal opportunity to realize his individual human potential. If the world people decide to strive for this second outcome rather than the first, the sooner they begin working to attain it, the greater will be their chances of success. If we continue the business as usual strategy, we could have a digital collapse. But an Australian physician, Graham Turner, took the graph and the data, the speculative data from this report 50 years ago, over 50 years ago, and simply decided to superpose real statistics over the last 5 decades over this report provisions, which gave us this graph. The bold line represents what's real, what's been measured. Okay? And before and after the report was made. The dotted lines represent the estimate from this report. This means that in 1972, that science team predicted with a very high and incredibly amazing accuracy for this epoch, a model that would work for at least 40 years, if not more. They predicted 2 scenarios that would work exceptionally well. They proposed a lot of them, leading to a global collapse within the next decades, 2020 to 2030 at least, for the first one, and the last one between 2050 and 2060. And if you think that is a problem, just remember, climate change wasn't really known to them with our current precision at that time. And it was not even taken into account, which means these people, just by looking at the resources and not talking about climate change as we did on the first part of this presentation, went to a scenario that, as you can see, looks like really, really, really close to reality. And actually, if you see curves being higher than the predictions, it's not a good sign. It means we are using more food per capita, more services per capita, and fortunately, we are not using, we are using more renewable sources than we did, but we are using also more non-renewable sources, which means we are going towards this scenario way faster than we think, even though they predicted a little more pollution than what we did. All right, and the income ability of industry is not as expected to be. So remember, the first scenario was only based on one thing: the peak of oil production in 2025, the second in 2050. You remember what I said a few slides ago? We have estimated to reach an oil production peak in 2027, which is barely approximately the same. As we saw about the scarcity of raw materials, the loss of molecules, and the lack of some sorts of energy, there's sometimes good news and bad news at the same time. Like I told you a few slides ago, we face an imminent end to oil extraction. There are mostly, I'll say mostly, mainly two types of petrol. It's way more complex than this actually, but I'll just summarize this as best as I can. You have conventional and unconventional oil. Conventional resources and unconventional resources are two very different, excuse me, two very different separate sets of resources that can potentially be extracted. Both refer to some quantity of fossil fuels that could contribute to reserve if they could be extracted economically. The distinction between a resource that is a reserve is explored or not and usable or not is within a diagram known as a McKelvey box. It's a diagram which classifies resources and resources locations. When we saw earlier about the difference between exploitable resources and scattered resources lies there. In short, to extract oil, you need machines, and machines need fuel, and machines' fuels come from oil, sometimes gas. So, if you use more oil to extract oil from the ground but it generates oil in the end, you are in debt and you accelerate the pace of oil loss. Easy, right? The difference between conventional and unconventional oil is relatively straightforward. It has to do with the ease the fuels can be extracted with. Conventional oil or gas comes from formations that are called normal or straightforward to extract product from. Extracting fossil fuels from these geological formations can be done with standard methods that can be used to economically remove the fuel from the deposit. In contrast to this, unconventional oil or gas resources are much more difficult to extract. Some of those resources are trapped in reservoirs with poor permeability and porosity, which means it's extremely difficult or impossible for oil or natural gas to flow through the pores and into a standard well. You cannot make a well and dig into the ground and wait for it. To be able to produce these difficult reservoirs, specialized techniques and tools are used. For example, the extraction of shale oil, tight gas, and shale gas must include hydraulic fracture step in order to create cracks from the oil gas to flow through. In the old sense, in situ deposits must utilize steam-assisted gravity drainage to be able to extract thick bitumen from underground deposits. All these methods are more costly than the ones used to produce fossil fuels from traditional and conventional reservoirs. But these stimulations allow for the production of oil and gas from resources that were previously not economic or interesting to extract from. If you want to summarize this, there's a metaphor I always take. Unconventional oil is like a scissor opening for a baby, when you have to pull the baby out of the body before using natural exits, because it's not going to work. It's about the same. But if we combine both conventional and unconventional oil, we get pretty pessimistic graphs. We actually peaked, as you can see here, we peaked on this black bar here, the conventional oil production over a decade ago. Since 2011, we have never peaked and passed the peak here. So, as you can see, the only thing that gives us more and more oil since then is unconventional oil. So, when adjusting the models with actual data, it seems that will lead to a collapse around 2050 rather than this during this decade for many reasons, as we talked about the last slides of the Meadows report. I won't tell you if we're going towards a disaster or not. No one is going to happen. Now you have data, and this data is already old. You can get the same data up to 2020 now by the EIA here, Energy Association for America. So, and you're gonna get all the data from then, but it's going the same way. It's going exactly the way this graph is telling you or showing you where it's going. So you're gonna have to do that yourself. So does that all lead us towards a middle-aged life? No, it does not, because we have made significant progress ever since then. So does that mean we're all going to die? I don't think we won't. Even in the worst case scenarios, extinction on life is impossible on Earth. Extinction of animal life is also impossible, and extinction of human life is absolutely improbable. The worst case scenarios usually bring us back to 1 billion people at worst. Best case scenarios start including changes of way of life and heading up to 15 billion people on Earth, which with hard to reach but considerable changes in our lives. So, does that mean there will be wars? That's highly improbable to me, but I leave you the estimates on that. Because in order to make wars, you need, like I said, energy, you need economy, resources, and human people. When they're all depleted, there's no war. Will there be civil war, small conflicts? That's highly probable. In every cases, history shows that what happens systematically never fails to happen without twisting reality of facts. What else should we expect? I don't know. But transportation seems to be threatened by all these conclusions. The employment market is threatened too, which is the best news, by the way. Superfluous aspects of our existence are threatened. What are they? I'm not to tell you what is and what is not. When things come, if they come, we'll see pretty quick what is retainable and retained from our life and our way of life. What is something we abandon and something we keep. All I know is that handling a world of growth is easy. As a French businessman once said, in an era of growth, there's no bad manager. But handling economic contraction is clearly another thing, and you can guess the tensions if such conditions would create. It's up and each to one of us to make that happen as best as we can when it comes, if it comes. Alright, now that we made the little trip around the world, let's go to the second part of this talk. Let's zoom in and focus a little on digital sector, the one we're especially interested at the moment. The first thing we need to be aware of is how tightly we are linked to digital. For many people, it has already been a concept that lives next to us. It is not. This conference is not about transhumanism, but there will be way too many things to detail and points to make, and this topic cannot be solely mentioned just like that, so we can continue. As you have probably noticed, we have used many terms or been for many views regarding digital. You'll remember those attempts to qualify people who shut themselves while playing video games too much. You remember all those laws and decrees about smartphones authorizations in schools, public places, about the maximum number of use per day. You remember all those places where people thought it was cool to forbid digital devices. You remember all those conservative reports. 4% is the current estimate and growing of digital share of greenhouse emissions. It is the equivalent of all truck traffic worldwide. It's the general consensus on digital responsibility when it comes to greenhouse effect emissions. So other ways of counting could expand this up to 11% depending on how far you count. Like, do you count that people using cars to go to work to digital companies linked workplace, or do you consider that will still work for anything else that would be the same? It's complicated, and it's growing. It is growing. 7% is the total car fleet greenhouse effect emissions worldwide, if you want to have something to link that with. And as you can see, this is pretty much 1/6 of the total estimated digital energy consumption. You need to remember all those graphs highly depend on methodology choices. They are not to be taken as raw data, but as magnitude again, okay? So this is the energy consumption that it takes worldwide. Remember, we use about 23 to 24 terawatts per hour, terawatts per year, okay? In other words, some sectors are on the decline, but the digital sector is absolutely not. And if we keep those services going up like that, those services, who knows how much it will take? 10%? 30%? We have no idea. I'm always part of the people who still think about the future of mankind through transhumanism, and this idea is not antagonistic with lowering greenhouse emissions. Yet we have to start to act starting yesterday already. We should have acted starting yesterday. It's already too late to be, we should start. So the question is, why aren't we acting? When are we changing things in the digital world? Well, it's pretty hard to act on things that you can't see. The problem with IT pollution is that it does not usually come from what is used. So when you see an electronic device, you don't see pollution, you only see value. When you see a data center, you just see blips and lights, although whoever tried to work them knows the noise that is inside the data center, mostly because countries where pollution is generated are far away from the other side of the world, from where the places where these digital things are used. That's why we don't see this kind of pollutions. There are no fumes high in the skies next to data center usually. There are no cases reported for being poisoned because of proximity with an electronic device, you know, even though some people think they are dangerous and they I feel like this smartphone is dangerous. But can you act individually? You can, but our world based on capitalism doesn't work like that. We say that you might or might not agree with your structures, you might not be given a choice. I say you because in majority people with power over structures are a minority, otherwise our world wouldn't be able to move on. We need strong executives and consensual ideas based on enlightenment and knowledge. The problem is that today we get the opposite. We get weak executives who either take the majority to get re-elected, either owners to do whatever they think is bringing them on money to just avoid suffering, mortality, and misery. Basically, we have people who want to be conscious, thanks to their neocortex, of their mortality and to get away from that. So in order to do that, they want to exploit machines or other people as much as they can so that they have the maximum capital as they can, so that if anything happens to them, they have the means to just handle bad situations. So in our contemporary structures, you don't often decide anything. Therefore, we start seeing civil disobedience, resignations, departure, insubordinations on the rise. But this is the bravest way to go, not the most efficient. It's just the only one we have. Boomers have been there for too long, and now we got the proof that they acted in majority too slowly, kill and decay the biosphere. But now things are changing. We must start seeing changes, because not everyone with power is a stubborn polluting mule. And everyone being under a hierarchy covered by the law is a great ecologist, nor are they very aware of what's happening. Things are always more complex than they seem. All around the world, it's been the case for years now, and people are quitting their jobs for ethical reasons, for themselves, for others, for many things. Since the start of the 2019 pandemic, this went further and faster than ever. People spread quitting their moments and make them go viral because of low team managers, because of harassment, because of professional toxicity, conditions of work, intimidations, homophobia, transphobia, racism, working conditions, and more because they work for people who are basically shit. I'm simplifying in order to save time. Another phenomenon I personally had to witness is reorientations. I have two friends I could talk about. One was a community manager, the other one was a project manager, both working in the IT. Guess what they do today? They are beekeepers to get a life out of it, and they're happy. They feel useful to the world while making money. Job ethics are certainly on the rise. Through my career, I work for many people who engaged in favor of all destruction of the world I've been showing you so far. Lo-fi content creation to distract instead of informing and educating xenophobic people, alt-right, regular right-wing politics, bourgeois class, basically the people who created or approved harming others people passively. For a long time, I've kept wondering what people says, yeah, they're holding the wallet, you know. But as we saw, that wallet is going to shrink faster than everyone can be thinking about. See, the COVID-19 impact of the start of 2020, it was barely 4% fall for many people. Just picture what it could be if we were going down by 90%. So yeah, despite all that, working in our sector has been more and more a receptacle for bullshit jobs. I can tell you, it definitely is. Not everything we do is desired to be by the rest of the population. Not everything we do is cool. There are thousands of groups online, on Reddit, on Facebook, Twitter, TikTok accounts, etc. that narrate absurd stories from our structures. Actually, you never have any proof that your reputation is really that good outside. Mostly because of algorithm segregation. Remember how journalists, for example, didn't think about the Trump victory in 2016 because they were not part of these things or these groups and stuff. So wait, I'm not saying you should condemn everything and leave for anything. You can talk to people. Even where they wear a tie and a costume and they got a N+X form of hierarchy. At some point they'll be the same shit as you are. Actually, people holding a lot of capital will lose much more than you do. Mostly because nothing will happen in an hour. It's going to be way more subtle than it looks. So you have rights. You can refuse missions, jobs. You can have a word saying that working for a really bad company is going to harm the reputation of yours, and no structure wants that. No one wants to publicly display that their customers are people who actively and purposely manufacture carcinogenic products, who emit way too much greenhouse effects for no reason, who have no ethics, etc. You can talk with your team. Discuss with your agencies, your structures. No one is hiring people to make them work against the planet. No one wants to leave those traces behind them, despite what you think. Everyone is human and everyone can change everything. It might take time, and time is not something we have an excess of at disposal. You always have a choice when and where your money goes. You always have a choice where your employees go. As you now realize, this puts a certain amount of job titles on the side. Strategy development specialists, communications directions, social responsibility specialists in social washing and greenwashing, quality managers who are actually our productivity managers. I won't list them all. That's hell of outgrowth of a real economy that can be set aside. And now you understand whatever you do with your PR, your public relationships, your well-thought plan, your internal and external communication, your advertising, your brand management, your expected growth, the virtual money you manipulate, whatever you do, you are now threatened. Why? Because business as usual will stop being as usual until it stops being business eventually. The only question is, will you be the next dangerous boomers and play with fire until you fall down into the blaze? Or will you try to remember when you decided to act? But okay, so you might ask, are there solutions? This is a reflex. We have superstructured societies, so we're used to thinking in terms of ghostly regulating presence. In other words, we still think that someone somewhere is going to do something. And yet, it's barely considered in most places. So we're all used to having great solutions for which we only negotiate and debate around the conditions of application for simple, summarizable problems. And now, we're facing the opposite. It's a large sum of small problems that create a great danger. It's directly aimed at each and all of us and has no obvious solutions. So do we have a great plan with awesome solutions? We still need to debate on, like, if it was just obvious. No, we don't. If you look at the world right now, we're barely even aware of the extent of the great void we're going into, so don't try to imagine that we're teaming up for solutions. That's the first thing that strikes you immediately. But on the second thing that strikes you is actually we have a lot of small to sometimes scalable solutions. Yes, we do have some solutions. we need to stop using coal as energy first, we need to review our needs, we need to publicly agree on a direction to go, we need to let go with frontiers because global warming bears its name well, it goes all over the place and doesn't stop where it comes from. So how do our mentalities change? How do you make our standards evolve? Usually it starts with early thinkers. Those are the ones who saw and thought everything before everyone else. Whistleblowers in a way, scientists, Fourier, like we saw, the Meadows, etc. Then we do have the first people with influence who start getting into the topic, like, remember, An Inconvenient Truth, this documentary from Al Gore a few decades ago, and a few blog posts out there in the wild that used to start about speaking about global warming like a few decades ago too. Then we start putting up some harmless shit in the fan, and we start considering that we are at the edge of our times. You know, those LinkedIn posts, that shit in your email signatures, that pile of labels in any company's wear all the time. Then we start adopting norms to define what we have in common, like ISO 14008, for example. Then, as usual, the long trail of population gets aware of the danger. They start being a majority, making noise, interpolate politicians, which in turn get to sometimes take 15 minutes to learn about it, true story, and finally adopt the consensus so as to get re-elected. And everything becomes law. If you're lucky, it will become constitutional and even worldwide. So what's our plan? What's that thing I was talking about? Before going further, I'd like to stop on this. There's a large consensus on quoting Albert Einstein about the needs for a new way of thinking. It's often said that Einstein said we can't solve problems by using the same kinds of thinking we used to create them. Though we never found a real proof of that quote, we have this one here. In other words, we need to think differently and not to go the same way we used to. Einstein said, our world faces a crisis as yet unperceived by those possessing power to make great decisions for good evil. The unleashed power of the atom has changed everything so that save our modes of thinking and we thus drift towards unparalleled catastrophe. That's what I remember, the unparalleled catastrophe. And that's the trickiest part. So first, you have a plan, we need to have a goal. Let's see about that goal from a closer view, right? We won't do complex maths here, as we're going to do an actual super simple maths. And remember, you can say that A equals A, me equals me. Or you can write that A equals A slash divided by B multiplied by B, which is me equals me multiplied by 3 times the number of stage 3 Pokemons divided by the number of stage 3 Pokemons, okay? And you can deneutralize infinitely one side or both sides of the true equation. Now, what if we do that with variables that actually mean something? What if we said that we did with variables that actually interest us? This is the Kaya in the identity that was developed by Japanese energy economist Yoichi Kaya in 1993 in Tokyo, in Japan. This is a mathematically more consistent variation of Paul R. Ehrlich and John Holdren's I equals PET formula that describes the factor of environmental impact, where F is global CO2 emissions from human sources. What we need to lower. Remember, we need to lower this. P is the global population. G is the world GDP. And E is the energy consumption. Okay? So we just use F equal F. So F equals F divided by E multiplied by E divided by G multiplied by G divided by B multiplied by V. So it just means anything is equal to anything. So it means like 5 is equal to 5, X is equal to X, 25 is equal to 25, whatever. Okay, so no maths so far. Okay? So if you think about this, G/P here is the GDP per capita. It's what the economists focus on, something of a growth indicator, the production per human. E/G, E divided by G, is the energy intensity of the GDP. It's an indicator of the energy intensity of the economy. And F divided by E on the right is the carbon footprint of the energy, is the CO2 content of consumed energy. So now, if we take the Copenhagen reference objectives, we need to divide the total CO2 emissions by 3. So the part on the left needs to go by 3. Therefore, the part on the right does so, because maths, you know. So let's start with the population and demography. We can solve the problem by dividing the world total population by 3 by 2050. Is anyone okay? Are people okay? Do you think we can do that with what, mass genocide? That's probably not even doable. People will hide and will not be. That's not be the best one, right? Like we're gonna kill the easiest and more civilized people, and the animals, you know, they will just hide, and that's not gonna be a good idea, right? So forget about this idea. But if you can see a pattern here already. Pro-natalist policies don't look like the best idea we can have. Think about that. Isn't it why people with higher IQ desire less children, go for sterilization a little more, and actually have less children? Yeah, I know. I don't want problems with people. Let's go. This is expected to go by 1.3 by then, which means that now the other members of this equation need to go down even more. For instance, in 1 year and a half, a world health crisis like COVID-19 only, pardon the quotes, killed 0.56% of the world population, which actually still went up by 1.05% people. So despite the COVID-19, there's more earthlings now than there used before. So now we should lower the GDP per person, right? The total, so the average, actually. This means less capital for you, way less money, things you own, great things you have, things you earn, good or not. I'm just kidding. It's going down whether you like it or not. This is going to go down. The amount of richness, of capital everyone has on the planet is going down. So far, it's growing by 3.3% for 2020 and expected 6% in 2021. So great, money, more weight. Okay, let's assume that the realistic +2/2.5% per year until 2050, that's the expected calculations, is okay, so that your politicians can keep telling you that they can convince you that you're great and that they are great too. So it means it's going to be like 1.9 to 2.2 in 30 years. But now we have a greater problem, right? We need to divide the last two terms by 8 to 12. So what about the third term? Well, we've been doing better. We reduced by 30% over the last 40 years. But to do that 10 times more? That would mean raising energy prices for everyone in the world, quite unlikely. So it's more than likely that we're going to keep on going like that. Cross your fingers. Otherwise, that would mean taking your energy bills for your car, for your electricity, everything in your house, and multiply them by 10. That's in France right now, that would be 15 euros per liter of gasoline, 10 times your electricity bill, your primary energy bill like gas or whatever you have. Can you handle that? Are you sure your economy is going to be okay? So only the last part remains, and that part includes the current developing of nuclear energy, hydroelectricity, solar power, photovoltaic energy, tide force, etc. So what about that? Well, we barely did 10% over the last 40 years, sorry. So how much in the end? Well, depending on your estimates, between 5 to 15. So in the end, what do we need? Let's recap. More wars, genocides, dividing by 2, 3, 4 the capital we have, which means cut your house by 2, 3, 4, bank accounts, valuable objects, etc. Shut down the total energy we take by doing nothing with our lives, find magic ideas that are 10 times better than all the ones we had over the last 40 years for energy saving production, and decarbonate everything we do without having the materials to do so. Great! Why aren't we starting? Next, we don't need a global goal. We need to know where we start. Actually, you might be surprised, but a lot of countries already started to act. I'm not saying that because of a conference of parties in Kyoto, Paris, or Copenhagen, but they need not change anything. But seriously, don't say that too fast. We actually started to act up to a point it has become visible. It's not the end of a job, but you can say we started working on the problem in some way. Some members, also participating in the IPCC panels, created a model to define and clarify common objectives at the scale of a country. The analysis adopts the Safe and Just Space framework created by Kate Warroth. This framework combines the concepts of planetary boundaries originally proposed by Johan Rockström and colleagues with the complementary concept of social boundaries. There are 9 planetary boundaries related to how critical Earth system processes are, which jointly defined the safe space that humanity should stay within to maintain the relatively stable conditions of the Holocene period. However, remaining within planetary boundaries is a necessary but not sufficient condition for sustainability. Human well-being must also be maintained, and it requires resources. You have them all under the current model on the right here. So that's the planet boundary and the social goals you need to attain that they estimated to be something that the world could use. This is the definition of a world we can live in, if you prefer that. And that gives us the chart on the left. It's not about who to blame. It's about why we are all here on the bad part, which means we should all be in the top left. And look where we are. We can't say we are really, really favored in the good place, right? So now you have a contest. You have something to start with. You have somewhere to go. You have the social thresholds achieved from bottom to top. The biophysical boundaries transgressed by each country from none on the left to all of them on the right. In other words, like I say, you need to go on the top left of the graph. But of course, this remains at country scales. I'll give you a few examples outside the digital world, so you don't think about where you're going alone. Lots of people actually thinking about capturing carbon from the atmosphere or directly from power plants. A handful of those power plants are testing this, retrofitting it to long existing power plants, and yes, it works. They capture a good part of the emitted carbon, but don't be fooled, this is just a way for capitalism to say we're gonna go like, we can still emit pollution and use all the fossil fuels until the end of time, which we can't. Some people think about doing this anywhere to simply capture carbon from the atmosphere and put it back into the ground, which could be more productive and therefore concern more states than private companies. And some people had great ideas, like using carbon to recreate material. The cinder blocks in this picture are actually made of carbon components, a lot of them, and they turn out to be very good for construction. But let's be careful about ideas. Not all of them are good in the long term. There's a project that seems to replace bees with robotic bees. In the case they would die, or put it apart to assist them. If you want to assist bees, you have to stop using harming pesticides, stop bringing hornet species from all over the world, stop bringing them new parasites, take care of them, let the growth take back a little place so you can have flowers, so you can have bees, trees, and a whole ecosystem coming back to life. Not that this is a terrible idea. Could be a very interesting experience, but using more pollution to replace what we kill with pollution doesn't really seem like a good approach, right? See, this is what I mean when I say we need to completely review our paradigms, our way of thinking. The best thing we have to do is not to do anything. Everything we move, go shopping, eat, buy, turn on a computer, send messages or instant messaging on our phone. Every time we turn on the oven to cook, every time we go for a ride, we go on vacation, we buy a new guitar, we get our teeth cured by a dentist, we get our hair done and cut. Every time we water the garden, we throw litter anywhere else that needs a dustbin. We consume something without even realizing it. Denial of activity, eco-friendly activity. This is what we need to think about. And yes, it's hell of a burden to view everything through that perspective. And yes, it's hell of a constraint. And no, it's not fun at all. And yes, if we care about that, we save our world. We save lives, preventing suffering, and maybe end up in a much better world that mankind is so advanced and that it survived the worst and can handle this like a charm. So before we move on to the digital sector, I'll just tell you the 5 things we need to do right now that needs to be our priority. Number 1 is pollution in the world. We need to stop using coal. Number 1 risk of failure if we want solution, if we need to stop recycling every material we can do. Also, we need to stop using coals. Number 1 reason why we're destroying lands and emitting greenhouse effect carbon. You have no idea what cow herd costs to the planet. I'm not talking about going vegan. This would be crazy good. But just the cows themselves. Everything that comes from cows is just absurd. It's just not because we use more of them, but because for every kilogram of things we get, like leather, meat, milk, cheese, whatever you want it to be, cows are destroying the planet because we breed them. This is absolutely incredible. The pollution of souls, the culture of cereals we do for cows, we could just handle much more if we just stop eating them. And trust me, I don't do this anymore, and this is really good. You don't give a fuck. It doesn't change your life. Then we have to improve our real estate. We have to improve everything that is built right now. In France, for instance, where I live, the buildings, renewability of buildings is 1 out of 1,000 every year. It's just nothing. So we had to take care about the existing one. This is number 1 way of not wasting energy. And then, lastly but not the least, as we're doing right now, as you're doing if you're watching this, you need to get interested. This is the number 1 reason for being counterproductive and toxic for the rest of humanity if you don't know what you're talking about. And that's it. Might not be the best advice. It's mine. It's nothing more. I'm not a specialist. I got those from specialists. By the way, if you think about recycling materials from electronic devices, you should know that some companies are already working on it. It works. It has a pretty good final balance, but it's not really that rewarding because people actually put less and less rare materials into electronic devices because they made progress and also because they know these materials are becoming rarer and rarer. So like I said, the best way to make things change is to first know about the topic, which is why I did this conference. If you know, you require acting. If you do, politicians will know it. If they act in favor of what you want, they will get elected. That's how democracy works. That's, even though it's different in each country, elections are both a poison and a cure, so are we all. Then authorities, politicians, commissions, delegations will start working. They'll always act with a couple decades delay. Regulations and laws always come late by 10 to 13 years. This current state of things is no exceptions. We've known for ages and we are just waking up. So I won't go far into how to solve or implement solutions globally because there's no purpose of this talk, but riding a lightning bolt, let's say you can act with giving a price to carbon emissions or anything that you can convert into carbon equivalent emissions. Then you can estimate the price of what all this is going to cost, which is a hell of a lot, and carbon pricing is a good idea, even though it can be more or less efficiently implemented. You can tax people to incite, or you can incite people by making them pay or giving them credits to do something positive. You can measure emitted greenhouse effects, or you can give tax rebates to improve housing. And you can also adopt measures globally, like forbidding cars to be circulated or produced beyond a certain way. You can prevent people from investing into non-renewable energy, etc. This map shows how close up-to-date map of the world where countries this map shows a close to up-to-date map of the world where countries started implementing carbon economy, like emission trading systems where you can get credits for not polluting or buying credits to pollute so that they get redistributed for ecological purposes. As you can see, we started moving. It's too slow, but we'll take everything that's superior to zero, right? To measure carbon emissions, you need a standard protocol. Remember the previous slides? This is where we start building norms and laws. However, pollution is not something obvious that you just put a meter on. It's more subtle and vicious than it seems. Greenhouse gas emissions are categorized into 3 groups: scopes, by the most widely used international accounting tool, the GHG, the Greenhouse Gas Protocol. Scope 1 covers indirect direct emissions from owned or controlled sources. Scope 2 covers indirect emissions from all the generation of purchased electricity, steam, heating, and cooling consumed by the reporting company. And Scope 3 includes all other indirect emissions that occur in the company's value chain. When you start including Scope 3 emissions, everything starts being way more complex. And as you can imagine, that understanding how carbon accountability is a nightmare. So, second great part of this talk, let's take a look at the digital sector. We see that global consumption is, with the global consumption, its rise. We saw about how everything is rising. We saw that everything is not going the good way. But what about digital pollution actually? Remember what I said earlier, the main problem with climate change is that we don't feel it. We feel at best with conditions change. Pretty much the same, we don't perceive digital pollution. We feel very little part of it. This time, let's add examples, okay? On the average, a simple email emits the equivalent of 10 grams of CO2, which is about the quantity of an average tree can absorb one day. We can see it, we cannot see it, like gas, exhausts, or river waste dump. Sending an email with 1 megabyte attachment is the same as a computer in standby mode for one night. And we send 300 billion emails per day. And this is just email. Remember, it's still estimated the number one communication source in the world. It's kind of old, not really optimized, consumes a little too much energy, and it doesn't offer a perfect experience, but it worked, and we've made it become a chimera with IMAP, HTML mails, security layers, etc. So let's just say it's not the most straightforward technology, but it's not really easy to set up totally, and more than this, there are norms, there are de facto standards, which means not everyone is following them. But think about the thousands of billions of messages sent every day through major apps. Like, think about SMS, MMS. Think about all the messaging, the instant messaging things. Think about Facebook Messenger, Snapchat, Discord, the video messaging. That's just crazy. Think about the sound messages, the vocal messages. All this is nothing you can see, nothing you pay attention to. You just let it die in some gloomy place. So back on topic. Assuming it's not really visible, where does it come from? Where does it come from? I'll tell you straight away, it comes from many different sources. If you wanted to remember the main two ones, it comes mostly from the things you buy and the things you use. So here's a rough estimate of where digital pollution comes from. As you can see, it comes from all sectors, all type of uses, and it's close to shared between production and use. You can find different sources on the web that pretend that production actually goes up to 75 production, depending on how your accounting methodology works. So about the production, it's about half the problem. Let's think about that. It means that every time you buy something, constructors build more. If we stop buying, they will stop manufacturing. If we stop manufacturing, we stop half the problem. Of course, we won't go down to zero, unless completely abandoning digital, but that's the direction set. And in order to produce a smartphone, we have to move a total of 40 times its volume on the ground. And you think that's just a bit of matter and energy, just think again. We need 80 times more energy to make the equivalent in weight of a smartphone to make a car. That's just absolutely bonkers, you know. 1 gram of smartphone takes 80 times more materials than a car. And about material, we usually start speaking about ecological backpacks. Maybe you heard about this term, virtually worn by electronic devices. For some really small parts of materials, less than a centigram, we usually have to move tens of kilograms of matter, if not tons of them. And about the use, that's the other half. Let's stick to that. So far, despite the really high growth of device and use, thanks to energy efficiency, we almost contain the growth of energy consuming. Hyperscale data centers are more and more efficient. Large-scale public cloud data centers operated by companies such as Alibaba, Amazon and Google, BlackRock or Microsoft fall into that category. Data centers around the world are believed to consume around 200 terawatt-hours of energy in 2020, barely 3% more since 2014. Despite the fact that they tripled as a consequence to new services emerging, digital transformation enhanced content type from text to images to sounds to video to virtual reality to augmented reality. It didn't change that much. Data networks, the equivalent of the nerve system around the world, consumed about 185 terawatt hours of global energy in 2015. As you can see, we have more and more servers. We have more or less machines like your computer, but only scalable, repairable, removable, and curable like working. This is what servers are. And as you can see, there are more and more in large-scale data centers. The proportions are changing. Thousands of machines and more, which means large-scale data centers. And the largest companies in the world are gaining proportions. And those servers usually go here in data centers. Then comes your home consumption and the network's transmission. That's where pollution comes from. Those are huge buildings full of computers in the form of pizza boxes that are stacked in racks, bays, units, sectors, etc. by the tens of thousands. They are all over the planet, including on both south and north poles, because they use a tremendous amount of energy while running, and a lot of heat is dissipated while they run, which is 24/7, 365, 100% of the time. And those data centers are not really on the decline, as we saw. Recent study compared two trends, real world with extrapolations and more laws with when combined with IoT. User behavior increases data center energy needs from 282 terawatt hours in 2060 to 353 terawatt hours in 2030. And the end of Moore law and IoT combined, because data center energy needs are going up to 1,287 terawatt hours in 2030. So this really shows a tremendous growth. And again, remember, this is tamed and contained because we have done a lot of work in energy efficiency in the digital world. So remember, to put that in perspective, this is about 1 terawatt hour, and the total electricity consumption at the moment is around 23,000 terawatt hours. So you see, this is accounting from something. This is your 4% I was talking about. Usually, the larger they are, the more efficient they get when it comes to data center. So what does this has to do with user devices? Well, when you watch a video or an average downstream, like me right now, or any Twitch stream, anything, or video message left on Snapchat, whatever you want it to be, YouTube video, whatever, your device consumes 1,000 times more energy than when it's idle. And it's just 10 times more than being idle if you simply send an email. If you take your smartphone, it's not doing anything, and then you send an email, sending an email consumes 10 times more energy per second it's working. But what is this used for? What is impacting energy demand the most? This is a global scheme of digitalization potential impact on transport, building and industry. Points represent a strategic and expecting domain or key activity for the years to come. We won't even discuss the individual opinions about what's strategic or not, but let's just say it's strategic. The more it goes to the right, the more critical it gets for our development. The more it goes to the top, the more energy it will demand. This comes from EIA. You have all the sources and explanations at the end of the slide. To sum things up, if you simply emit around 1 ton, you just emit around 1 ton of greenhouse effects gas per year because of digital, on the average. If you are a freak like me, you probably are way above this average. This is about 1/8 of our annual greenhouse effects emissions accountability. And what about the digital world we're talking about? So far, we've seen proportions and relative numbers, and how many items are we talking about? What's the size of digital? This is digital. 2 out of 3 people on Earth now have a mobile phone. Their major usage is web. Then comes platform apps. Now, more than half people have internet access at home on the planet. And it's growing really fast. In the use of converting units, as you can see, everything is skyrocketing each and every year. This is what we call an exponential growth, probably more a polynomial one. And look at the years. It all grew up short terms. This is the global internet traffic. The bandwidth consumption of the last slide is essentially phagocytized by Netflix. Then come YouTube, followed by HBO, YouTube Premium, Amazon, Pornhub, and Disney+. The rest is shared between spam, then the rest of the internet in mobile apps, websites, Facebook, Instagram, TikTok, and then the web, email, video games, and the long trail. This is where pollution comes from. With over 9.3 billion hours watched, Twitch is now the biggest live stream platform worldwide. Facebook is still the largest streaming platform because of its user base, excluding Instagram and WhatsApp. More than 1 in 5 Facebook videos are live and watched 3 times longer than pre-recorded videos. This is even more for Instagram, which means it's 15 times more live stream traffic than we used to have in 2017. Mobile and IoT already account for over 30 billion devices too. That includes fridges, wine bottles, drones, cows, which emits around 200 megabytes a year already, or cars. The number of smartphones is expected to increase from 3.8 billion in 2016 to almost 6 billion by 2020, while the number of connected IoT devices is expected to triple from about 6 billion to 216 to over 20 billion units by 2020. If we were to include everything, we could easily say that we're going to approach 50 billion devices. That's one of the reasons for many technology changes to happen, from IPv6 to 5G, 6G, fiber optics, NB-IoT or LoRa, Raspberry microcomputers, for example. And all users spend more and more time on mobile devices. Every time you do something, you generate pollution. Every time you watch, like, answer, comment, send a PM, post a picture, make a live stream, you generate pollution. Because using it consumes battery, it's backed up locally, it's processed locally, sent over networks, stored, presented to others, analyzed to create data value, transferred through networks to be viewed, saved locally again to allow offline view, etc., etc. As you can see, most pollutions come from production when you look at mobile only. This shows values only for smartphones. It's slightly even more polarized for desktop computers, but the market size is now on a very different scales. Also, note that this graph is already a couple of years old, but hence the data with previous slides. By the way, if you just wonder, GWP means global warming potential. It's an index to express equivalence in carbon dioxide, GHG, greenhouse emissions. The ADP means abiotic resource depletions, which encompasses both the use of renewable and non-renewable abiotic resources like wind, flowing water, etc. And abiotic resources comprise all raw, non-biotic raw materials like everything that was not derived from living organisms. These resources include fossil fuels, ore, and other mineral raw materials, construction minerals such as sand, gravel, rocks, and industrial minerals such as silica sand and potash. And HTE, ecotox, means human toxicity and ecotoxicity, which is a way of pollution too. Of course, speaking about production, whatever pollutes is simply due to the fact that we change the machines from simple pocket nano music player to super large gaming stations and workstations. But through the years, we can't really say that we are making progress with durability. However, we're making progress in manufacturing. So tell me, do you see where the problem comes from here? Do you look at these numbers and I think now you're starting to think about a few words like planned obsolescence, all right? You see that. We change equipment 6 times faster than we used 30 years ago. So this slide is a little more technical. You know those packages, repositories we use 10% of? That's what we called software fat. It's also those embedded things that we are not using anymore, but that still are installed on the machines we use, maintain, pool, etc. This comes from the way we design software and implement it. We only focus on a few things. We never look back on the old ones. So this generates a lot of uselessness, imported files, libraries, classes, dead code, commented code, overhead in resources, memory leaks, CPU leaks, etc. This starts at the design phase, where it's the most important. It's not about developers, it's not really about software architects, it's about who's paying for the application design. The true responsible people are there, because they hold the wallet, like we said, with money. Everyone obeys and denies their responsibility in designing efficient and minimal software, because these people just think about money first and the rest is not a parameter to them. People are mandated to supervise software production, but rarely get interested by it. I had people in my job who literally didn't care about what we produced for them. I had a customer once who told me, as long as it's delivered on September, I'll get my extra cash bonus at the end of the year. That's all that was at stake. I literally worked over a year on a project that finally got completely trashed away, and everyone was happy about that. A year. That's who we are. We are the rich children throwing tantrum through management layers and direction phone calls, because no one is really looking at us, nor do they look at what we do. We strongly decorrelated the exploitation from the needs, and the needs from the development from the utility, and the utility from the real goals. We just do things because someone somewhere asked for it. Also, last but not the least, since anything that creates activity has energy drawbacks, cybersecurity does not make an exception. For example, in 2017, the WannaCry ransomware hits hundreds of thousands of computers in thousands of organizations in some 150 countries. This attack did not target energy infrastructure directly, but several energy companies reported problems. In China, over 20,000 China National Petroleum Corporation petrol stations went offline just because of that. So cybersecurity has a price, yes. Which leads to the part here, and probably one of the most important things to understand when it comes to the digital world, the rebound effect. I'm going to cite a paper from Cédric Gossard from January 2016. Listen carefully. Between 1982 and 2012, while final energy intensity in France decreased by 1/3, final energy consumption increased by 15%, from 134 to 154 millions of tons of petrol equivalents. The transportation sector also witnessed important energy efficiency gains. For example, the fuel consumption of a medium-range car dropped from 8.3 to 6.7 liters per 100 kilometers between 1990 and 2012. And CO2 emissions of new average cars dropped from 175 to 122 grams of CO2 emitted per kilometer. In the same period, the mileage per medium-range car remained stable at around 13,000 kilometers per year. These results should have delivered energy savings to the French economy, but the exact opposite happened. The final energy consumption of road transportation increased from 32 to 36 million tons of petrol equivalent, and its CO2 emissions increased by 10%. Despite energy efficiency improvements, overall energy consumption and pollution increased, notably because the number of cars increased from 24 to 32 million, providing evidence of a rebound effect. That's it. That means when we make something more accessible, people use it more and more and start adding uses that were not previously a need. Some people just finally fulfill their needs, but some people, if not all of them, if not all of us, actually add more to that, taking the cars here in this example more for destinations and trips we would never have done before or never have even thought about doing before. The problem with digitalization is that the rebound effect almost applies to everything. Once we made something computer speeds thousands of times that faster than human speed, we tend to overly use it. But it's not only our fault. It's also driven by marketing strategies. Most companies sell data for ads at the top level, the GAFAM, the BATX, Baidu, Alibaba, Tencent, Xiaomi, the Alphabet Group, the Meta Group now, etc., for free services. And the data comes directly from the use of those services. The old motto says, online, if anything is free, you are the product. What makes the quality of advertising on Facebook Ads Center, on Google Ads, on any other services that perfect? Because more use what brings data in. Have you noticed how you're enticed now to produce more posts, more videos, to create content on a regular basis? They do produce. Facebook, Instagram, Google have all the dashboards you need to schedule, to do everything, including for you if you are an individual, if you are selling your own living right now because you're a YouTuber, because you're someone with a huge Instagram account, And they can help you schedule your posts, live stream sessions, create plannings where your people are following you so they can get in touch with you at precise hours. You are becoming a TV, you're becoming a media by yourself. And how do you generate engagement, the world for any activity towards you? Likes, thumbs up, subscription, comments, upvotes, etc. This is called engagement. By simply publishing more and more and more and even more. Up to a point, over 90% of all user-generated content is never seen. Streaming videos, photos, saved online, etc. But they are useful because they contain data. So you're more than encouraged to use those devices to chat, send PMs, post content, quick answer, reply, etc. Every single thing you do is captured and anonymously analyzed. Therefore, that hidden prominent part of the rebound effect is unconsciously enhancing your sharing capabilities. Have you ever wondered why all content platforms starting rewarding and paying their content creators? Do you think the billions spent each year on those people is anything compared to what they sell, the analysis that emanate from what they bring? Guess who has the best turnover at the end of the years? YouTube or the YouTubers? Twitch or the Twitchers? And that is a plague. It also applies to device. For instance, what makes the wealth of Samsung, Apple, Xiaomi, or Oppo? Mostly selling their devices. And how do they make more money? By selling more. And how can they do that once the market is saturated? Well, they can nudge you into changing your phone by making it obsolete through the lack of operating system support, hidden dead code, poor battery life. That's actually between 1/3 and 50% reasons why people change their smartphone. Another one being contractualization ending. Then store applications update their performance reference devices to higher standards, and there we go. You are forcing people to change their smartphones, their computers, everything. Production and manufacturing are responsible for nearly 80% of smartphones' lifetime carbon emissions. But still, studies show we change our smartphones more often than we change our t-shirts. Let's be honest. It's part of what they are that digital devices evolve. That's okay. Also, some of them just break, just get stolen, or just simply stop working after some years. They do provide more and more too. That's all right. We do get benefits from the new stuff. But the thing is, we have to require those devices not to be changed when there's no need to. So we should not blame those companies for the core of what they do, but how we collectively constructed our modern society so that they get out of control. I'll give you another example. Carpooling is not only a new economical trend and collaborative economy example, a brilliant way to reduce GHG emissions. It's something people are doing a lot right now as a way of common transportation. But to help better organize that, some companies have started to position themselves as solutions in that way, like Ola, Uber, Lyft, or BlaBlaCar in Europe. Those companies now make millions for simply acting like marketplaces for transportation. But they do have people working in, owners, shareholders, and there comes the problem. How can they increase their income? They could promote carpooling to enhance global market reach, which means that part would be the same relatively but much more in absolute numbers. But that's not really what they do most. They do mostly try to predate on other market-sharing competitors, which means they do marketing, promotion, advertisement. All these things lead to tremendous amounts of pollution and wasted money. The only profit for that is at best theirs. There's no one else, and they're not, of course, stopping there. To further enhance the use of their products, what could they do more? Well, they could foster us through the use of cars and even further. They have no interest in common transportation. So recently, I saw promotions with gifts in gasoline and gift cards, etc. when joining their websites and applications. You see where this is going? Not the good direction. They are simply twisting something ecological into personal profits and even more greenhouse emissions and pollution. Okay, so this is not the purpose of this talk. We're not here to blame them. They're just like any other company in the world. If we were to selectively shut down companies for the harm they do to our planet, we would never start with those ones, like carpooling. And we could question ourselves a lot when it comes to digital responsibility. Is it better to order on Amazon or locally? Or for local activity, for the retention of a local job for the planet? Is it worse? What's the cost of choosing express delivery? Is it better for the planet with all these pickup points for deliveries? Or have we everything delivered to the chosen address? Is it better? What's the impact of not being at home for deliveries? Should you use a human cashier or a self-checkout? What are the pros and the cons of each choice? Do you remember those large studies a few years ago about how self-driving cars should handle critical risk, crushing non-human animals instead of humans, save 2 elders or 1 child, etc.? Should you buy a digital book or a paper one? Which one pollutes the less? Would get information from a paid media for a free media, funded by advertisement placements from governments, from public fundings? What's the effect on you posting a picture of that happy moment you're living? How long until no one remembers it? Some major organizations like Greenpeace, for example, have made investigations and produced papers regarding the largest companies in the world. They made great reports in 2017 and again during the last years, where they gave marks to digital industry giants. You will have again all the links in the sources section at the end of this talk. But not all of them are pure evil, because they're depending on public opinion. They cannot risk anything anymore because of their sizes, and ecology rhymes with economy. And though some of them could be doing greenwashing, they're definitely going the good way, and many other organizations have confirmed that general direction. In fact, media giant Sky has been carbon neutral since 2006. Adobe achieved the status in 2013, followed by Google in 2017, and McKinsey and Apple in 2018. So please, take the time to keep an eye on on all that when changing your next smartphone too. Like I said, things are really more complex than they seem, and your personal taste in colors, shapes, and operating system choice is not enough anymore to pick up what you're going to change your device with. And about nothing, I just discovered digitaldynamos.com, and I recommend that you try the experience. It's extreme, but it's kind of awakening. It's an immersive website experience provided by the Red Cross Red Crescent movement. Just give it a try. So, what's digital responsibility? It is, as you can guess, a much broader beam of topics, conscience, elements, and facts that you can imagine. It actually goes way further and beyond simple awareness about energy, atoms, and molecules. It's not only about your equipment and device, it's not only about how to use them, it's about what you use them to. So why did I make this conference? Well, I said during the introduction, I'm not specialist of anything, maybe a little in digital, but that's all. But as we saw, politics are not a world apart, we are politics. If you remove humans, no one really cares about humanity. So I started learning about all this because I sensed something really bad was happening. And I hate discussing science topics without fundamental knowledge, which is why I also share it, make conferences, YouTube playlists, social posts, etc. I actually challenged myself during the COVID-19 pandemic to discuss with a handful of reluctant people who were refusing to get vaccinated against it. I want to think publicly that I succeeded in changing the world, but I can tell you I gave them all the keys and knowledge to understand everything. They told me that they would book vaccine appointment by the end of the day. We're going to talk about it in a minute. In 2019, a study showed that 69% French people believe that nuclear energy contributed to Earth's greenhouse effects. 86% of 18-24 years old did. In fact, nuclear energy, we saw that, is not carbon-free, it's simply low carbon. So they're not completely wrong on that, but most people believed it was the main source of global warming. I can't recall that precisely, but I think a long time ago, I started confusing those two ideas, even though I clarified that pretty fast too. I'm also convinced that most people know about some kind of global warming, remove the quotes, but not up to what point. To be honest, I did not either. And I'm also convinced that when you call out to people's intelligence rather than their ability of repeating things they hear, you make a stronger world. So as of this talk now, I will not take time to discuss everything from carbon diagnostics to acting, from refusing to contribute to pollution to changing your life habits. I won't tell you not to travel anymore, how you can affect your life and everyone else by eating no more animal flesh. I won't tell you how bikes can be amazing from the planet, how common transportation should be free, how you should massively install heat pumps in all buildings. I won't tell you about government building isolation policies, about how you should stop using motorcycles, how we should use nuclear energy, dams, better sun-oriented houses, require all buildings to have primary energy efficiency neutrality. I won't tell you about changing your everyday habits when it comes to heating your home, optimizing your motorized path, living closer to the locations you often go to. I won't tell you to use phone over instant messages. I won't tell you about state children limitation policies. I won't about sharing housing and flat sharing. I won't tell you to drive slower, not to have kids, to drink tap water instead of buying it from bottles, to change your bulbs, to close your shutter outside when you go to sleep to have better isolation. I won't tell you 1,000 things of advice not because I don't want to, but I don't have the time. So I chose to focus on one domain, digital, which is why we are here. But all this global contraction, this lack of energy, the material production against the exploding demand is going to have way many more ripples and effects than you can imagine. Because all those events are going to happen at human lifespan pace, which means we won't be able to rely on the death of previous reactionary, change-reluctant generations. Now, all this is happening within shorter and shorter time spans, which means the thoughts of people are going to be shaken when we still have power, when they still have power. This video and conference is recorded in 2021, right now in 2021. We've been in the COVID-19 pandemic for 1 year and almost 12 months now, and it's far from over. We've seen more ways to waste energy, lives, and indirect consequences of digital failures. Right now, there are two opposite directions we can take when it comes to emerging advances in robotics, computing, and information theory, nanotechnology, and genetics. We can either use what we discover, invent, create, and fabricate in a negative way, or do the same in a positive way. Personally, but that's very personal, I call going the negative way digital segregation, and I call going the positive way transhumanism. I'll let you all appreciate and criticize all these words, but make sure not to mix them, for you can very often stumble upon people who sometimes, on purpose, hijack the terms to change their meanings. On one hand, we have to continue research, we have to push science to improve technology, what we do today, generating what we've been reviewing over the last slides. On the other hand, we need to make sure we don't create polluting habits among the population when pouring the benefits of this on it. So when it comes to progressive within those domains, humanity is permanently walking on a thin, dangerous wire. You can see a parallel in atomic energy advances. It's up to you to remember the bombing on population and weapon tests, so you can remember this is one of the best contemporary means of growing forward without destroying climate, and also a weapon of peace and not a weapon of war, but that's a deeper consideration out of topic. There are many reasons for us to take a pause and realize how much we have accomplished over the last years. It's actually making us dizzy to overlook at everything we've created. 30 years ago, people were taken for fools when writing that they'd communicate with the other side of the world in less than a second using video. 9 years ago, we managed to set evidence for a fraction of seconds of the scalar boson, the boson of Higgs, the last missing particle in the standard model, allowing us to better understand why certain particles have mass and some others don't. 4 years ago, we set evidence for gravitational waves, while proving two black holes were fusioning far away. 2 years ago, we modelized the first picture of a black hole. We are progressing at tremendous speeds, but there's a problem. As we advance, we also have a shared responsibility of letting no one on the side. Otherwise, we create that digital segregation. There are not only physical problems when it comes to digital, there are many more. Digital is now a common support for information, for services, for trade, for everything in our everyday lives. As we have no idea about how many things we do, we have no idea what the extent of a digital world will lead to. There have been many ways to represent the fact of creating something and then watching it spread out, ramify, and then see how great and fast it can be used to get way beyond what it was originally made for. Atomic energy is a good example of that. Internet is another one. Gunther Anders once spoke of what he called Promethean shame, from the mythos of Prometheus, who brought the fire to man, which etymologically means one who thinks before. The shame given by the humiliation of realizing how far what you create is going. But not everything is bright, especially when it's supposed to be a space for freedom and minimal control. This is an original picture of astronaut Edwin Aldrin, taken in 1969 on the surface of Earth's satellite, the Moon. It took 400 NASA employees and contractors to put Neil Armstrong and Buzz Aldrin on the Moon in 1969. But only one man to spread the idea that it was a hoax in 1976. A recent poll found out that 1 in 6 British people agreed with the statement the moon landings were staged. 4% believed the hoax theory was definitely true, and 12% that it was probably true, with a further 9% registering as don't know. By the way, it took about 70 kilobytes of data to send an astronaut in space at this time. It's about the size of a typical email today. Think about that when it comes to data optimization. This is in Italy, 2020. A few weeks ago, Francis Goncalves from Cardiff lost his brother Shaul, 40, his father Basil, 73, and his mother Charmaine, 65, to the virus. Yes, the COVID-19 virus. They all refused to take the vaccine after watching anti-vaccine propaganda. They died after they started to feel unwell on the week of July 10, after having a meal together. Francis said his family did not ever get vaccinated because they had been scared by anti-vaccination misinformation. And he has now been bombarded with vile messages, death threats, and has been accused of lying about the deaths of his own brother and parents. Since then, people have organized to visit the tombs, ask him publicly to release death certificates, and many other threats. This is why we go wrong. This is what we create when collectively responsibility hits us through the offline talks or online discussions. This is a burial site in India. Before burying, the majority of people are Hindu and desire to be cremated. This was an aerial photo taken during the COVID-19 crisis last year in 2020. You might not be familiar with that place in particular, but the attached report says it's 100 times more than usual. You can see the pictures taken with drones of smoke billows, miles and miles away up to the sky. This is the Capitol in Washington, US, on January 6, 2021. It's the meeting place of the United States Congress and the seat of the legislative branch of the US federal government. After losing the election, the former president's supporters, slightly incited by him, suddenly appeared and invaded. After months and months of repeating false accusations, denying elections, independent commissions, congressmen, etc. 5 people died, either shortly before, during, or shortly after the event. Many people were injured, including 138 police officers. 4 officers who responded to the raid died by suicide within 7 months. Everything was organized thanks to digital supports, private groups, ciphered messaging. Even though part of it was public, the vast majority was privately organized. All that on digital supports. Those, if I were to zoom in, the sources are the Elder's talk, you'd see that are the papers called Technical Report TR Release 16, emitted by the third generation partnership project with 3GPP, a global organization of telecommunication standards of what is called the 5th generation of mobile devices and networks. Namely, this is part of the specification of what we call 5G. This is 5G. Technical documents of reference to define how everyone on Earth should interact with mobile devices so that it's not a global mess, which we called norms. If you take a moment to look at this, not in details, you see you need to be a little qualified in network engineering, and that's okay. I want you all to do that. Look at that. These are 50 and something pages, I don't remember, of a report. And this is a series of flasks containing a few doses of Pfizer Laboratories Comirnaty mRNA vaccine against COVID-19. It's a 45 milliliters liquid solution that contains a mix of ingredients. One dose, 0.3 liters, contains 30 micrograms of COVID-19 mRNA vaccine, which is embedded in lipid nanoparticles so that it doesn't decay into those vials, which is basically a series of codons, a sequence of nucleotides, which are made of nucleosides, organic information, and a phosphate. Here, the sequence is one of a spike protein of the virus called SARS-CoV-2, the one that's responsible for the COVID-19 pandemic. mRNA was discovered in 1961 by 2 researchers, Jacob and Monod, in Institut Pasteur in France, for which both of them got a Nobel Prize. This is exactly what viruses have been doing since the dawn of host existence, which is probably since life itself existed. Actually, viruses may have existed way before us. And we get infected thousands of times per minute by viruses. Every time we breathe, we could inhale up to 2 million viruses. Using the same exact information replication technique than the one viruses use, with partial sequences only, we proved the safest and more efficient technology than any other previous technique in virology for many diseases. And we did that. And then there are excipients. ALC0315, ALC0159, and DSPC. Those are synthetic lipids, fat, basically. They are here to encapsulate and protect the mRNA until it reaches the body. And then, a few common molecules to ensure solution viability like sugar, salt, water, potassium, etc. But as for every new discovery, science facts, some people become refractory to the mere idea and decide to, quote, act against it, like you could act against the fact that people have knowledge, whether this idea concerns them or not. And we need to think about that. Why are they skeptical? What makes us refractory? Why do we suddenly decide to be against something that goes way above our heads and that is just knowledge? You cannot be against something that people know. If you remember the pictures of the 5G documents on the previous slides, by the way, you remember that some people actually said, repeated and spammed that one could put those virtual documents into the flasks through medical needles. I wanted to leave a pause here so that we all take some time to see how far we've been with the complete lack of basic knowledge, so the people can write and spread things that are completely irrational. About 5G. This is communications relay and antenna. It is made of a 230 meters high antenna and a 40 meters high pylon dedicated to digital television. On January 11, 2021, those and two other antennas were set on fire by so-called anti-5G activists, who named their operations from, let me quote, noises of winds and bird songs, which has nothing to do with the antennas, actually. Problem: none of those were actually 5G carriers. Half of them were dedicated to television and radio only. For a few days, 1.5 million people remained without any TV or radio broadcasts. Some of these people live in the countryside with little outside communication to the rest of the world and their relatives. Some of them were elderly people who had this as their major daily presence with them. I know this place very well, for this is actually located 40 minutes south of my flat, which I'm talking to you right now. I just need 30 minutes or 40 minutes to go there. See, I didn't have to travel a lot to find examples of such actions. 5G is really debatable in terms of ecology and social impact. It's ambiguous, for it's made to be simultaneously a way to better use mobile networks for the worst and the best. Remember about the rebound effect. Is it better if people can video chat with their families where they're gone thousands of kilometers away? Is it better if people can like posts of models in bikini or latex posting with their dogs and posting 10 times a day the same profile shots? Is it better if people can have connected objects like personal cars, police vehicles, fridges, wine bottle, this is true, heating systems? Is it better if people can live stream videos of themselves doing nothing else but living their own lives in public to thousands of people at a time? Is it better if a surgeon can monitor a live emergency surgery assisting a colleague from a tablet while being on a train? Is it better if our current mobile networks get desaturated finally? Is it better if manufacturers push people to massively change their mobile smartphones to get 5G compatible ones? What I know is that people don't receive information, fabricate their own, imagine part of it, or falsify it willingly or not. The consequences can be devastating when they do so, despite having the best intention of the world. The people who are against 5G or vaccines are not badly intentioned, they just want the best. They just don't know what the best is and how to find it. And about COVID-19, as you know, this is what saddened me the most. This is not only the people who couldn't dodge the virus, but those who could and chose not to. Those are mixed. So many hoaxes, I can tell you a whole list. It's dizzying. The people who mixed all those hoaxes, it's I don't even know what to tell about that. All we have left from them is that pictures from all social media accounts sent by families to media, people who were probably happily living their lives, but who got captured in the vortex of news, live reactions, the complete mess of giving a microphone to anyone, including the less qualified people to speak, and the idea that everyone should have an opinion on everything, even when they can't. Collectively, we failed. These people died. We considered them as peers and they still died, ignoring the other people or common sense. This also falls under digital responsibility. What if media did their jobs correctly and broadcasted science instead of making audience from creating cheap controversies? What if we all took a better care of giving science fundamentals to these people? Where did we go wrong? Can you really blame them and only them? How far can you think you can push individualism until you realize this is a social collective failure? And what shaves me is if these people couldn't even understand mRNA vaccines and why pharmaceutical companies are also hung up with the rope around the next in that situation, what do they see when they watch the CERN presentation announcing the evidence of the Higgs boson? How do they perceive laser inertial confinement fusion for fusion-based atomic energy experiments? What can they understand of the relativistic Doppler effect blue shift redshift wavelength measurement that I talked about a few slides ago that helped create the Laniakea modelization that I showed you at the start of this conference? How can you achieve such complex things when you're still given that the result of a nationally United States representative 1,000 subject poll, part of the 36,000 subject 2016 cooperative congressional election study, and another analysis of the universe of social mediums mentions that geoengineering were analyzed. The former shows that 10% of Americans declaring that the chemtrails conspiracy as completely, and a further 20 to 30% as somewhat true, with no apparent difference by party affiliation or strain for partisanship. Chemtrails conspiracy is people simply observing an insignificant details like condensation trails left by planes at high altitude, mixing that with agricultural aircraft used to spread fertilizer, pesticides, and water over plants. The widely debunked idea that airplanes are spraying toxic mix of chemicals through contrails, which with supposed goals ranging from weather to mind control. Conspirational views have accounted for over 60% of geoengineering discourse on social media over the past decade, of which chemtrails conspiracy is a part of. Of that, Twitter has accounted for over 90%, compared to 75 of total geoengineering mentions. Anyway, I could give examples for hours, but you got the point. The question people always need to ask themselves is, how did you know? When, where, and how did you get the information? Did it come to you? Did you search for it? Did you do what do you call searching? How did you search? How did you make a no bias search? Our common responsibility is to help people by questioning them the right way, the wise way, the way we build science. And this way, we don't doubt everything. It's not that easy to understand that what is given known or not, what you can verify or not. And more than this, how do we as mankind know? How did we discover this and that? How was the world before and after we learned something? Did we never knew about the Higgs boson before 2018? Did we never know about the shape of planet Earth before Galileo? And how did we prove that Earth was around 2,000 years ago? Did we never know about oil before Drake drilled the first oil well in the United States? Did we really never know about how far the moon was before sending men on the moon? Did we really have to wait for the time we were able to observe planets in our solar system to determine their existence, size, rotation? Did we really have no idea what DNA was before 1962? The question is, how did we rationally learn and get to know things at epochs where we had nothing like today at disposal? And you, yes, you, listening to me right now, how did you learn things that you didn't even have any idea of? Do you remember how you learned, how you acquired that knowledge you have? And if so, do you remember that moment when you acquired certitude that you knew about some things? You might be mocking flat earthers, which is tempting, but definitely not a good way to go for none of us. But can you tell me how we knew that? How we know about the shape of Earth, the size of Earth? And how did you know that? You know about DNA, about chromosomes, right? But can you explain how they work? Can you explain why your cell from your foot isn't a cell from your eye? Can you explain how a car engine works? Can you explain where the energy comes from in a gasoline? You never saw your lungs, but you know you have two of them. What proves you this statement is true? As a photographer, there's something I tell most models. You think you know yourselves more than anyone, right? Well, how many times did you look at yourself from an outside point of view, and from which angle? How many times have you seen your complete back, from heel to your parietal bone? That's a major problem here, which I won't go deeply into. But you need to think about how you understood things from collective knowledge without ever being able to prove them. This is why negationists exist. This is why conspirationists exist. This is why beliefs, faith exists. When you lack a point of rationality, either you can intellectually represent your lack of knowledge, either you fill in the gap with whatever pleases you. And if you choose the latter, you might start searching only for things that please you instead of things that are proven to be true. Because we have to admit it's hard. It's hard to prove and demonstrate everything to everyone. Because this requires educational time for knowledge transmission. Because this requires a specific mindset and focus. Because humanity can't spend everyone's lives redemonstrating everything to everyone every day. This is simply too long. For that, it is our mutual responsibility to share knowledge, to give adequate sources, and sometimes to explore doubt. Because doubt is natural and sane. But you cannot spend your life doubting everything, especially the millions of mechanisms you passively use every day, which have been invented, discovered long before you were born. You can be a flat earther and use GPS. You can live in a world where diphtheria is no longer a threat, and your country, you're pretending against vaccines, especially 180 years after we started using them. But yes, if you want to fully understand how they work, this would require basic knowledge in Einstein's relational theory of relativity, or memory T lymphocyte secondary response and interleukins. Maybe that's a little more than you think you do. And this leads us to an epistemic concern, which means linked to knowledge. How do we provide access to knowledge to everyone? It would be another full conference to explain how a paradoxical evil is currently segregating our masses. I would love to talk about this for hours, and the social aspects of the crisis we're in, which we are far from exiting, but I chose to really try to remain purely on physics ground for now. Just to sum it up in a few words, we have let, in many countries, liberalism destroy our educational system. This is not about a country in particular. This is could apply to many different ways to many scholar systems. Of course, I could talk especially about the French one, but this is a general trend, which means as a result, we are segregating, cleaving the masses, and reproducing social classes through our educational systems. In short, this is also strongly linked to intelligence, and intelligence strongly linked to genetics. Life experiments, unfair social constructs, injustice in structures cannot totally overwhelm what people are, but it can definitely help aggravating the consequences of its tacit destruction. I know, you're really wondering where this could go, but unfortunately I don't have enough time to develop all that. So on the other side of this paradox, we have to realize that human knowledge is extraordinarily increasing. At first, there wasn't enough knowledge to let people in school for too long, and we saw, before the main source of human production means the human themselves, we didn't have the time to go to school. We have the time to survive through action over intelligence. And then we didn't have the time to go to there for too long. I could speak about my grandmother, born 1926, who always told me she was put in a field to work with her hands and manual agricultural tools. I wish you saw her fingers in the end before she died. than how she got removed from school at the age of 13. 13. It's not really old, is it? 2 generations later, I left the educational system after a master and 6 diplomas. My first diploma, the French baccalaureate, doesn't even count as a diploma nowadays when it comes to recruiting. And it was given to me 5 years later than my grandma stopped going to school at her age. I finished university and engineering schools 11 years after being her age when she did so. Almost double the age she had. That's the gap within 2 generations. Therefore, at one point in time, we were able to generate educational systems where people could receive 2 things. One, they could receive global knowledge about what we know about the universe, modulo the insufficiently consensual knowledge, still classified as research or edge knowledge. And 2, they could receive the tools that a human person would need to apprehend life afterwards, which is the keys to understand what you don't already know, what humanity doesn't know yet, but that is going to appear and get to be known within the next decades before the people who are at school right now could die from aging. And this couple of knowledge is very important. In the digital sector, we know that giving basic knowledge in algorithmics, programming, object concerns, database, modelization, etc. But we cannot learn more than 3 to 5 languages at a beginner's level among the 600 and more currently listed on Wikipedia. And as you know, there's no shame in that. We can start learning many things without having even thought of them, just because we had the keys to apprehend them. When I got my last diploma, like 15, 16 years ago, Docker didn't even exist. Container orchestration didn't exist. Deep learning didn't really exist. Now, I make conferences about all that. So, later it has become impossible for a human mind, whoever this mind will belong to fully understand the world humans live in right now. This has become definitely out of reach a long time ago. Speaking right now, this would mean, should I estimate it in time without making up all the reactionary people in the audience and all of the aficionados of things used to be better before, that I would estimate this period to start between the First and the Second World Wars of the 20th century. When we stopped teaching only languages, history, geography, maths, philosophy, and literature and biology. To me, that was when we started including, before the end of high school, electronics, physics, chemistry, computing, engineering, and economy, mostly, which is quite recent, depending on the country you live in, and highly depends on the country's economic development. Starting this blurry point of time, and after that, we didn't and couldn't teach future generations everything we knew about the universe, our world, and our society. We started making the selections, specialties, and battling every year over the proportions of each topic to be taught and the age it should start to be taught. Past that moment, we could only select the fundamentals, general knowledge, civic fundamentals, the ability to communicate, and the basics of modern science. I think I consider myself to be among that series of generation, not among the last ones, but closer to the end that it's going to be in the beginning. But then came another era, the one we are currently in. The one that, to my definition, which is highly debatable and criticizable, for it's very hard to prove, we should have the debate over these two, but I don't think we have the time now. But this era saw the arrival of many tools, easiness, distractions, opportunities, objects, topics that young generation couldn't even pick up everything and therefore started missing the basics. And to be fair, none of us, I'm talking to the adults in the room, yeah, the boomers can stay too, would perform better than the young generations right now. We would do exactly the same. Because right now there are so many things to learn about, so many fundamental knowledge is being challenged every day that it has become a true challenge to get past fundamental knowledge. I mean, right now pupils in high school in my country receive basic introduction to quantum physics, to wave particle duality and energy transfer. Wow! So many things that 21st century youth has to learn. Why the boomers are being busy telling them they don't know half what they themselves used to learn, right? while the boomers right now actually still fail all the basic tests that students don't go through, so don't laugh at them. And the thing is, when all those strata of necessities of new domains of knowledge accumulates every year faster and faster on top of our heads, we start giving less time and attention to fundamentals. And it's not our fault. We start paying less attention to language, writing, reading, expressing oneself correctly, and soon this expands to science as well. So now we can have a situation where people read anything anywhere and are unable to proofread it, but able to spread it widely, especially when it tells stories that simplify everything, including things we don't know to answer, but things that we like to hear or read. And this is what we call the ignition of the ignorance bomb. How can people know that the Earth is flat? That the Earth is almost round and not flat, and about 40,075 kilometers round, if people never got to know how we learn that? How can people not write that vaccines can contain 5G technology if they never learned about the wave transmissions, electromagnetism, or memory T cells? How can they not write the majority of people who die at the moment from COVID-19 are partially to fully vaccinated and lead to a conclusion between those two assertions if they never were told about causality in conclusions because of the sizes of the initial studied populations were completely different? It's not because you see it's not because you see blood more often on the roads next to car accidents that cars do bleed. It's not because you see more often leaves when it's windy that the wind is made of leaves. Or if you prefer, as we saw in 2020, it's not because a really minor study early published that people who smoked had 23% chances less among the same population sizes to get COVID-19, that nicotine prevented COVID-19, see? And this is the moment we are in. This is the moment where we realize it's impossible for us to go the same way. It took me 4 days to understand basics and to realize the mass majority I still completely didn't know about in mRNA, in virus spreading here in R0 factor, for SARS CoV-2, how it attacks the human body, the spike protein, the history of coronavidae, the phylogenetic proximity with SRS-CoV and RATG13, and how modern vaccines work, the principles of vaccinations, the basic words about liberty and how to face a situation where you know nothing, Jon Snow, but you still want to feel less ignorant. It took me 6 hours while I had a rhinopharyngitis to challenge myself and see if I could explain all this to a person who said she knew nothing and about that, but had publicly given signs that she wanted to know more, and that knowing that no virologist could come to do that, that the person, give the person all the sources, explain where the sources were, up to a point she told me she would make an appointment to get finally vaccinated. She's probably listening to this talk in French, but yeah, I'm sending her best wishes and a virtual kiss. I hope she's alright. And that's part of our problem too. Knowledge does not come for free. It's the succession of thousands of years of experimenting, research, learning, and transmitting. It takes time, patience, and investment in passion, in time, in will. In a world where economy is on the brink of collapsing, we long started to express everything through the value of money. When you monetize everything, you end up in a world where knowledge does have a cost, despite the appearances. But the good news is, if knowledge has a price, you can replicate it. And then you get 2 people with knowledge, and it costs you close to 0. You see, information is something you can replicate and have multiple copies of in multiple individuals, and you don't need to pay for that. Like all the things you might not know before watching this right now. But there's a drawback. Doubt is costful. People in doubt are in pause. They're not advancing, they're not progressing. And again, it's okay to doubt. But if we all do, the world stops. While we remain in doubt, the world around us keeps revolving and moving on. For instance, you might be in denial of climate change as an individual, but this has been demonstrating through consensus for decades now. And while you're still here pondering, the world is dying. It's the same for every decision you take while expressing doubt. And I can tell you very often doubt is the proud and unassuming version of ignorance. Because saying, we don't know when you don't know. And because asking for simple answers when the problematic is complex doesn't lead anyone anywhere. And in the end, with misleading directions, you end up with overthinking from non-specialists. Because one's ignorance is not the world's ignorance. Because what you call doubt is not a specialist's doubt. Because even when you finally find a specialist in doubt or in negation, doesn't mean you found out a proof of negation. I'm a software engineer, and I can tell you I've known many really bad software engineers with a lot of diplomas. I've had 5 diplomas post-baccalaureate, and I can tell you I have written some seriously bad piece of software for my life. I can tell you there's no guarantee ever that anyone who's obtained a complex diploma within many years of study won't go nuts one day or another. Here's an idea of a railroad comparison I sometimes take. If you admit that a doctorate with 8 to 13 years of studying in their field of research can blow a fuse and kill someone cold-blooded, then you can admit publicly that they could more or less blow less of a fuse and lose their minds enough so as to become bad in their domains and counterproductive. Whether it is quantum physics, genetics, family medicine, artificial intelligence, ancient green, pedology, or whatever you want it to be. Which leads to a quite awkward concept and a series of unfortunate consequences. Up to the 90s, before the broad access internet for the masses, communication was often official, public, due to the extreme costs of technology starts. Then public plus private, then it became easier to set up. As of today, it's so easy to become a content producer through the media services as being a Twitcher or a YouTuber, and it has become a job, more than this, a dream for many teenagers. The problem is that social media networks have changed the deal without anyone having planned this. They all were first media for individuals to connect people, and guess what? It works. We're now in a paradigm where we can be and go anywhere on Earth and still keep strong bonds with anyone else. That wasn't the case 30 years ago. We need to be aware of such paradigm shifts. And while existing in that bath of information, we can sometimes stumble on non-rational, non-aware thoughts of contents where people who lack knowledge still feel like they should speak out, loud, very loud sometimes. And you usually never get arrested for saying words wrong and saying things wrong out loud. No one is going to sue you, right? Just because, as for climate change, you don't harm people, someone in particular, when you talk about chemtrails, autism and vaxism, when you deny Holocaust, when you just invent secret societies like New World Orders, Illuminatis, or anything else. You're hurting everyone at the same time. Because for some of these, they've been running for the centuries now, and all the data used, the network, the devices, and all the web searches, everything has a cost. And this is absolutely free and totally useless and counterproductive pollution. Because someone has to host all your ignorance. Because then comes all the conspirationist contents. Then the debunking content, the debunking of debunking, etc. The amount of waste generated by all ignorance may not be equal to the price we pay for knowledge. But it certainly accounts for part of total pollution. And that, in the end, leads to people speaking out there beyond their abilities and domains of knowledge. Because in order to get a simple glimpse at what you don't know, in order to know what you don't, you actually need to know. It takes years for specialists in domains to finally realize how much they don't know about it. I can tell you about my domain. I've been working in software development, architectures, and ecosystems for 15 years now, and just like Jon Snow, I can tell you I know nothing. But I know how much nothing I don't know. And that greatly helps apprehend the domain I'm in. Because any given ignorant person could use the same terms I use every day and pretend to assemble a very close to credible reasoning. But using the signifier doesn't mean you understand the signified. Yes, this is semiotics. You see, you have a long way to go with what you know, what you don't know, and what you know, what you don't know. How far does this get? Look at this. This is something that struck me at the beginning of the COVID-19 crisis. If you're not French, you may have missed that, of course. Remember, at that time, at the beginning of the COVID-19 crisis, beginning of 2020, everyone around the world was extremely tense, and we started to see how many irrational behaviors arise. Like we already had them, but they surged out. At this time, the WHO had only one recommendation regarding COVID-19, an antipyretic for the fever and antalgic pain like paracetamol, also called acetaminophen. Then came the corticosteroids in September 2020, then interleukin-6 receptor blockers on July 2021, okay? 3 different molecules after almost 1 year and a half. But then, at the beginning, the media started to approach science and research like they do for ideas, which is definitely not the same. When confronting ideas, people usually invite pros and cons in the same proportions, and sometimes alone for interviews. But this is not journalism. This is absolute danger. When you invite someone dangerous without proportional contradictions, you become dangerous yourself. So the TV shows and broadcasts, the radio, the paper, YouTube, etc. became filled with pseudoscience debates between totally opposed people for very critical topics. Researchers were welcomed as people of knowledge, and science became shadowed by scientists. Knowledge disappeared in favor of people and names. And at some point then, right at the start of pandemic, in a country, France, where people got forced isolated at home and all across the country, a public poll was open. Yes, you understand me well. A public poll made by some public organisms that were paid by newspapers. And that poll asked, it is what you see in French right now, that poll asked people about a research topic that not even specialists knew anything about. It asked them about their opinion on very complex topics, on a medicine molecule, regarding what kind of accreditation doctors should have to use to prescribe it. And then they were asked their opinion on public funding of different location types and research center. The funniest thing is that this poll was massively broadcast on private media owned by people and producing contents that were both against public economy. Yes, lol. So I'm going to take some time, but because in French people could see that, it just says, do you think? Remember, this was April 2020, the very beginning of the crisis. Do you think that chloroquine is an efficient treatment against coronavirus? Remember, no one has any idea about that in the world at that time. Absolutely no one. Not even scientists and even chloroquine specialists. No one has any idea. People answered the poll. Only 21% people said, I don't know. 59% said, yes, we know that is absolutely wrong now. And then, if we should have this prescribed to people, should this be enlarged to all city doctors or only restricted to hospital doctors? And then should it be enlarged to treating people with only light symptoms or only people with heavier symptoms? And do you think right now that the public powers in France do sustain and support sufficiently or insufficiently research, public laboratories, great private laboratories and in pharmaceutical industrials and biological startup? What the fuck? I think at that time I chose to get drunk when I saw that, because I was like, this is absolutely nonsense. This is the opposite of rationality, this is the opposite of intelligence. I've been completely blown away by this when it went out, really. So this is an attempt at summarizing how digital anthropology and sociology can go bad. See, we have a natural trend to assemble with people who are like us, who look like us, who come from the same place, share past ideas, who think like us, who agree with us. This is what we call homophily. Homophily leads to people assembling in social layers, colors, ethnicities, political and social opinions, wealth, etc. This creates groups and relationships. These relationships generate magnetic behavior across population. People gather in places where they feel safer for being similar. And within those places, physical or virtual, borders are non-porous. And what is expressed inside bounces all around, and people start become each other's source of information in a circular system. We call that echo chambers, regardless of media type, broadcasting or social. Such echo chambers remove contradiction, opposition, therefore giving the impression that suddenly many people agree with you. And this creates a cognitive bias we call the false consensus effect. Then comes the digital-only part. When building social platforms, it was empirically observed a long time ago that confronting people with each other at random is not a good idea. People are unable to communicate and have individual reasons to defend their different worlds, which leads to impossibilities upon agreeing. So all applications, websites started amplifying this. Why? Because in the end, people had bad opinions about the messages, but about the media, the carrier supporting it. Which means when you talk about people who just go flaming against you on Facebook, you end up hating Facebook too. Considering we saw that these people depend on people using it more, they determined that by actually analyzing users' activity, they could offer serendipity, which means filtering and similar content, locking them in their bubbles. And talking about bubbles, there's another problem. On social media, there are too many things produced now because platforms promoted the post all the time or die business model. Up to a point, brands pay people to capture other people's attention all day long. Therefore, networks aren't able to show all new contents to users. You simply cannot follow all your friends and see everything they posted. Simply because there's too many of them while usage of time and focus were going on. So there's a need for filtering and sorting that would interest users more first, which then condemns the rest, definitely. This is called filter bubbling. And that leads to thinking there's only one world full of things that go our way, up to a point when they possibly don't, and when they read them, they misread them, and we reject we reject what doesn't go the way it was pleases. So we start interfering with search bias, like searching why X kills people instead of searching is X dangerous. Just like a physical debate, you would ask a person for, do you confirm that I'm right, instead of asking, what do you think? And this is called the confirmation bias. When you finally mix all that with the current pace of new topics to discuss every day that go way over our heads, when you realize our world is actually accelerating its pace and advances its phenomenon analysis, when you realize we simply create polemics faster and faster, up to a point some totally useless polemics only last for a few hours now. And finally, all that we call communal reinforcements, which simply means we repeat things over and over against all rationality, which is also called the Dupian effect. Except the Dupian effect doesn't exist. It's actually just an anagram of my last name, but everything else does. See how fast we can generate false information? How long until you would figure that out and go to the internet to say, wait a minute, I can find anything, this does not exist. A great experience, which I'll let you read in details in many social posts on Wikipedia, is the conformity experiment of Solomon Asch. This is one of the most famous experiments in human psychology for the masses. In short, a group of people were presented in a room to answer public basic questions, like this on the picture, which bar on the right is the same length on the one on the left, which is C if you got good eyes. Except the number of really random people was not 100%. Sometimes only one person was really randomly selected, while all the others were actors who were asked to answer the same wrong answers all the time. You get it? And all the tests were really obvious and easy. There was no doubt or anything else that would interfere, okay? So in short, the results were mind-blowing. At some point, any given subject would start behind the majority, even after answering correctly more and more to answer things wrong. This social experiment on conformism is really amazing and still shows how fast we can manipulate each other's in both right and wrong ways without being aware of it sometimes. As usual for any given science experiment results, I suggest you read the full protocol and results. This experiment is also renewed from time to time to see if anything changes among the population. Okay, one more topic before you summarize everything. It's hard to mention those facts about energy, materials, ethics, psychology, or business without talking a little about economy. So this is the longest slide because I chose to let everything on the slide only. This one I'm going to be lazy. I will just read it with you. We still have no physiological, no psychological explanation why the human body never ceases to become more and more obese as soon as nutriments are provided. So it is for capital, poverty, and money. No one ever approved the fact people started initiatives individually, organizations, collectives, companies, states, etc. No one ever approved your business, nor did you justify what it brings to society. It just exists, within a minimum legal frame. We thought only the laws of market could channel you and justify your existence or not. Once started, you and only you have a sovereign state legal ownership permission in the absolute majority of the Earth territory. Therefore, workers and employee workforce are separated for the means of production, the ownership and the property. Also, workers are separated from the results of productions, the generated surplus value. Which means the only purpose and finality for such structures, the producing ones, is the lucrative one, the capital accumulation. This is the base for what we call economic liberalism through entrepreneurial freedom. This is solely based on autocratic, disconnected, hence infinite growth, a concept that was widely taught in all strategy and economy tools. The global frame in which this growth is supposed to remain undefined is supposing that the sum of all initiatives can grow infinitely as well. Those three statements, once added, the separation of ownership from the generated value and the lucrative purpose of entrepreneurship, are the fundamentals of Karl Marx's definition of what we call capitalism. It's a mechanic that is an extension to liberalism. Capitalism is the vastly majority doctrine the world goes with as of this day, since Middle Age, through diverse steps. This means that the market economy is totally independent from the energy and the material market, but remains completely unregulated in its purpose and justification. This all signifies that, concomitantly, while our civilization is based on non-sustainable promises, the way we built our resources exploitation and allocation amplify the damage done. Regarding the point one here, I would say this is linked to the animal universe. We're all born with a one shot of existence, and we are given a special burden, the conscience of it, through our neocortex. We are mortals. So we have a very slightly temporary assembly of atoms made from death of other organisms to create something living, us, that will decay in death again to create more life like later on infinitely. Once you acquire that conscience, you get an atavic fear for suffering and your own premature death, which is why you are ready to do anything blindly to prevent those things, suffering and dying, to happen. And once you find out a way to disconnect from our real economy and our physical world needs, you try to abstractly live your life away from all those everyday concerns. You don't want to be attached to those. This is something we can go two opposite directions. Like I said, positively you go towards transhumanism, abandoning the animal rootsiness, because if you remove from us exhaustion, hunger, thirst, and the needs to pee and defecate, as well as removing damage done by cold and water and heat, then for removing suffering and mortality, you instantly remove all the needs of social contracts, countries, boundaries, economy, natural competitions, war, crises, everything. And it negatively goes towards private capital accumulation, polarized at the expense of the human peers. And guess what? This is happening right now, where 4 to 6 people worldwide own as much as 50% of the lowest part of the population owns. And this is exactly where we stand today, trying to do the good way while letting the bad develop up to a point, gathering to save ourselves, and our biosphere requires decades and massive negotiations. Doesn't mean that, as opposed to all that, we should soon need to start reviewing our peers on how we authorize and validate anything that anyone wants to do. Well, whether you believe it or not, what I'm trying to demonstrate through this talk is that sooner or later we won't fall under the question of our opinions. It will become mandatory. Because, as you saw, letting everyone do whatever they want with their lives and pollute and degrade and use non-renewable materials and limited resources does not fall under opinions. At some point, it's going to be someone you shouldn't be able to do until you won't be able to do, regardless of people's opinion. So what if what you call is what you call communism in conjunction with a global crowd, ultra-democratic control for the first time in history, decided in agreed directions to go, well, that will only be told by the future. As I'm concerned, because I believe some of you would like to get an answer, I believe forcing things cannot happen because of existing structures, and that we need more panic to start acting. So we are not fully in panic right now. But when we do, we may sooner or later go much more into regulations and constraints. We have been aware of all the facts that I told you about for decades, and as you saw on the graphs, absolutely nothing changed ever since then, including the Conference of Parties. Again, what matters is not the cost of the change, it is the cost of the continuation of what we're currently doing by extending it infinitely, which, may I remind you, is the worst scenario projected by the IPCC so far, the worst. So remember, when you implement or use solutions that you always need to think deep about ethics, you need to think about this. Who is it designed for? What are they going to do with it? When will they use it? How will they use it? And how much does it cost for the planet? I can give you an example of buying design. I'm currently trying to buy a house. I use real estate selling websites and aggregators. None of the first 10 websites I used offered energy performance diagnostics, which are mandatory as a selecting criteria. None. Can you believe it? I'm trying to buy a house and no website is offering me to choose anything else than house size, how many rooms, how many ground around the house, the city it's located. That's like 20 criteria, but none of them is, can you filter anything with energy performance diagnostics below or above this? This is crazy. And why is it not a criterion? Because the vast majority of houses suck and are all houses with ridiculously low grades, and because people don't care. In France, we barely renew 1,000th of a total building each year. This is why it's important to change. But how to change things if we make websites where people cannot even filter on that? And that's a simple example I was giving you. All right, so let's sum up everything about what's going on bad in our world, okay? So first, we have entered a global catastrophe, mostly made of dead ends and very few exits. Second, there's no green energy, so nothing we can do now can keep like this forever. It's going to stop very soon. Then, the world is infinite, maybe outside, but the planet we live in is finite. The materials are finite. Everything in our range is finite. And everything we can access to is in our range right now and won't be pushed until probably hundreds of years. We are way too far right now to get more materials and more planets. So growth is only virtual and finite too. We're only getting closer and closer to this asymptote. The only thing that can grow is our knowledge. But not knowing, we can increase pollutions. By ignoring facts about our use of the planet, by not being aware of the current situation, by spreading counterproductive lies. Whatever you do as a structure while thinking you can save your ass and reject accusations by over-communicating and lying about your activity, you're not solving anything. You just make everything worse, actually. The first ones that try to disguise themselves have already been pointed out publicly and shamed on for greenwashing. We know that the problems we face are going to be more and more complex. Every shot is a three-cushion one at least. Everything requires triple attention. Nothing is straightforward. Don't take information that pleases you straight away. Make a pause. And every time you read, hear, or think about something, just doubt yourself before doubting the rest of the world. Okay, right. Let's finish with a stubborn, unyielding idea that we still want to need to tackle the problem on our side, the digital world. Because there are solutions. So I broke down the solutions in 3 parts. The first part, how to act and what to do as individuals. Well, first of all things, you should review your usage and storage history. You should completely delete video, image, email history, everything, and organize them so that they don't stack up into your history, because the services are designed to keep them as long as you want them to. But you know exactly that the emails from 10 years ago with nothing on special, just notifying you about your orders of a pen, is not useful to you anymore. It's something that is retained somewhere in a database. Put them away, these things, trash them. Then delete the instant messagery and the chat history too, if you can. Limit your online shared documents. Limit your online file storage. Use the reply to instead of reply to all, because you don't want to send a reply to 15 people when you only want to notify one of them, knowing that the other one will just skip it. Disable notifications. This has a cost of energy. Then you should use bookmarks. Yes, on a mobile you can do that too, and this is a heck of super practical. You shouldn't go on a website engine for that all the time. And as you noticed, the company building the website of search engines and doing the mobile browsers is the same. So they have an interest that you use the browsers for that. So yeah, then you need to unsubscribe from everything that is fake. When you receive a mail, you don't know what it comes, just follow the unsubscribe links. Unsubscribe to everything until it goes down to 0. I have done this. I'm subscribed to 1,000 websites at least on the internet, and I receive 0 email from untrusted sources right now, and I receive down to, I think maybe down to 100 mails per week, where it used to be 1,000 if not 10,000. You can do this. Then remove all the apps you never use on all your platforms, computers, smartphones, tablets, whatever you want it to be. Deactivate your automatic cloud upload. You don't need that. You don't need to have your photo. Why did that phone go down? We don't care. No one cares about your phones, your pictures, or anything else. If you really wanted them to be saved somewhere, you would have saved them way before that. It's not the fear of having this done that is overwhelming you. You will survive. You will wake up the next day. Your life will be the same. Then just remember, if you have a chance to watch things several times, downloading them produce the same bandwidth as live streaming or live watching them, but the next time you will do this, you won't use the same amount of energy and networks. So yes, this saves some cost. So if you're designing applications that do that, you can privilege download over streaming. Then do not abuse one-to-end streaming, which is, if you want to broadcast some things, like, yes, this is exactly what I'm doing right now. I know, this is a YouTube channel, this is one-to-end. I mean, if you are to do something with that, don't abuse it. I'm thinking about removing many of the videos I've saved on YouTube for privacy, for private reasons right now. Then you should use lightweight signatures in your emails or anything else, or nothing. It's perfectly okay to have no signature. You don't look like a douchebag. You don't look like non-professional. Do not abuse file uploads and messages. Limit third-party usage for simple tasks. You don't need to use applications to do something you can just do yourself. Then limit the video usage, because as we saw, it is 1000 times more usage in bandwidth, storage, and anything than the rest. Use responsible search engines. You know what I'm talking about. Then when you need to print something, are you sure you really need to have this on paper? Do not print. And you can choose the print quality correctly, and also you can choose to print on recycled paper. It's not a joke, it exists. This paper is really easy to find. Then you should remove all the unused apps you have at work too, not only personally, but everything you don't do, everything you don't want to do in your current life cycles. Like sometimes you have applications not only installed, but in the chain of what you use. But if you remove them, your daily life is exactly the same. Then you should use live shared components instead of transferring documents through emails. If you have a document you want to edit, like a text document, a spreadsheet or whatever, you cannot have multiple people working on it, sending you their revisions and then sending your revisions while they send it. Stop. There is a live version for that, and it saves up to 80% energy doing so. Then you should entice lawmakers, manufacturers, and politicians to create longer longevity for everything, for websites, for applications, for games, for operating systems, for material, anything else. Then you should make no use of ad-based business model services. I know you're gonna have to pay for everything, but if you start paying for everything, at least you got a competition for that and not for hidden costs. Then you have to use, if you can, laptops instead of desktop computers, because desktop computers, apart from gaming or video editing or some very special purposes, consume like on the average, I would say between 300 and 600 watts, whereas a laptop, which has also limited performance, we only use barely 50 watts to 70 watts for the larger of them. It's not more than them, because think of it, we have to have it on the knees. Use high energy CPUs and architectures for normal use. Like, it's not a good thing to buy high-end CPUs for people who are just going to open Microsoft Word and read emails. You can do that totally. Then don't make videos when you got nothing else to do. If you can send the same message through text or audio, just use it. You don't need a video for that. Don't make ephemeral content. This is absolutely the absolute fucking cancer of society right now. The fleets, the lives, the stories, there's just so many things. This is the absolute gangrene of our world. If you stop using that, you might actually participating in saving the world, especially when all these things disappear. They get a chance to at least be useful, but the thing is, they don't disappear. You know, all the social networks, they keep them for an infinite number of time, you know, so do not create them. That's a permanently stored useless video all the time. Do not repost or post similar content multiple times. This means simply, if you made a story, don't make a post about your story, or a story about your post, or don't make a post to say that you posted on another network so that you have a post to say that you made a post. This is something you see very often right now, very, 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 very often. Do not do that. Do not say to everyone, do not make a notification to say, hey, I published something new. People will get to know when they got the time to. Then think before you use social media. It means sometimes, I'm using them a lot as a reader most of the time, but think before you use them, because you don't need to use them to just go to doom scrolling, you know, when you don't know what to do with your life and you just scroll until something will find your way. They are designed, very well designed, so that you stay stuck on them and use them for many, 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 many hours of useless time, you know. Engagement does not define your value. It means that you shouldn't try to desperately beg for likes, shares, and comments. And if you have content creators in your companies, you don't owe to have them, please, I want to have a report on how many likes we have on the post, otherwise you're fired. This is absolutely bonkers. If you do that, please leave your job right now. Actually, if you are a communication manager, you should leave your job too, but that's another story. Do not abuse social video sharing. which means not only like I said, the videos for yourself that you make, but also the other videos from other people. The more you share something that is meant to go viral, the more it will be played for no reason by people. And now the networks start playing things without asking. So when you just share something, you even share a video that's going to autoplay into people's lives that they don't even get to make a pause on because they don't give a fuck. But we just browse sometimes several times over it, and they will read parts of videos that you don't need to. Update your passwords and check your digital security. We talk about that. We talk about following good cybersecurity advice, because this could save a lot of energy and waste. Then, just to use now, cryptocurrencies are not cryptocurrencies, they are crypto actives, and they are not the future. The proof of work is a great algorithmic and digital concept. It brought a lot of the world, but cryptocurrencies are just like the new form of capitalism. So are NFT. This is just completely crap. It's easy to ignore these things. Just ignore these things. You don't have to do anything special about that. They are just speculative materials. If you are wondering why the world is owned by like 10 people right now, just look at the cryptocurrencies. Bitcoin is already owned by like 10% of people who have Bitcoin currency. So this is the same thing. This is just new form of capitalism. Limited your cloud-based backups. Like we said, don't, like I said, disable auto backup, certainly, but you also have to limitate what you choose to purposely backup on your cloud-based things. It is very practical, and it's designed not only to be practical, it's designed so that you cannot leave it, so that you have no way of extracting the data on it. So when you stop using that, you are literally in the shit. You don't know what to do. You are fucked up. So be careful. This is an entanglement. This is a cuffing of your possibilities, you know. Then you should shut down your devices like smartphones and stuff. Go to plane modes, silent modes. Shut down your screens when you're leaving work. Shut down anything that has an AC outlet. You could just unplug or just simply have on-off switches. That's just perfect. You should, that's more complicated. You should leave attention economics. Attention economics is the large way of what we do today to say that people have a brain, their brain is faced with time, and you need to take part of people's brains and times so that when they have nothing to do, you provide them with something to do. This is attention economics. If you're doing something this way, you should probably stop doing whatever you're doing. You are just killing the planet for no reason. And generally, you should just take a great of care of everything, because a phone that is broken is not a phone that you changed because you were a victim of planned obsolescence, but unfortunately, you're going to have to buy a new one. So if you break your phone, this is not really ecological. If you break someone else's phone, this is not too. If your kids that you love and cherish break your phone because you didn't think about removing the phone from their range, this is also against the planet, against themselves and you. So take a great care of everything. Everything you buy that is digital linked, hi-fi, Wi-Fi, a hi-fi system, amplifiers, loudspeakers, whatever you need to make music, photography, whenever you need to, smartphones, tablets, phablets, it can leave like a whole lot. I still have my 2013 Google tablet. It's working fine. Really, it's working like perfectly. And really, it doesn't have any form of system update since like, I think it was 6 years ago, and it still works perfectly. And I mean, right now I'm not asking anything from it. If it stops working, then so be it. Okay. Then you should, like I said a few slides ago, ask your governments to have something repairable and recyclable. So if you cannot recycle the smartphones, then don't buy them. If you cannot repair them, which is 50% of the time because of the battery, if you cannot change the battery, don't buy the smartphones. Websites like iFixit can estimate how you can change the smartphone batteries. If it's a bad score, you simply don't buy the smartphone. That's just how it is. Then you should better estimate your needs, so you don't buy something that is beyond your needs, so you don't buy something that will just pollute and consume more by doing nothing because you didn't need it. That's something it's actually hard to estimate, especially in a world of capitalism where everyone wants you to have the most expensive things all the time so you can display it to your people and relations. So like, yay, I'm rich. You need to go down with your needs. It's not a bad thing if you have an entry level phone, car, I don't know, door, table, whatever. It's perfectly fine as long as it looks fine. It's okay. What matters is the longevity and how much it costs to the earth. The second-hand market is cool and completely booming right now, so that's perfectly fine. You don't buy things brand new anymore. You should yourself get information about repairability of anything you use, and like I said in the first line just above, it's something you can do. And then I don't know if you know it, but everything you have that is electronic can be recycled. There are places and collect points. They make money with that. It's not your problem. You just dump whatever you were supposed to dump in the dustbins, because what you dump in the dustbins is usually going to be burnt and incinerated, which is not good at all for the planet, even though they capture the gas so you don't die. Then when you take your speech in public, like I do, if you are not moderate, you shouldn't talk at all, because you're gonna make people less likely to listen to you. When you hear specialists, you should be always like, this is a good quote, I like what I want to say, but you need to let some time cool down on that. You won't need to share it instantly after you heard it. Then you need to find courses on science topics. I'm sorry, but there's no other way to understand how the world works. You cannot be a citizen, you cannot be pretending to vote, to talk with people, and to exist into the life while being a human and knowing nothing about anything. You need to have as much science culture about anything that you can have. Spoiler, if we just all had way more than we had, I think we wouldn't be in the situation we are right now in. You need to understand how research and science work. These things are really different. They are not the same. You need to have at least some news to see what is new, brand new every day. You need to be learning a few fundamentals about energy, matter, chemistry, computing. I gave you little clues through this talk, but you need to know way much more. You need just give yourself a goal. You should learn about one science fact every week. And until you don't know one science fact every week, just try to follow things that will be way more interesting than your random YouTuber that is completely useless to the world, or any influencer. If you read something that really pleases you, that you say, yes, that's exactly what I thought, maybe you should double check it, because you're going to be very counterproductive and probably toxic if it's wrong. You should question the sources, including the ones you use, against the sources. When you find something that is true, you need to say, how do we know? Is it true? Is it a consensus? Can I prove it? Can I have some people around it? Is it within my reach to prove it or not? Etc. All right? Then, when you are working as an individual, you should not behave outside your house like you wouldn't accept at home. So if you just slam your keyboard, if you just punch your screens at work or whatever you do, if you just transport them like just hitting them against the wall when you're moving from one desk place to another, you're probably a douchebag, because you wouldn't do that with your own things. And it's not about your company being responsible for that. Just think that every time the place you work with has to change something, this is less money into your pocket. And every time they have to change something, this is something that the planet has to pay. So, like I said, shut down everything when you're done, because there's no activity in your work if you work on location. You should live closer to where you work. This is not a choice. This is something you have to as a citizen of now. I know the people just sold you for ages the opposite. It's too late. We need to go further. If you my personal boundary and reference to that is, if it takes more than 10 minutes for you to go to your job, you are not taking the good job and you are not living at a good place. That's not something you can negotiate. Wherever you live with, whatever your city, your place, if you work, if you go to work every day, of course, if you go to some place that's more than 10 minutes away, whichever transportation you use every day, you should absolutely move. you need to move your work, or you need to move your working house. It's not natural and sane to have a car that works on oil, and to do 30 minutes of transportation, 1 hour or 2 hours, some people do that, of transportation every day. This is absolutely stupid, and when you do that, you're not free, you are the opposite of free. You are putting chains on yourself. You're being a new modern slave by yourself, willingly. Also, stop buying shit hardware, because if you go from 3 to 5 years life cycle to laptop, you diminish by 30% your greenhouse effect emissions. If you do the same things for smartphones, for 1 year, you just do 1/4 emissions less. If you just go to, everyone would just move from the 20 to 70% dual SIM smartphones right now, we would reduce from 37 greenhouse emissions, which is, we are about 20% of smartphones with dual SIM right now, which is basically, if you don't know what it is, one for work and one for personal life, and the phone is paid by your work, and when you leave the work, it's up to them to say if you keep it or leave it, because no one will want to leave it after 3 or 4 years anyway, so that's good. Then, solutions for digital companies. Those are the last two parts for the people who work in the digital sector, so hold on. This is what many polls now show when it comes to employees' working conditions for companies, and this is also why they leave. As you can see, the world is changing on the other side. People think that the responsibility is better than the working conditions, and the working conditions is better than the income when it comes to choosing in the digital world where they're going to work. So if you have shitty working conditions, or your company is doing shit, people will not go with you. I mean, in the end, you will always find someone to work with you, but you will notice that the number of people attending your job offers and trying to apply for them is going to drastically reduce. This is tough. In a world collapsing, the money will stop coming in. You have to think about that. The world you were sold when you were born, or when you started your company, or inherited for your company, was a world where everything was linked to exponential infinite growth. And now you know, and you cannot say you don't know anymore, that this growth is going to stop. It's going to stop. It will stop, and there was a place that is going to stop. Not only your company at the expense of other competitive companies. I mean, the whole market you are in is going to collapse. So the money will stop coming in. When you will start firing your employees because of structural needs, you already put a hand on the doorknob for yourself. And you know the key to close is already in your hands. So what I mean is, when you're going to start firing the first people because you have less and less money, the tension is going to change, your world is going to change, your work is going to change, and your company is going to sink within the next months. In the meantime, wage increases will not be on the agenda. So make sure you pay everyone equitably and cleverly. Don't try to say who's going to pay more or whatever. You need to have that applied to the correct people, and to make sure first everyone gets a decent salary. And of course, the money leeches are out. If you have shares in your company, buy them back. Lots of companies are doing so right now. Buy them back and start keeping for your money for yourself. If you have, you have, I'd say 15 years to do that, not more. Then your shares are going to kill you, because your shareholders are going to kill you. There is going to be something that's certain. In a world where money collapses, the shareholders will be the last people we need to give money to. They will have to find work and get a decent life like everyone, instead of sucking and leeching the money where it's not coming from them activity. One of the greatest success and threats for population of capitalism is the employment market, where individuals are given the responsibility and the danger of selling themselves. This generates pollution, anxiety, suicides, pressure, and blind obedience. This is the most reason why people are keeping their job right now, the fear of losing their jobs. And you do not want to have people working with fear in your company, because if they do that, they are not really efficient. So you have to do the same thing as considering them to leave. Whether you do this our way, your way, their way, it's going to be the same. So do whatever you can to fight that. Start trusting your employees to pilot the structure along with you. They know more about your company, about your structure than you think. and make them stay. If they leave, you're also responsible. And people using the market, the employment market, are generating tons of pollutions, really. So limit your turnover and enlarge and make your onboarding better. Another great step ahead, before being able to become specialists, just start a carbon balance sheet. You see where it goes and where your chasms are. A carbon balance sheet is something you can start. The carbon accountability is not something that abstract. It requires some skills, and you will not acquire those skills like in 5 minutes. You will have many outrageously bad people trying to do that for you. Try to do that yourselves. Try to include that in the projects you produce, not like an automation. It's like a strategic value added. It seems fake and selfless, but if it is fake and selfless, you will lose. You will be greenwashing your projects for no reason. So try to be honest with that and to say we've entered and invested some money into being less polluting. And spoiler, if you pollute less, if you are less responsible for carbon emissions, you're probably going the good way, and your company will strive and survive a little more before everything collapses, if it collapses. So then you should remove everything that makes you visible on the internet based on consumption. That is a long story, but just like the companies that build smartphones require you to buy smartphones to live. Companies that offer visibility through advertising, like LinkedIn or whatever, or Twitter, require you to buy ads placements to live. So these things, they will cost less and need less advertisement if there is less content, so their servers will be less costful, and then they will need less advertisement, they will remain free, and actually by negating and denying your everyday and typical use, you will just save some time. So that means you need to publish your content to be minimal and to add value. If it's just something that you publish by it's an automatism, you're just like losing. Stop social media posts, blog posts, and publications. You can be a company with no existence on LinkedIn, or just your page is not going to be a bad thing. You will have the same power. Stop advertisements, stop reposts, stop tracking user behavior in your company. Focus on GDPR, because it's going to be ecologically efficient. When you have less tracking and less things like that, you put less things in motion, and trust me, it's really costless and cost reduction efficient for both users and maintainers and hosting people with applications when it comes to applications. So also forget about sales advertising. This is the absolute grand the yearly, if not more than yearly, grand parade or fair for capitalism, and it's not going anywhere. You don't need those periods to make money. If you make money and you are dependent on Black Friday and Christmas periods, you should really review business, because your business is bad. Then you should stop using newsletters now. We are in 2021, so stop using browsing blocking windows that say, hey, do you want to learn more? No, we don't want to, and you should stop proposing this. Stop doing newsletters. This is absolutely insanely useless. Apart from the fact that your business could be newsletters, then you have to if people register and subscribe so that you send them useful newsletters with content and work that they need to, then you are doing a useful newsletter, right? If you don't, just forget about it. Stop thinking about tools like you're decorating your cars with neons, change wheel drive, a super bass in the back, metallic paint and everything. It's just, you're just like, yeah, we're building a website, let's just add newsletters. No, you don't need them. You don't need them. When it comes to changing your habits as a structure now, you should maximize remote work. That's absolutely necessary, as you saw during the pandemic, and also a lot of people now are being used to remote work. And as we saw earlier that 70 people are working the services, and out of these 70%, people, there are at least half of them can totally work as remote. So yeah, do this. There's not something you can negotiate now. Just have remote work and people will be more efficient. We have tons and tons of studies. We know that people are more efficient when they work remotely. If you don't know, you are part of the past. Then you should get eco-friendly office because you still need that with lights, LEDs, climatizations, efficiency, isolation, structure, how it's done, walls, the placements of doors, walls, everything should be eco-friendly. There's much way you can save energy on that. You should make employees stay at work during pauses, which means they shouldn't like go back home if they travel along. They shouldn't feel the need like they go to the restaurant. So if you're attractive enough, they would stay at work and they will not consume and spend money and pollute outside in at pauses. Even though it is really important that they disconnect from work. Then don't hire distant people if you don't do 100% remote. If your if your offices are located in place A and you want to recruit someone and you ask them, are you the owner of your house? And they say, yeah, I'm the owner. And where do you live? And you got the address, and the address is like 30 to 40 minutes away from the job. You say, I'm sorry, but we don't hire people from that far. So you will need to move closer to the city or we won't be hiring you. And this is not bad. Then you should help people park, because having buildings, offices where people come with their car is not the best thing in the world, as you know now. But if they still do so and they lose 10, 15, 20 minutes by turning around the streets trying to find parking every day, this is absolutely super bad. You are discharging your work time on them. They're going to come late. If they don't want to come late, they're going to have to extend their time, become less and less useful and efficient, more tired. This is absolutely against every single thing that is logical and in favor of the planet. So the people should be coming to your work and park immediately down the building they work for, or walk the minimal distance. Then, if you have vehicles yourself, you need to buy eco-friendly vehicles, and not only because you get government tax reductions for that, but you understand now it's going to be the minimum themes, and you have also to have a park and a parking place with rechargeable stations, stuff like this, if you have vehicles. Then you should reduce all trips and forget about planes. So there used to be a time where sending your people, your human resource or your colleagues, your employees, or yourself or whoever you want it to be, to meet the customer or go to a special location or work at the customer place, etc. Everything of that needs to be stopped right now. It's the minimum thing. This is not a huge effort that you're going to provide. This is the minimum thing. Your employees should be working 1 at home, 2, if not possible, on site at during your the work times in your offices. Nowhere else. Absolutely nowhere else. If you provide people to your customer location, they should be remote working for your customers, and if not, at their customer offices for as long as it is possible. But you shouldn't sell your people just because you want to handle a difficult situation with your project, to say you're going for 1 week in that town or that town because the customer lives there. That's absolutely something stupid. You need to avoid that. Every time you will send someone somewhere, you will fail. So now you need to review your processes and you delete most of them. You ain't gonna need it, which means you have processes, there's things that were written by people with response and power, the N+2, 3, 4 people a long time ago. It's usually in the form of PDFs or written documents that no one knows about, that no one reads. And the only thing you do is protect yourself from fear with the idea that at some point your company would fail, so you have someone to point and say this is your fault and you're fired. This is just a better way to determine who you're going to fire, when the actually culprit will be yourself as a company owner. So you need to review your processes and delete most of them. You need to only keep the processes when people don't know how to do to help them. If your process is how you tell people to do things, you're not telling anyone. You're just using your hierarchy, permissions, rights, and abusing it. Then you should do a carbon footprint for yourselves, and you should follow its recommendations, like we said. You should find a way to provide public transportation. So if you have like people living in the same city, you can say, hey, you know what? Symbolically, every year we're going to buy yourself the monthly tickets or the pass to use public transportations. If you work with us, this is free. This comes for free, so we encourage that. You should incite day offs during peak weather conditions. If there is a heat wave or a cold wave, you should say to people, whatever you're going to do and however your remote conditions are, if it's like 3 days at the office and 2 days on remote work, next week's going to be tremendously low conditions. You stay at home for 5 days, and that's not something you can negotiate. You should set forced vacation during extreme weather conditions and human events, which means if at some point the weather becomes really a threat, you should send everyone back to vacation, and you should have that in the working contracts. So you don't have to use AC or strong heating during bad periods. What I mean with human events is that if for some reason your company lies in a zone where there is a national day or something or a fair or I don't know, whatever event is going to be that is going to pollute your surrounding with noise, with people in the streets, impossibility to park, and etc. You should stay away from these things, and you should have people be at home that day. I personally experienced that because I was working in a place where there was a fair, the yearly fair, with children and stuff, and for 2 days I could not park next to work. It took me up to 2 hours to find a place to finally park like 1 or 2 miles away from work. This was absolutely stupid. So then you should limit data. You should not go into the big data FOMO and the artificial intelligence or machine learning FOMO, because you will not get anything from that. Improve your margins, not your turnover. So I think this one is pretty self-explanatory. Then you need, if you provide computers and smartphones and everything, you need to run better ones. So if you buy shitty ones because they are less costing, you are wrong. It's better to have a very good computer to be rented for like 3 years that costs $2,000 than to change it every year that it costs $1,000. That's not going to be a good thing. You need to invest on the hardware you work on with. You need to require longer guarantees for the material so that it's changed for free when it's not working. You need to use hardware rotation, which means when your hardcore employees, the ones who work with the best computers, need so, and then some people just need simple basic computers. You can give them the older ones and provide the new ones only, so you have a chain of value. So the largest, the most performing machines go with the people who need them, and then the people who don't need performance can work with them later on. This is absolutely better, even if the machines consume a little more watts and more energy, it's way better if they consume like twice the energy than to have a new one being bought and manufactured. This is completely different and way more efficient. So dispatch the user, the older devices. Also, you should limit smartphones. You should let the people use them at work. You should not buy professional smartphones if you don't need so. Again, dual SIM is really good. And also stop using paper that's not recycled. If you are printing things that are just designed to be remaining inside your company, you should use recyclable paper. And finally, it's no bullshit. There are tree conservation projects, and it is true. It's working, and it's not going to save the planet. It's going to be the minimum thing we can do to make sure something, someone, somewhere is investing into that. So yeah, same goes from the non-digital things, the furniture, the materials, the desk, the chairs, everything. If you buy shit, it will just be something that is going to be shit, provide a shitty experience through a shorter life experience. So a shitty chair, for example, will last for 2 or 3 years. A good one will last up to 7-8 years of professional work every day, 8-9 hours a day. and it's going to cost 5 times more. But if you just change it 3 times faster, the difference is not that much, except that during all this time, your employees or yourself will have their butt sitting on a really bad chair that's going to harm their back, their thighs, their everything is going to be very, very counterproductive. Okay, so you're gonna actually make everyone's lives worse by doing this. So again, there's a reason why things get more expensive. It's not just for the pleasure of bragging about it, because it's really more efficient. So don't use the fact that you brought and you bought new something to the company as a brand image promotion. No one cares about the latest iPhone or Samsung or whatever device you bought. No one cares about your largest TV or the fact you got new machines or whatever. No one gives a fuck about that, or workstations or whatever. You have to provide Wi-Fi regardless of use, and has to be Wi-Fi, if possible, separated from work if you want for cybersecurity. But it's absolutely very completely stupid and absolutely bad that people who all have their own device right now within your office cannot use your Wi-Fi. You have to have Wi-Fi. It's way more efficient. Wi-Fi is so much better for the planet than the mobile networks are. Even 5G, there's no comparison with that. So whatever you do, everyone should have a public Wi-Fi that your employees can use. Then you need to have not only old bullshit air conditioning or climatization systems, but for heating and cooling, you need to have something smart and recent. This is not only for smart houses, it's also for smart offices. These things can completely change your billing and the amount of energy you use at the end of the month. I know so far it's not that more than 2 or 3% of your expenses yearly, but expect it to go up to 10 to 20% yearly, and then you will be able to notice how much you are paying more. So yeah, smart heating and stuff like that is not a bullshit. It's working, really. It's working. You should choose eco-friendly hosting when it comes to computer hosting. When I mean hosting is not, of course, hosting with hotels and stuff, but hosting for your applications on cloud and stuff, you can choose something that is eco-friendly. Again, we talked about the Greenpeace studies a few slides ago. You should use domotic installation and appliances if you can too. This is great, like intelligent lights, intelligent heating, doors, everything. You can have lots of things that can be intelligent. They require a little electronic, but the drawback is greatly compensated by the length of use if you use them for a long time. Also, you should push software updates all the time, because having older software means you're gonna have usually it's tightly linked to more consumption. So yeah, you need to have software updates, web applications, mobile apps, computers, everything, operating systems, everything all the time. So you need to locate an end-of-line pickup. If it's not something you should centralize, your company is not going to handle this if they have offices like 1,000 kilometers away from each other. Each of them should have a local pickup point, so they can put the material that's not working anymore. And if you don't know what to do with the end of life of your hardware, there's a high chance that your employees would like to get it. So let them pick up the old hardware. It might help someone somewhere. There are people in this world who have nothing, who don't even have a computer or anything, and just giving them a shitty screen and a shitty computer, as long as it can go to the internet, be connected to a network or something, this can really help people. Don't even think about throwing it to the dustbin where you don't need to. So yeah, define fair use for your apps when you do this, because if people use it too much, it's not only a matter of business, it's a matter of consumption. So pretty much like video games right now send notifications to gamers to say, hey, you've been playing for 1 hour, you should take a break. This is the same thing you should do for your apps. You've been using your app way over than the people usually do this. Okay, this is still within your contract's boundaries, but you should be considering doing something else, okay? you should inform the people about the consequences of use. You should say, okay, we're trying not to pollute, but every time you use our applications, I know you should be promoting the use of free application, but actually you should be promoting the use of free application when it answers a need. When you just fabricate the need by yourself, you are guilty and you're going against the planet. So you should tell the people what they should do or not, and you should inform them that every time they use your apps, they just pollute that much. They emit, for example, this much grams of CO2. This is something to make people be responsible. You should stop buying corporate goodies. This is absolutely stupid. There's no way. No one gives a fuck about your pens and stuff. It's just stop. Just stop. Really, you don't have to do that. The only thing you can use is reusable, useful ones. So if you were to buy, for example, drinking bottles with water and your company name in front of it, that is okay. You could just buy normal ones. That would be even better because no-name ones would be cheaper and the manufacturing process is going to be less. But if you want to keep one goodie, you have to keep this one, okay? But the posters and stuff like this is absolutely useless. No one has ever read them. No one will give a shit about them, okay? Stop making satisfaction whatever surveys. Like every time people buy from you, you want grades, you want marks, you want 0 to 10. How much was your thing? How did you evaluate your experience so that you know how to fire? Just shut the fuck up with that. Stop asking people about their opinion and feeling their experience all the time. Remove all these red, green buttons with smileys all the time. Do not use them if you are yourself a user. Every time people send you a satisfaction survey, just trash it. And then remove anything that is not operational expense, operational income based, which is when you think like you're going to be provisioning money for something, in the end, people will waste it to do something because they think it's still within the budget. And if it's not within the budget, it's going to stress people, and stress generates even more pollution. So the only way you should sell projects now or build your own projects is to say, we have that much people, resources, computers, people working on computers every day, and we have like, if you're working like a web project, you have 2 developers, 1 architect, 1 solutions architect, 1 DevOps person, and this is what you're gonna hire 3 weeks. So you say, I don't know how it's going to cost, how much. I know my needs and I know my team, so the team will tell you when it's done. That's the only thing that's gonna happen. So needless to say, you need to go agile right now. So because if you're not building seriously agile and not agile makeup or agile washing, agile in name only, you are completely lost and you're wasting money. You should disengage your customers from marketing. You should evangelize data and third-party usage removal. So that you go directly with your services. You should not aim at creating user dependency for ecosystems. It's pretty much the same thing as we saw with attention marketing a few slides ago. You should build a digital expertise within your staff. So your staff should be aware that how to involve, how to progress, and also you should have your staff, your internal staff, and yourself, if you are a leader, be really involved and aware of ecological concerns and topics. So if you want everyone to be aware of that, you should organize meetings too. And then you should monitor your energy impacts of whatever you do and the digitalization of what you do. You should share your expertise with your partners. Again, this looks like it's something you don't really care about, you don't give a fuck about. Don't worry. The world doesn't give you a fuck about what you do either. Whatever your company is, people don't give a fuck about it. And I can tell you within a few years, it's going to sink down because you won't have any activity, any energy, any material to base the whole economy on. So everything will collapse and you will collapse with it too. So it's up to you to be part of it or to keep a company or keep something running, structures running until the end of the times, or your times at least. And of course, use open source software and hardware. You don't need something closed source, because closed source means usually that you have to pay more and to waste more energy for the same thing, which is why everything is going like this. So once again, last but not the least, just remember the ecology paradox. According to acting to save towards saving energy, doesn't go against your activity. It doesn't go against your profits. But making no efforts, by doing so, everyone loses profit in the end. And when the profits go by, there is going to be a time, and I do firmly think about it, I'm convinced that there will be a time where some structures are going down, and you're going to have to handle this. And when this arrives, when this comes to you, you won't be able to handle it. You're going to have to handle a complete collapse of your structure that you own and direct, and it's going to be a disaster for you and your life. You're going to sink way further than you can, Also, because the data and artificial intelligence hype is already a boomer thing, we move to something new and quite critical. So now, being ecologically advanced and being a specialist in ecological conception is way better for your business than what used to be. And the last part, what can you do as a digital worker? And then we're done, I swear. The concept of ecological design encompasses mainly three aspects. The product life cycle assessment, the LCA, the product life cycle assessments, which is manufacturing, distribution, installation, use, and end of life, as well as considering ecological behavior of stakeholders. The product and service functionality, the use, performance, level, and duration, the measurement of environmental indicators linked in the product services like the natural resources used, water consumptions, waste generation, etc., by making sure there's no pollution, trade, or transfer, like consuming more water despite generating less direct solid waste, for instance. And this applies to us, digital workers at all levels. So you should implement less expensive solutions. We should downscale down to 0. You should try to only require servers when you need them. You should learn about caching. I make a conference on that on the same channel here. You should reduce information systems complexity. You should use profiling management, application performance management to see where your application is going down, and you should work on it. You should not just look at it with monitoring whiteboards. You say, oh, this application is really going down. This query is taking some time. That's good. You should be working on optimizing it as much as we can. You should check algorithms greediness, check database greediness over engineering. You should avoid the sessions and cookies as much as possible because they prevent caching and they make data storage. You should use transfer compression, like gzipping everything when you can. You should prefer information structure on-premise tracking to cloud tracking, which means you should do the tracking yourself. You should, on the other side, prefer large cloud hosting with good marks to old school information as service and hosting yourself. Good for your sovereignty of data, but bad for environment usually. You should compress assets when you are using images and including videos. You should use vectorable assets because the same simple image in SVG is way better than a complete PNG, and a PDF can be way better than a Word document, etc., etc. You should lazy load assets, so you should make sure people don't get to load things from your website and applications if they don't need them. You should remove dead committed codes. You should not use autocomplete. I know it's convenient, but convenience has a price. You should maximize static serving over dynamic serving, like you should generate files that are just cached or used for some time. Implement scheduled server shutdown and start. Yes, if your company has a service, you can say, that's new, our services work from 8 in the morning to 8 in the evening, and then they will be shut down. They'll be shut down. That's just not outside working B2B hours. That's just, if there's just less than 0.05% people on this website, why would you keep the servers light on? Just turn them off, and you need to turn them on later when you start restarting your day. You should allow eco-friendly versions and choice. Think about the google.com search engine main page is reduced to the strict minimum. You should update frameworks, libraries, languages. You should remove useless functionalities. Pay attention to event-driven development. When people in your developer team want to say, I want to try this new technology, and they fail at it, so it takes more time. It's not the good moment to learn about things and the good way to do so. Massively adopt, as I say, agile software developments, and no, you are not agile. Whatever you are, whoever you are, I can tell you, you are not agile. 1/3 of the companies worldwide are pretending to be doing agile development, and of this 1/3, I would say a third of this 1/3, which is a ninth of the total people, are really aware of what agile software development is. So yeah, don't insert rich content. Think REST for the web. REST means you use responsible web design plus server-side modulations and component, and actually this is by far the most ecological design of doing websites. This only applies for websites. Don't trigger notifications, newsletter, and GDPR. That is not yours also, so you don't need to do that. When you do things, applications and websites, mostly mobile applications, don't use autoplay. Make sure you understand the standard and open solutions, the cables, the protocols, whatever you want it to be. Include ecology metrics in your quotes. So you say, if you work with us, your applications will have this ecological imprints. Stop using single page applications for light websites with less than 10 page views, because if you don't have if you don't have a very large audience and a very high traffic density, if you don't have a lot of page views and returning people, then you have probably designed the architecture wrong, and this goes towards CV-driven development. Stop using large frameworks with massively imports for small applications. You can do that with simpler things. Double check the needs versus use of each action. So you should question everyone. When the customer asks you to do something, say, I need to understand fully what I'm doing this, and I need to understand the added value, because the data proves that every day, every year, every month, there are thousands of things that are done by people who order them to be done and who are actually completely forgotten in the end, like I said about myself a few slides ago, and this is not good. So if you don't know where to start, you should make a team, gather data on CPU, RAM, network usage, visits, cross all data with number of calls, impressions for web, etc. Even you can head up to referentials. Most of them will provide data to help structure reports, calculation and methodology. But so far, considering how estimates are extremely hard for everyone, you will just receive different metrics from all providers you can use, like local machines, employees, servers, networks, providers, computing, energy reports, cloud computing, whatever. Just be aware that financial costs won't reflect carbon emissions, so everything will be a challenge. The ISO 14064 is the international standard as a reference when it comes to greenhouse gas emissions reporting it. It was created to standardize practices and certify the results. It can build upon accounting methodologies below. Yes, you can receive official accreditation, which you don't use, and you don't need to. But the bilan carbon, the carbon accounting, is the French accounting methodology compliant with ISO 14064. This methodology was created by the French Agency for Ecological Transitions, the ADEME. The greenhouse gas protocol that we discussed about a few slides ago was created by the World Resources Institute and the World Business Council for Sustainable Development. The GHG protocol works with non-government organizations and governments to build a credible and efficient greenhouse effects accounting methodology. And by the way, Microsoft starting putting a carbon calculator for its applications, and it runs on Microsoft BI Pro, of course. So whoever you are, working in the digital sector, in the end, you need to find allies. You need to start something. Remember, nothing is what we did now. So good news, you probably cannot do worse unless you start using oil-based servers or coal to warm your office, which I doubt people will like. And as we saw in the end, we can't be in favor of suppressing the old world and making it work at the same time. So some of us, if not all of us, will have to choose. Oh, and one last word about digital worker accessibility and quality often rhyme with sustainability and eco-friendly. No joke. Read accessibility referentials, same for quality. If you work on web, you have to read UpQuest recommendation. You want to start on eco-design. There's a great book named Écoception Web, les 115 bonnes pratiques. Yeah, it's in French, sorry, I can auto-translate it. If you want to have a high mind on green IT, just go for Green IT Alliance and stuff. People are starting to gather and do something. Remember, the Energy Star program, you remember, was born in 1992. All those things that the Energy Star logo and the BIOS of any booting up system, you remember that. I will finish with a few lighter words to soothe you and let you on a positive note. I like this part of the poem from British poet Alfred Lord Tennyson that you might remember from arguably one of the best scenes in all James Bond movies ever. And if so, I just wanted to know I love you. This little part is a part of a longer poem that is the definition of motivation, resilience without fatality, and how about to stand up whatever you've done before. If you cannot read, I'll just read for you. Though much is taken, much abides, and though we are not now that strength in which in all day moves earth and heaven, that which we are, one equal temper of heroic hearts, made weak by time and fate, but strong in will to strive, to seek, to find, and not to yield. And I thought this was a good way to finish on a good quote. If you look at this very famous picture, you will see the real Avengers with Tony Stark here in the middle. Except these people really existed and laid the foundations on many things we are able to do today. Einstein, Curie, Schrödinger, Planck, Henriot, Pauli, Heisenberg, Bohr, Lorentz, Langevin, and so many more amazing names. Those people were all way ahead of their times. I don't think there's a place somewhere in our world where we can fit the new Avengers. I already have some names to put on the list, but I even got no idea how far the list can go. One very last thing before we end this long conference, this is the time for us to go down. I'll always remember how accurate a great drawing can be and how faster it can be, how much faster it can be to explain things than words when it comes to telling everything. I'll always remember this drawing from a French cartoonist named André Franquin in 1977, who's died right now. This is the inside cover of a dark humor book named Last Laugh. And it pictures a couple of somehow an exploded fragment of Earth. The guy says, "Don't worry, honey, I'm here. I'm sure we're breathing a little harder than a few minutes ago, but they are certainly going to organize something. Each day has enough trouble of its own and it's starting to get colder. Let's go back inside, sleep on it." While you understand that the Earth exploded and they are going to miss oxygen and die perfectly alone in the next minutes. This highly depressive comic perfectly demonstrates how we could feel right now, because that is the first emotion that a normal being would feel. The feeling that you might have now has a name, and it's a neologism called solastalgia. The emotional or existential distress caused by environmental change. We might be tempted to fall under the unhappy consciousness as described by philosophers George Hegel or Benjamin Fontaine and many others, in different ways and perspectives. The somehow paradoxical depression from being particularly aware of the situation we're in, the challenges we're facing on one side, and our incapacity in changing anything on the other side. But you shouldn't let that feeling overwhelm you. The half good news I can tell you is that we currently don't have enough power to destroy Earth, not enough power to destroy its surface, and we don't have enough material to really go to war too long. And there's absolutely no calculations and forecasts where all life on Earth's biosphere dies, not even all of us. It's probably going to be challenging and a very hard one, but it doesn't have to be apocalyptic. And by the way, I keep telling every day that our world, in the way we organize human metrics to measure development, is going better and better. But this is not really visible if you live in so-called developed countries. I've talked about the world mostly through a keyhole, which is actually a whole door of physics and digital. But as I say, if you also handle the results of this use of physics in a really bad way, you can worsen the world you create. Fortunately, we do not. On many of our metrics, education, women treatment, justice, equality, extreme poverty, etc., I know. It looks hard to believe, but you trusted me so far, so you can trust Hans and Ola Rosling on their brilliant talk. They did it many times also with TED to tell you more. If you have the time now, this conference, you have to see it. You should definitely check it out. You'll smile a lot as well. The link is in the end of the sources. It's called How Not to Be Ignorant About the World. There is, and there has been for quite a time around, an idea that we called the hummingbird legend. It comes from an American Indian legends. It persisted through the ages and tells a simple story. A story that says, once there was a huge fire in the forest, and all the animals were fleeing away, until they reached a river bank. But one hummingbird took a few droplets of water from the closest river and dropped them into the immense fire over and over. One animal asks, "What do you think you're doing? You're so tiny and fragile, you're going to burn as well." And the hummingbird answered, "I'm just doing my part, what I can." See, I don't read a lot of books. As you see, I'm quite a busy person, and I only read complex books of scientific topics. And I find myself too easily influenced, so I'm trying to think by myself, which is the hardest possible way of thinking. But I sometimes stumble on quotes that I like to, because they sum up great ideas. In 2009, a French philosopher and poet named Edouard Glissant came with this sentence that I really use a lot. Act within your place, think with the world, which is my personal translation. And I do think that's what I'm trying to do. I change my habits little by little. We all know that that's just an old story, and we know it doesn't work. That we need to fully reconsider the way we build our civilization. I stopped eating cow meat, trying to go vegan. I'm not here yet, but I'm slowing down. I canceled my sports car dream. The next one will be a mixed energy, used one, probably not brand new. I've been trying to buy a house for years now, and its greenhouse gas emission performance is one of my top criteria when it comes to selections. I divided by 1.3 my electrical consumptions in 10 years thanks to better computing monitors, undying LED lighting. I changed my smartphone at least every 4 years, hoping to reach 6, even though it's harder now. I cleaned all email and not subscribed from everything. My trash email address receives close to 0 spam and unsolicited email per day. I now sort my household waste as much as I can, much better than I used to do. Actually, I think now 19 to 90% of my household is recycled and sorted correctly. It doesn't do much, but I do find new ideas every day. What about you? What do you have in mind right now? See, the hardest thing we need to understand now is that we won't solve everything with substitute. We know that already. And yeah, I'm sorry you all have that ending theme from Game of Thrones stuck in your head now. We know that we won't be able to replace the current world and its pollution and exhaustion with another one, a new one. We know that we'll need to reconsider how we live and how we go further, because yeah, we will go further. We're not stopping here. I still have plenty of things to tell you about the extraordinary, magnificent, breathtaking things we're also currently doing at this time, during that extraordinary era. You probably have no idea what we're succeeding in right now as I talk. I barely do, let's be honest. We're beginning to understand our universe, how it started, where it's going. We made ancient particles re-exist again. We have this which had disappeared since the primordial universe. We started investigating on what we think is non-baryonic dark matter and dark energy, what we cannot perceive, not interact with. We're starting to study black holes. We just found matter on Earth way older than Earth itself. We detected and validated Einstein's 1916 gravitational waves existence, oscillations in curvatures of space-time. This is where we stand, at the stammering of our knowledge, at the dawn of our reinvention. We are barely the prehistoric era for the humans of the next century. We need to face our mistakes and reorganize our civilization. And we always should have done this, collectively under mutual aid, except now we might not postpone this action furthermore. This is why we stand here. Here at what I called the edge of the world. At world's edge. That world for which, as I always say, we have backup servers, but we have no backup planets. And here are the most references that were used to construct this conference. Please note, some images are subject to copyright, and I keep them at disposal if needed, of course. You just need to pause the video if you just want to get them now. I'll put the slides on sharing platforms. Yeah, I had some work to do in order to create 2 3-hour conference into one like this one. I had to work for 6 months. When looking at the calendar, it's over 200 hours of work to assemble this and produce this, which is far from perfect. And as you can guess, this is not an easy topic and it requires a lot of work. And here's the last part of those resources. I hope it remains readable for you all. Whatever we reached the end of this conference for now, I am quite relieved now because sourcing, assembling, understanding everything that's within this conference took me over 6 months. In order to do that, I was alone, which, as you can imagine, means I needed quite a lot of motivation. Now, you understood that the absolute best thing to do before everything else is to help everyone to be informed, which is why I will encourage you to share all this. And if you don't want to share my conference, just make yours. You have a place to start now. Now, you also have a part of our collective digital and therefore physical responsibility. I am more than satisfied, happy and soothed that you were still there, that you took your precious time and unique given living time to watch all this, that we shared together this fugitive fraction of time, that the atoms that make us took some time to consider the atoms that they need to exist and persist. Like Carl Sagan once said, on a mote of dust suspending in a sunbeam. From the Earthling that walks the same planet as you do, I thank you for your attention, and I hope to see you in the cosmos.